semiconductor market is projected to touch $1 trillion by 2030, and India is determined to capture a meaningful share of that future. The Ministry of Education is fully committed to meet the requirement of skilled professionals with technology transformation to ensure young minds are equipped to lead this transformation. The Government of India is taking a comprehensive, collaborative approach to meet this growing demand. Global partners such as IBM, Purdue University, and with countries including United States of America, Japan, Singapore, and the European Union. These collaborations are strengthening supply chains, expanding training opportunities, and ensuring is prepared to meet the global standards. Our true advantage is our youth. With a median age of just 28.8 years, India has the world's youngest workforce. By 2026, we'll produce 5,000 highly skilled professionals in semiconductors. Close to 10 million students in STEM pipeline, more than 1,300 universities and 52,000 colleges, and a thriving startup ecosystem. India is not only producing talent at scale, but also building the innovation landscape that is global and which is what the semiconductor industry requires. On the academic front, the Ministry of Education, through its autonomous body AICTE, redesigned the higher education curriculum, which will help us to meet the workforce demand in semiconductor-focused courses, with more than 550 institutions already offering these programs from this academic year. In a few years from now, thousands of engineers in the field would be available to the industry. The minor curriculum in VLSI will aid in honing the skills of engineering the domains. This alignment of education with industry is perhaps one of the most significant reforms in shaping India's semiconductor future. The results are already visible. More than 280 institutes and 70 startups are supported today with electronic design automation tools. India runs the world's largest EDA tool support program with 10 million student usage hours logged this year alone. And our ambition does not stop here. The CHIPS to Startup and DLI programs under MIGHTY are preparing 85,000 design engineers. Also, the LAM Research ISM IISc Semiverse virtual platform is training 60,000 students in advanced chip design. Under the Skilled Manpower Advanced Research and Training program of NIDEP, we aim to skill 100,000 engineers in semiconductor technologies. Semiconductor innovation in our premier institutions have been the vehicle for sustained growth of semiconductor ecosystem. Years, our institutes have been translational research that eventually ends up in products. Several fabled startups such as Agya Vision, which has been incubated in IISc Bangalore, Encore Semiconductors, Mind Group Technologies, the two have been incubated in IIT Madras, Visit Networks, Green PNU Semiconductors, Lemon Chick Semiconductors, Smart Coach Technologies, which have been incubated in IIT Hyderabad in the recent past, are a few notable examples. In the nano fabrication area, our academic fabs are performing at par with the world. Apart from their training activities in India, Nano User Program that is funded by MIGHTY, the pressure sensors developed at Sensi, IISc are being used in space missions at HAL. The explosive detectors based on nanotechnology developed by IIT Bombay are being deployed at various high security sites. The semiconductor manufacturing R&D is further spearheaded by centers of excellence in nanoelectronics housed in IISc and 6 IITs, creating a network of institutions jointly supported by MIGHTY DST using the MOE institutional platform. These labs develop semiconductor technologies spanning various domains with significant engagement with industries like Synopsys, Applied Materials, Global Foundries, IBM, Seagate, Texas Instruments, Horiba, Tokyo Electric, Intel, Tata Cairns, and many others. The industry-academia research synergy enables India to rank in the top 10 countries for research publication in this field globally. The robust research ecosystem that has led to innovation resulting in pioneering technology-focused startups beyond the more popular integrated circuit design startups. These startups target application domains like AI, defense and space, security, health tech, energy, and agrotech. Soil Sense and Matter Wave at IIT Bombay, Agnit and Path Shodh at IISc Bangalore are some of the notable examples of startups from MOE's premier education institutions, which have traversed in the field of silicon-based and powered transistors, neuromorphic technologies, GaN-based radio frequency, sensor technologies, etc. Similarly, IIT Madras and IIT Kanpur are doing pioneering work in the field of photonics technologies and advanced transistor modeling respectively. With the mushrooming of research and innovation leading to startups, India is in the right path. Under the aegis of MOE, an international collaborative workforce development program for semiconductor manufacturing is being run by IIT Madras, IIT Hyderabad, in collaboration with Purdue University. Under this program, students from semiconductor-related disciplines across India are handpicked, are given an initial hands-on training at IIT Hyderabad, and a select few are given advanced training at Purdue University. More importantly, as a result of this collaboration, a Center of Excellence on Semiconductors is announced by Purdue University in collaboration with IIT Hyderabad. The challenge is to partner and compete with top talent powerhouse like China and Korea, Taiwan and US. The ISM-related roadmap specifies that India needs about 5,000 globally top researchers. This requires a significant increase in the high-end talent development by 5 times, especially through growth in high-end semiconductor R&D infrastructure and industry-related cutting-edge technology experience. MOE has created the Development of Semiconductor Eco Talent Committee under IIT Bombay's leadership to implement this vision. Ladies and gentlemen, this is more than a skills program. This is a national mission. It is about creating the foundation for India's technological future. It is about building capacity, capability, and confidence. And it is about giving our young people the tools to shape not just India's semiconductor story, but the future of global technology. In closing, let me reaffirm the Ministry of Education stands shoulder to shoulder with the Ministry of IT, industry partners, and academia, determined to ensure that India not only meets its domestic workforce requirements, but emerges as the global talent capital for semiconductors. The future belongs to our youth, and together we'll power the world. Thank you, Jai Hind.
Well, ladies and gentlemen, Dr. Vinit Joshi has shared his vision for aligning education and skilling ecosystems with India's rapidly growing semiconductor mission. And thank you, sir, for setting the tone with your inspiring and strategic perspectives on workforce development in the high-tech sector. We now move on to the first panel discussion. But prior to that, the most important issue on workforce development will be addressed in this panel discussion. But before the panel discussion, we have a seasoned professional with over 25 years in development and tech education. She serves as Vice President, Workforce Development and Initiatives at SEMI. She drives initiative addressing workforce needs for SEMI's 3,500 plus member companies. So please put your hands together and let's welcome Shari Lees onto the stage, madam. Yes. Under her leadership, SEMI has launched national and international programs which would enhance the industry's image and attract dedicated to shaping the future of tech education. It's all yours. Over to you. Yeah.
Hello, everybody. Yes, my name is Shari Liss. I'm the Vice President for Global Workforce Development for SEMI. I was asked to just speak for a few minutes today to sort of set the global stage, what we're looking at with respect to workforce development, why this is an area critically important to the industry, what are the challenges, and how we're addressing them at SEMI. So SEMI is a trade association with over 3,500 companies on a global scale. We're looking to help all of our companies create pipelines into their companies, into their work through job placement opportunities. So I oversee the SEMI Foundation. I also oversee SEMI University, and of course, all of our global regions with respect to workforce development. We've discovered that we need, across the globe, about 1.5 million new workers in the next handful of years in our industry. 1.5 million people in an industry that still isn't a common household name in most of the world. The reason this matters, and one of the slides that I like to showcase why this matters so much, is this one. If we look at this slide, now everybody in this room is familiar with this industry, but if we look at these slides and we look at these circles, there are a number of areas that are critically important to this industry. Electronics and semiconductors and testing and packaging, all of these pieces matter, as we know, and of course, design. When we look at the companies that fall in each of these rings, these are all SEMI member companies, and they all contribute to this broader semiconductor microelectronics ecosystem. So why am I showing this to you around a workforce development solution? Well, I'm going to show you right now. I bet everybody in this room, maybe everybody in the world, can tell me what that logo is. Right? Everybody recognizes it, lots of nods in the audience. I could talk to fourth graders. I could talk to high school students. I could talk to university students. Everybody knows that. But when I ask them how an Apple product runs, and we look at all of the companies that create that product in the end, most of my students, most of the people we work with, most of the job seekers, the veterans, the women returning to work, don't necessarily know all of those companies. We need to uncover all of the work that goes on across this fuller ecosystem so that we can fill the roles needed in all of our companies. So although we're all can acknowledge the most outermost rim, we need to know all the undercover rims as well. So this is something that we try to do through our workforce development work, is illuminate all the different components, all the different pieces that go into this work to make these products that we use every day. To pretty much run everything that our world is using right now, our products are the most critical. But if we don't know all the layers, it makes it harder to recruit for that 1.5 million people that we need. So when we talk about a global talent shortage, you can see here, this is broken down, this pie chart is broken down into our 8 global regions where SEMI is currently operating. These are the numbers of expected workers needed in the next 3 to 4 years across the globe. These numbers are really agile. They change all the time. Every time a new announcement is made, a new investment is made, a new fab is built, it impacts the fuller ecosystem with the numbers. But when we collectively look at this picture, we're looking at a 1.5 million person deficit in this industry unless we change some stuff up about how we recruit our students, about how we do outreach, about how we intrigue people to this industry, about how we make semiconductors exciting and interesting and engaging for students. So this tells a really strong story. We have to recruit a lot of people over the next handful of years, and I believe our panel will dig into some of the how, but today I kind of wanted to paint this starting picture. In India alone, the current estimate is 85,000 new workers needed in the next few years. And again, it will depend on investments made. It will depend on what happens on the ground here, but that's the current expectation. We know that we need to align academia to industry. We know we need to make sure that what's being taught is what's being needed in our industry. So we need to open up conversations between those two worlds. We also know that every region that we work with has different strengths and different gaps in their learning and in their training opportunities. So here, design is an incredible strength. You're actually training people for the globe. incredible. But there's areas where there's going to need to be growth. I've been requested to do K-12 programs. I've been requested to do apprenticeship programs here. There's ways that we can help support as SEMI in partnering with many of you in this room. So when we talk about challenges, the invisibility of the industry, that multi-layered thing that I just showed you on that circle slide, oval slide, is one of the most critical. But we're also talking about an aging population that's in this industry. I heard the other speaker say that there's a younger contingent here, which is fabulous. But our industry, on a whole, the average age is above 50. It's actually 58 right now. So we need young people to come in. We need to align that curriculum with all the technologies that continue to grow more quickly than most universities have been able to keep up with around the world. Not all of them. Some are doing an incredible job, but we also need to ramp that up. We're looking about creating pathways to hire. We want to create as many opportunities as possible for the people that are engaged. In addition to that, we dig into the work at SEMI. We try to talk to the student populations across the globe. We do a lot of research into what students are looking for, what people who are looking into their next careers, what are they excited or interested in learning, what do they want to see, and where do they want to land. And if you look at this list, I will not read it all to you, but these are what rise as the most critical pieces when we talk to students around the globe. So although diversity, equity, inclusion may not seem as critical to everybody, it is one of the most important parts when we talk about recruiting from a broader ecosystem. If you look around this room even, if you look around any SEMICON show, if you look at the companies, it is still predominantly a male-dominated industry. I'm fighting it, as you can tell. But we have to make changes, right? We need to, thank you, yes, there's more of us, but we need to make some changes. But the diversity, equity, inclusion is critical because when we talk to students, what they want is to feel like they belong in an industry. We have to make it a place where people want to be part of this. So that is the number one thing that comes up no matter where I am in the globe, which is a pretty remarkable thing. But they also want sustainability practices, transparency, coaching. They want to they can grow and paths where they can grow in this industry. They want to know they can make an impact in this work. They want to feel trusted. They want to be able to get feedback and provide feedback. These are the most critical pieces that we hear from students all the time. And as an industry, we need to rise to that. If we're going to fill that 1.5 million person deficit over the next few years, we have to address what workers are also looking for. We have to make room for that. So this is my last slide, but I will say, so at SEMI, what do we do around workforce? So I say I oversee all of our workforce programs. We're an association, 3,500 plus companies. Every single one of those companies does an incredible job doing their own outreach, their own recruiting, their own workforce programming. But we as an association try to approach it from a different angle. What can we build to support the broader industry? What kinds of programs? And we think about it holistically. We think about it from the 7-year-olds, capturing people's attention when they're really little, the little kids, and then growing that until we can upskill and reskill. I don't have time today to address all the programs that we do at SEMI, but I'm just going to highlight a couple and then I will announce the panel. But we're currently working actively with more than 500 of our companies, our member companies, to actually implement programs on behalf of their needs. Meaning, they come to us, they say, we're struggling hiring technicians, we're struggling hiring design engineers, we're struggling hiring chemical engineers, whatever the need is, and we try to address that through our programs. This is a list of our programs. Our website has all of the information you could possibly want. But I will say that we have programs where we put kits into the hands of 7- and 8-year-old kids with curriculum for educators. We have programs that you can learn online through our semi-university system. We have programs where we're doing apprenticeships and earn and learn, meaning you get paid while you're learning before you even enter the floor of a fab. But we're trying to build all of these programs so that we can meet the broader need, trying to support the industry on a grand scale so that we can meet the numbers that I was talking about. But all of these things matter. We're now being asked to develop certifications on behalf of training programs, so we'll be working in that space throughout 2026. But this is just a glimpse at what we're trying to do to address this challenge, and hopefully I'll have an opportunity to share some more when I'm on stage with the panel as well. But I wanted to just at least give you kind of a sense of why, from a global perspective, this becomes such a critical need. This is raised at every event, at every SEMICON show, at every show that we do with SEMI. It's like the most visible challenge that we have with the industry. How do we keep the talent flowing? to meet the growth. Yes, AI is impacting, everything's growing faster and faster, and how do we get there? It's through all of these programs and in partnerships across the globe. We're going to need to all work together to do this. So thank you so much for the time, and I appreciate the listen, and thank you.
Thank you. Please be seated. Take your point. Thank you, Sharilis, for your great insights. Well, this particular session will be moderated by Professor Manoj Chaudhary ji. I would request Professor Manoj Chaudhary, the founding Vice Chancellor of Gati Shakti Vishwavidyalaya, to kindly come over. Put your hands together, ladies and gentlemen, for Professor Manoj Chaudhary, and has held several important positions, and more importantly, has won several awards. Most influential Vice Chancellor, has 31 granted patents in USA, Korea, European Union. Hearty welcome, sir. Yeah. And the esteemed panelists consist of Professor Rajat Moona, the director of IIT Gandhinagar. Yeah, let's give a round of applause for Professor Moona. He's also a recipient of several prestigious honors in terms of Vasvik Techno-Visionary Award, National Award of the Election India, and he has played a pivotal role in developing key national interests activities such as smart card, driving license, and so on. Hearty welcome to you, Professor Rajat Moona. Dr. M.M. Tripathi, the Director General of National Electronics and Information Technology. He also serves as the Chancellor of Nillet deemed to be university, and of course, has got more than 3 decades of professional experience. He has also led collaborations in the international arena. Hearty welcome to you, Dr. M.M. Tripathi ji. We just got a message from the other panelists, Dr. Udayan Ganguly, Professor in charge of CEMICS, and as we are all aware, because of the arrival of the Honorable Prime Minister, he may be, hopefully the security guys will allow him to come. So in his absence, yeah, let's give him a round of applause, Dr. Udayan. And I would also like to call upon Dr. S.D. Sudarshan, the Executive Director of C-DAC. Prior to joining C-DAC Bengaluru as Executive Director, he was associated with ABB Corporate Research and several other organizations. And under his leadership, Bengaluru has rapidly evolved as a technology hub. Hearty welcome to you and Suswagata Nivige. And finally, Mr. Rene Cortes, the Head of Quality CG Power. Mr. Rene Cortes, I think he's also probably going to join us in a short while, who is also the Associate Vice President at Quality. So welcoming once again all the panelists, and I would straight away hand over the session to Professor Manoj Chaudhary ji. It's all yours. Take it away.
Hello, can you hear me? Yeah, thank you. Good morning. Firstly, I want to thank the organizers for such an important panel. As we know, India, the vibrant democracy where we do everything of the people, for the people, by the people. Semiconductor industry is also the same. That is, we are developing semiconductors for the people, and we are looking to do it by the people. So if we look at the semiconductor industry, as we know, it has 2 important aspects. It was highlighted yesterday by Honorable Prime Minister. It was highlighted by the Union Minister, Ashwini Vaishnav-ji. This morning, the Secretary Higher Education and Sherry also highlighted. Semiconductor industry is not merely a capital-intensive industry. It is also talent-intensive industry. And as high are the entry barrier to semiconductor industry in terms of capital, similarly, the talent is also one of the very, very big entry barrier. And if we were to succeed in the semiconductor industry, it is a talent pipeline that needs very deep expertise in various areas. And I believe that is why we have a dedicated session on workforce development. So to begin with, as we all know, last 3.5 years back, since the launch of the India Semiconductor Mission, several things have progressed in the country very well, apart from 10 units that have been set up. Yesterday we discussed about how the students-led chip manufacturing has happened. We also discussed at how the first chip is likely to come up. Along with the India Semiconductor Mission, one thing that was also announced was, as Sherry also highlighted, the need of 85,000 trained manpower in the semiconductor sector, and what country will do in a coordinated manner to help that. And there are several government support systems and schemes that were announced. So to begin with, would like to understand from our panelists, in their opinion, in last 3.5 years, how we have progressed in our goal that we have set up. And in particular, are there any challenges that we are foreseeing or we are currently experiencing with respect to the support that is available to us, and what do it? So I'll start with Professor Muna. In terms of our goals of 85,000 manpower, on how we have started, where do you think we are, and in particularly, what do we think that we should do more? You can use this one.
Yeah, okay. Yeah. Thank you, Professor Manoj. Let me first of all say this, a beautiful presentation which was put by Sherry, which talked about what is the demand and all that. 1.5 million people worldwide needed in semiconductor is not a very small number. And added to that, while Sherry actually talked about some 85,000 semiconductor professionals needed in the country, our estimate is probably more than that, and the reason for that is what Sherry actually talked about is semiconductor professionals in the country. But then if you look at the semiconductor professionals in the world, where are they going to come from? 1.5 million people, I mean, this is not a small number. And to a large extent, a lot of Indians will actually go and work offshore, and that's what has been happening, for example, in IT industry and various other places. Our numbers, estimated numbers, if we take everything together, turns out to be almost close to 300,000. 300,000 Indians will be needed, maybe out of which about 100,000 will be in India. Now, that number is astonishingly high, and all this can only be done through academic institutions. I mean, there is no other method right now. I just go back and look at what was done in IT. There are several other initiatives which were created. Initiatives like, IT industry actually grew not because of IITs, but because of the computer science programs created almost everywhere in the country. Whether it was MSc program or MCA program or BTech program or BE program and all that put together, I think numbers actually came from there. In a similar way, the numbers have to grow exactly in the similar way. And in fact, the rate at which semiconductors are growing in this country, all our numbers probably will go off rail and demand maybe even more. Now, having said that, it is important that for us to realize that like in our curriculums, which are centric around computing, we should also bring another center of curriculum, which is hardware training. Right in the school education to all the way college education, we should actually be able to teach our students doing things as much as, for example, designing a small microcontroller or microprocessor in a school. If we actually do this right in the middle school and high school, we should be able to teach them how to make a microprocessor. And then as they come in, they probably, this particular thing will start getting rolling. People will start getting convinced about hardware, and that hardware is not a difficult thing. Now, having said that, at IIT Gandhinagar, that's where I come from, we introduced 2 years back program on ICDT, which is IC Design and Manufacturing Technology cross-disciplinary program between computer science, electrical engineering, and material science. And the aim is to actually handle all aspects of semiconductors, devices, materials, modeling, design, and processes. All this put together encapsulated, we actually have started this program, and this program is very much liked by students. It's one of the preference of students, to take into this program. I'm sure in time to come, we will be able to contribute into these numbers. At the same time, we have also introduced a scheme called Samarth, which is basically with Gujarat government. And under this scheme, the students of electrical and computer science will go through training program at various spoke organizations, and out of that, some of them will actually, some better performing ones will be selected, and they will come at the hub, which is at IIT Gandhinagar, for training on the actual machines and design and such kind of things. I think we are just about to launch that program. Thank you very much.
Thank you, Professor Muna, and very nicely said that our goal is not 85,000, but to really look at entire 1.5 million workforce requirement and what our country can do. So thank you so much for that. While higher education and research is absolutely essential and needed for the cutting-edge semiconductor sector, skilling a vast number of people is also very important, and that is why we have a significant focus on Skill India, and even in our budget this year, the significant focus on skilling. Professor Tripathi, NILIT conducts several programs all over the country, apart from regular degree programs, also large number of skilling programs. Would you like to highlight some of them, and what is your experience so far in doing that?
Thank you, Professor Chaudhary. See, NILIT, I'll introduce first, is the skilling arm of the Ministry of Electronics and Information Technology in India, and with very focused skilling in the IT and electronics domain. We skill around 1 million every year, so it's a huge number. And all the programs are aligned with the National Skill Qualification Framework of the country. We have spread out 56 centers across the country, and supported by some of the education which is available in the virtual mode. A major portion of this skilling is also related to electronics, primarily on semiconductor design part, and other electronics design, embedded systems, VLSI design, and other electronics technology. And recently we started the skilling programs in the manufacturing also. But important thing is that we are working to build a ecosystem within the organization. Recently we started a deemed to be university with 12 campuses across the country. And most of the centers are situated in the tier 2, tier 3 cities, northeast, Jammu and Kashmir, and like locations which are most disadvantaged location. So that way, by design, we are very much inclusive. These university programs are offering BTech, MTech, and PhD programs. So we admitted this year, first time, the students. And we got very good response also. But the focus of the university, this university is a little bit more aligned with the industry. And focus is the student should be skilled in such a fashion that they should be able to develop the products in these domains. So from the very early stage, we started working with the industry. We invited industry to participate in the curriculum development, and many industries have responded very nicely. Like we have agreement with Tata Electronics. Government has given us 10-acre land near Tata Electronics plant, which is coming up, and we are building a campus and center of excellence in advanced packaging. And this campus will be completely focused on the OSAT technology. So create a very specialized manpower for a particular segment. Similarly, our 2 master's programs are supported by Infineon, and many in IT domain also from the industry. So we are working on the high end of the skilling also, where engineers will be required to the semiconductor industry especially through university, and our existing skilling programs and certification programs, which is available not only to higher education institution but the school education also. So if you see, NILET has a complete ecosystem of skilling where we have a skilling program ranging from school students to up to the PhD level. And there is a progression, and within the system we have allowed the multiple entry and exit system. You can move from the formal education to the non-formal education and come back. So that kind of ecosystem we have developed. And to support this at mass scale, because what is requirement, if you look at the numbers, you need the quality education in large numbers. So addressing two things is a very, very difficult thing. So to support this, we are coming up with a very unique digital platform where we have integrated all our initiatives taken earlier. For example, we have a smart lab under Chip to Startup program in Calicut. And we have developed 11 programs of 2 credits, 65 hours, jointly with ARM and other companies, where we are training 1 lakh students in 5 years, and almost 50,000 we have completed. So using this facility, any student can do any hands-on practical training related to VLSI, embedded system, IoT in a virtual mode, sitting from anywhere. So that's a very unique thing we have created. Like this, we are also coming up with a EdTech platform to train students in chip designing completely based on open source, where Semiconductor Complex Limited has given us PDKs, their PDKs. So it will democratize the whole semiconductor design processes also. Even though under C2S, C-DAC is doing the chip-in program, and we have licenses from companies. But in addition to that, to cater to the large number of students, it is very important that the open source training is also available. So that is another thing we have taken. So all these initiatives are now clubbed and completely available on the NILET digital platform, which will be launched very soon in September itself, where a lot of virtual labs we have provided. And industry is supporting us with the virtual lab. Infineon has given their videos and lectures. Kyndryl has given, so many industries are supporting. We have developed our own tools. So that is going to, create more number of manpower in a blended mode, because these digital platforms, there are virtual lab facilities, and then the best of the faculty. We are creating around 100 studios across the country. From here, people from industry and academia, they will be teaching the conceptual part to the students. And they can do hands-on in our own premises, 56 locations across the country. So, these are the certain initiatives that NILET has taken to scale up the skilling system and support the semiconductor industry. And government is equally supporting us by providing land now in Gujarat also, in Tirupati, in Odisha, in Noida, everywhere where we are going to open very specialized campuses focusing on the special industry segments, somewhere on design, somewhere on fabrication, somewhere on OSAT, and like that. So this is the model we have adopted. Thank you.
Yeah. Thank you, Dr. Tripathi. Thank you so much. As our Honorable Prime Minister, Sri Narendra Modi ji always says, that we cannot solve the problems of 21st century with the mindset of 20th century. That is the mindset that was there working in silos, and in 21st century we are looking at whole of the nation approach, whole of the sector approach to try to build and synergize our activities to reinforce our outcomes. And C-DAC is playing a very, very major role from Param supercomputer days to today. One of the biggest force behind this skill development is C-DAC's enablement through the tools EDA tools and the entire repository, the chip to startup program support, and a close coordination with Semiconductor Laboratory Mohali. So Dr. Sudarshan, coming to you, in your experience in last 3 years, where do you think we have progressed so far, and where do we think we need more support from industry, from government, for you and to do much more in the ecosystem that we have the goals for?
Yeah, first of all, namaste to all. Thank you to SEMICON and Professor Manoj for leading the discussions. And I think our respected Professor Rajat Muna sir and Tripathi sir have already highlighted many initiatives. Coming back to specifically what we have been doing on the talent development in the cutting edge technology, specifically you mentioned last 3.5 years. So I can share some of the journeys that we did, because when we started, the coin Chipin itself was not there as a brand. Today, Chipin is a global brand which provides all the facilities for the EDA tool, particularly the fabless design part. And when we started, I can say this much, that people knew VLSI as VLSI. But today when we say VLSI, immediately they start asking front end or back end. They start asking RF, analog, digital, mixed signal. Then they start asking what kind of node you are using. So that shows, first of all, the depth. And the depth is coming because we reached the scale. The current scheme that was envisaged originally targeted 120 academic institutions. But we have, whatever was told yesterday, unprecedented and exponential. This is a testimony in this particular case, because target was 120, that was the stretched target from 100 initially. But today we are 285 and counting. This is absolutely exponential growth, so to say. The second aspect was, when we started, we tried to get the top 3 most used tools. It took almost 1 year of paperwork and other processes because of the volume, because of the kind of open access that we needed, pan-India. It took almost a year to do all the paperwork. But then subsequently, industry has actually rallied along. Today, top 9-10 tools, all are available under one roof. And all the tool providers have been extremely cooperative. So there is no support wanting, first of all. The second aspect with respect to this is, it is there for us to see. Today, we have conducted more than 200 instructional enhancement programs to all the CTS participating institutes. And interestingly, it turns out to be at any point, any given day, 2 programs are on. And all the numbers are available online for you to see. So the number of people who are actually engaged in learning these new tools, they are offered by, not just by C-DAC or Chipin, but they are offered by all the tool vendors, then foundries like SCL, then aggregators like IMEC, Muse. They are all coming and engaging with the CTS. So the student community is no more doing paperwork or fabless design. This year itself, with SCL and other foundry support, we have more than 50 chips already guaranteed to tape out. So yesterday we saw 20 being announced. But by end of the year, we are expecting 75 plus design in one single academic year, calendar year, by students. This is unprecedented. Now this has resulted in a change of strategy for the entire program. We have now started extending peripheral IPs, PDK support, the MPW and post-silicon validation. And yesterday itself, during the MOU, we announced availability of Synopsys IPs through IITM Pravartak, analog bits, which is a peripheral IP from analog bits on that, and from TEPL. So if you look at it, it is a great change. And second, we are moving beyond traditional silicon. Now yesterday we again announced tying up with an European and US foundry for getting access to cryogenic design, chip design, which means we'll be able to support beyond traditional silicon room temperature to cryogenic chip designs. This is the change that we are seeing. And in terms of further support, there are few things definitely that can be put on the table. Number one, the hardware, though we have the smart lab facility, which is amazing, they are all good for kind of mass killing and repeated exercises. But when we wanted to develop products and solutions, each one is unique. So few development boards are needed. For example, today 100 institutions have FPGA boards and some of the hardware. But India today has 600 plus institutions offering VLSI courses. The tool access is today with 280 plus. There are almost 50% still needing access. And we are trying our best to expand it. Ministry is doing all kind of supports, both MIT, AICT, they are all coming together. But when you hit 600, probably our original target of 85,000 in 5 years, we are already 60,000 as told by Honorable PM yesterday. But current year, another 15,000 are already online. So we expect to achieve the target within the year. So 85,000 will be done and dusted. And we have no doubts with 600 institutions coming on board in the next couple of years. We will be able to meet the targets whatever Sharia was presenting. And the good news is, as I said, we are able to go now deeper. People are asking more questions, technical questions, than just VLSI as VLSI. So the complexity, difficulty has been slowly kind of being moved away. People are getting comfortable, which is good for the country. So we are very happy to be part of this journey. Thank you, sir.
Yeah. Thank you, Dr. Sudarshan, for this elaborative aspect of what all support C-DAC has been provided. Of course, the numbers we are doing is quite phenomenal. I'll come back to you on how do we measure, I'll come back in the next round on how do we measure the quality of what we have done so far, and also to how do we ensure that the people who have been trained are finding the right gainful employment. So I'll come to that question. But before that, from CG Power, right? I was really waiting for you because often our educational or academic institutions so far in many decades before the rollout of National Education Policy 2020 was talked about that we teach what we know rather than teaching what is needed. And that is a paradigm shift that we have now done with the National Education Policy. But from CG Power, being one of the very, very important setup that you are doing, what difficulties did you face in hiring the right talent, and what is it that you are looking for? Because we really want to build our entire skilling pipeline with a stakeholder-first approach, and that is where we want to listen from you on what are the challenges you faced and what are the gaps you see in terms of manpower that you hire.
Thank you very much. Thank you for giving us the opportunity here and share our thoughts about the semiconductor explosion in India. I was here yesterday and listening to the Prime Minister, and I was blown away when he said, designed in India, made in India. And as we journey towards this particular venture, me being an expat, I'm excited because we just turned on the first factory in Sanand, the G1 factory. We're going to build products there. We're already doing quals there right now. And we passed already. We reviewed with the customer last week. It was good in terms of this standard that we have put up. Knowing that we have a need to bring up an ecosystem, it's highly important to see that we get the right talents. That's very important. Get the right people on the bus. More to that, when we say we want to create a semiconductor ecosystem, it should be a structured way of doing it. Starting with R&D, design centers. In order to put up a design center, you would have to look into the talents that would be developed and the laboratories that would help them realize the value of testing, of evaluation, of DOE experiments, combination of materials. So you would require the packaging knowledge about it. So that's one thing about R&D that you have to have, packaging capability, design for packaging. The second one would be equipment. You can buy any equipment available, which is high-tech, state-of-the-art. We have it, we bought it, we run it, but that's not the limit. The truth about it is how you want that equipment to operate efficiently and effectively through a target value approach. You don't set up at the edge. You set it up at the middle, and it should be repeatable and the machine-to-machine combination of its stability should be measured. R&D for equipment selection and equipment development is crucial to the manufacturing lines. Looking at materials, and we don't have much supply chain in India, and that's why we have to work together, all of the electronics and semiconductor firms who are here, to become a user council so we can bring all of those supply chain in India. Same thing what Penang did way back, the 7 samurais. Big companies who grouped themselves together and brought in all the supply chain. If you look at Penang today, it's a Silicon Valley. This is a reality likewise in the future, in the near future, in India. So with supply chain, it's important to understand the material science of things regarding our semiconductor packaging, manufacturing, and design. And that gives you more advantage when the suppliers are coming here and asking us, all of us, what do you need? I've been in R&D quality and in my long term in the 35 years, and I've seen things change in my life. Different materials give different results, and different results give better business. So we need to harness that capability in R&D, on material science capability to develop a laboratory that can experiment through and examine it through an MSL testing to all the environmental testing that would challenge the package to survive an automotive grade 0, the minimum. We can do a grade 0 here. We're talking about it already at Sanam with our customer. When you look at the systems, we have to use our integration capability, our AI, in order to link all of our equipment, materials, even our human capital, into the manufacturing and the high volume manufacturing we desire. And so we introduce more and more products. We have to have an R&D, an NPI team that is highly skilled, who knows the 4Ms, man, machine, method, and materials, and likewise enable the business to bring the quality that we see. As Prime Minister said it yesterday, it was really brilliant. He says, India quality is high performance and is error-free. It rings to me because I'm a quality guy. Now, if you look at the bigger picture and you walk into the manufacturing, we have to use the integration, the automation, and the EIM, Equipment Integrated Management. That is a system that makes your capability more efficient because you can analyze real time through these softwares. There's a lot of available software. CG Semi is already working on that path. We're working with AI-capable application providers for our next factory, G2, which is ongoing right now. We estimate by the end of next year, we have that big factory. And that capability definitely have to sit on smart quality, meaning it's driven by AI. It's driven by integrated machines into a mainframe system with a control panel that we can see real time what's going on with the performance of SPC, the CPKs, the behavior of failure rates. If ever they would be high, we can react immediately. The people that we train in-house is specialized directly towards this capability of knowing the basic, but running also the advanced. We're looking at this talent, and we're not looking at foreign. We want to develop the local. When the ISM visited our factory in the earlier part, and we showed them that our GETs, graduate engineers, who were trained in Kuala Lumpur in one of the factories of our customer, actually came back and was able to do the basic and do also the growing advancement. So we're proud that we can develop because that is the key. What we do basically is to make sure that we have to structure this particular journey into a more broader sense. And I was thinking, the education system also have to be structured in a way that if you're taking a mechanical engineering course, which I am a mechanical engineer, or an electrical engineering course, or ECE, we can have the first 3 years to be the basic engineering. The 4th year could be an immersion in this IIT Bombay and all of those available institutions that are enabled already. So they will understand the value of semiconductor from how the packaging works, the design of the product, the device physics in it, the material interaction, how an electron goes into those circuitry, and how that affects the application of a TV, a computer, a handphone, and all those electronic stuff. But in that laboratory, we still miss the fifth one, which is the last part of the education, the actual practicum in CG Semi. In any other available semiconductor OSAT, even EMS, in their own grounds. And in the fifth year, we can practically qualify them, and as they graduate, they go into the job. That's the view of CG Semi about the whole semiconductor space journey of ecosystem. And we hope that we can find most of the answers here in this big forum of intelligent people and institutions. Thank you very much.
Thank you. Thank you, Mr. Cortez, for offering an employer's perspective on what is really needed and very important. And actually, you seem to have given me an action item. Being India's only logistics and transportation university, we have to start courses on semiconductor supply chain and logistics, so that is an action item that I'll take, and we'll do that. One important aspect, as we know, because we started almost afresh 3.5 years back, coming to you, Sherry, there are several areas, like yesterday also it was mentioned, 20% of the world's semiconductor design engineers are in India, from India. However, there are several areas in which, because we were not working in India so much, and therefore, in an interdependent world, we depend on global collaborations, more on the manufacturing side, what goes at the equipment, how do you ensure equipment operates at a optimum, or how will you ensure yield efficiency, and many of those aspects. So from global collaboration point of view, SEMI has been playing an important role to help India Semiconductor Mission. What are your experiences so far? And where do you think we should focus more in terms of our global collaborations next?
Thank you. Yeah, I think, oh my gosh, there's so many things. There's an incredible need to collaborate globally. Of course, this industry has to be this worldwide view of how we all work together. So I think what's become more and more critical as I watch this industry sort of exponentially grow, as I watch the needs, as I watch the ability for everybody to start working together, is to look at what we've seen be successful in this space. So I'm going to start there. When I think about how we've been able to build programs that we've seen success in our world at SEMI, it really only works when we can bring academia, government, and industry all to the table to align. We need the resources. Workforce development is not an easy component to lift in this work. We need the resources, we need government support, we need industry support, we need everybody to work together to source this, to make this a viable pathway for folks. We need industry partners to do exactly what you just did, to illuminate what we really need to build from a curriculum standpoint, from a skill set standpoint, from a competency standpoint, so that when we are building the workforce, not we, just SEMI, I mean collectively, all of our academic partners and on the globe. When we look at this, we are working together to make sure that we are meeting those needs very carefully from a member perspective, from a company perspective, from an industry's perspective. And then our academic partners, I'm really going to get to your question, but from the academic side of this, in order for this to work, our university systems need to align with those needs. We need to really look at how do we build the set of skills that are needed most in this industry. So yes, in India, you guys are doing an incredible job already scaling up into the design world. And I think we rely on the talent globally based on that work. And to your original point, you're right, 85,000 is here. But the number of Indians that are going to be needed around the globe, I hadn't thought about it that way. In my own brain, I was thinking about each region, what is needed. So it is a collaborative effort, right? But until we all pull those partners, those stakeholders together, it won't work. So what I've been hearing, and you guys would know this better than me, is that there's this opportunity to build more here on the ground in India. So if that's the case, and there's new building around fabs, there's new building around manufacturing, that's going to have to become an area of focus, just like design currently is. That's going to have to be an area that you expand upon. And there's going to be different partners around the globe that will have different strengths in that work as well. But I think as long as the collaborative effort is there, there's an opportunity to really build some spectacular work here. And what I've learned over the last year of learning about the ecosystem on the ground in India is that there are an amazing amount of programs and initiatives that already exist, and we're all learning from all of you about how to implement this around the globe also. So it becomes, we bring strengths from one country to another. We learn from all of you, you learn from all of us, and it's a way that we can all work together. And the other piece I did want to touch on, to add to the gaps, to add to the needs around trainings, to add to the technical levels that you expanded upon in your response. We also heard a talk yesterday about the ability to bring creativity, to bring communication skills, to bring cooperation, teamwork, to make sure that we don't lose sight of that incredible amount of need in that space too, in order for students to be successful in this career. That need to be curious, that need to be lifelong learners, to want to keep advancing. That's going to become really important as we look at the growth of this industry on a global scale. And again, it has to be this amazing and powerful collaborative effort. In the US, we were just funded, the SEMI Foundation, to build a national network for microelectronics education. It's a $200 million grant to lift exactly what I'm talking about. How do we all work together collaboratively to fill the gaps that are needed? So I think that's the start.
Yeah, thank you, Sherry, for offering the global perspective. One of the important aspects that yesterday also it was highlighted, that our future success will also significantly depend upon how our country can become a product nation. And there is a big difference between merely designing or defining our own requirements and conceptualizing design for that and then leading to manufacturing. And that is one aspect that is still considered one of the gap areas for us. And our semiconductor journey can be complete only when we have an entire ecosystem of local need to local design, to local manufacturing, to local consumption, and then export to the world. So when we say design in India or India to become a product nation, I'm coming to you, Professor Muna, what do you think specific action that India should do, maybe in 1 or 2 sentences, or because we have to wrap up in 5 minutes maybe?
Thank you, Manoj. See, basically, in my opinion, one has to look around the problems around you and find solutions. I mean, when you look at the problems, there are too many problems, like pollution in Delhi. I mean, every winter we talk about it, okay? Like water pollution, like energy. And there are just too many problems that we have around them. It's just that in order to solve them, in every place we actually have a solution which can be built with electronics. Monitoring of pollution, and therefore acting on something. Otherwise, what do you act upon, right? This itself is a design problem, and in my opinion, lot of designs can actually come around. Monitoring the temperatures at micro scale, you know, not at the level of what is the temperature in Delhi or North Delhi and South Delhi, but what is the temperature in this room and, you know, the next building and so on and so forth. I mean, this itself is actually going to be a design problem. There are many other things, like for example, I have myself worked on several projects, and things like electronic passport, things like driving license, things like GSM cards. They're very tiny, tiny semiconductors, and all of these can actually be designed and manufactured in the country. And I actually want to mention something. In fact, often, especially in the media, we hear a lot saying, oh, India doesn't do semiconductors, and because semiconductor mission, India will start doing semiconductor and our dependence on other countries will reduce. I don't agree to this last part, right? Because semiconductor is actually a global phenomena. It is not that our dependence on others will reduce. It is also equally important to say others dependent on us will increase. And that, because if you, I mean, Sherry actually gave you a dissection of Apple iPhone and says, you know, these many companies are actually attached to this. And all of these companies are actually coming from all over the world. A simple phone doesn't work, doesn't get designed in one place. Software, hardware, everything comes from differently. So in a global ecosystem, in my opinion, there is a huge space for us to design and get into that. Thank you.
Thank you. My last two questions. As we know, our country always strongly focuses on democratizing the technology and its usage. Therefore, for semiconductor technology, in terms of whether usage of open source ecosystem or usage of a model which can democratize, Dr. Sudarshan, you have any input that you want to share? Quickly, maybe 1 or 2 lines.
Hello. Yeah, sir, few steps have been taken, just I will highlight quickly. Though we spoke about the basic,
Just 1 or 2 lines.
Yeah, 1 to 2 lines, education part, but we have conducted design hackathons. I'll probably just highlight that one aspect. What was done was we identified problem statements, both for analog and digital design, and it was announced to the institutions. Surprisingly, 10,000 plus students with 2,000 teams participated. 40 were shortlisted with a lot of challenges because we never expected that scale of ideas coming from people. And for the first time, a 100-hour hackathon was conducted on premise 24/7. Normally we do 2 days, 100 hours. And the winners were from all over the country, from tier 1 to last tier. And all of them had specific problems solved and industry was in line. And the next line of thing is happening currently, we are in the evaluation stage. 30 of them will be supported through Makers Village and they will be incubated to come out with the real products. So it is going very well.
Thank you. My last question, maybe I'll ask each one of you in one line or other. With semiconductor sector being such a large sector, we're projecting India itself will need maybe more than $100 billion semiconductor need 2030. Is there a need to set up a sector-specific university in semiconductor? For example, maybe whatever the name, Indian Institute of Semiconductor Education Research or whatever. Do you think there is a need to focus on a sector-specific university for semiconductor for having a much larger focus on a specific area? Anyone can comment? That is my last question before I close.
Thank you for this question. So, I mean, I told the first time only that we are already working in these lines. And Ministry of Electronics and IT is kind enough to support NILET with a focus to make very specific NILET university campuses in different technology domains. So the focus in Guwahati, we are setting up a university campus with Center of Excellence in Advanced Packaging. In Gujarat, we are going to set up in the fabrication. And similarly in Noida, we have already made a Center of Excellence in chip designing. Yeah. So NILET university campuses
so my question is, including industry, just like the model of SEMI University that Sherry talked about, what bigger push can we give together and collectively was my interest and the discussion point. Yeah.
True. I mean, so industry is supporting this campuses.
Thank you everyone for a very nice and engaging session. There are many takeaways that we can take from here, and let us continue to work in synergy to build the entire semiconductor workforce that is needed for the sector. Once again, thank you so much.
Thank you. Thank you, Professor Manoj Chaudhary and the team, entire panelists for moderating the session. Ladies and gentlemen, let's give a round of applause and thank Professor Manoj Chaudhary, Dr. Rajat Moona, Dr. M.M. Tripathi, Dr. S.D. Sudarshan, and Mr. Rene Cortes. Well, we now move on to another all-important fireside chat, particularly on the topic, the hot topic, which is normally discussed in different media. That's the green energy for a sustainable world. We need to delve into sustainability, which is a key pillar. Now, around the world, we are all aware that countries are making bold commitments to combat climate change. India indeed is committed to carbon neutrality in terms of net zero emissions by 2070 and sourcing 50% of the electricity from non-fossil fuels by 2030. Now, this all-important fireside chat will go a long way towards exploring sustainability initiatives that can drive a greener future for the industry, balancing cutting-edge innovation with environmental stewardship. To moderate this session, it's my pleasure to welcome Mr. Masaru Tsuchiya, the partner of McKinsey. Are you there, sir? Yeah. Please put your hands together, ladies and gentlemen, to Mr. Masaru Tsuchiya, who leads a client work across multiple industrial sectors, including batteries, hydrogen materials, and semiconductors. As a member of the leadership team, he collaborates with clients across sectors on operational, transformational, and strategic initiatives. Hari, welcome to you, Mr. Masaru Tsuchiya. The other panelists on this fireside chat, I would like to call upon Professor Jagjit Nanda. Put your hands together for Professor Jagjit Nanda, a distinguished scientist at SLAC National Accelerator Laboratory and also the Executive Director of the SLAC Stanford Battery Research Center. He's also an adjunct professor in Material Science and Engineering Department, Stanford University, and scholar at the Stanford's Precourt Energy Institute. He's an internationally recognized leader. A hearty welcome to you, Professor Jagjit Nanda. After that, we have Mr. Saurabh Agarwal, the partner at EY India. He's a leading expert on policy advocacy, specializing in localization, incentives, and of course, taxes and tariffs. He provides strategic guidance to his clients on government policies, such as production-linked incentive schemes to enhance domestic manufacturing. Hearty welcome to you, Mr. Saurabh. Please take your seats. Yeah. I would request the audience, please, to take your seats. We are having a session. Please take your seats. I think the offline discussions can happen later on or outside the hall, please. Please don't think otherwise. Please take your seats in the interest of time. Yeah. Yeah. Over to you.
Yeah, thank you very much. Good morning, everyone. Welcome to the panel on the green energy for the sustainable world. Thank you very much for the organizer for having this session. Very exciting to discuss this very important topic in the SEMICON India. My name is Masaru, or Masa, as introduced. I'm a partner in McKinsey & Company, where I lead our semiconductor practice and battery practice in APAC. McKinsey is actually my third career. I actually began my career as a researcher in semiconductor physics and a brief postdoc. That was actually running the company in the US on the fuel cell. And about 10 years ago, I joined McKinsey. And now actually working closely with the clients in Asia. My normal destination going to the client work has been Japan, Korea, Southeast Asia, and obviously Taiwan and US. But recently, from probably 2 years ago or so, I started actually coming to India quite often, which is actually spectacular to see this region is waking up to lead the semiconductor industry going forward. And also I think in many ways I actually feel India is my sort of the semiconductor home. So when I was actually doing the PhD in the US, my advisor was actually coming from India. So my mentors, all the collaborators in Intel, Sematech, IBM, all are actually coming from India, from IIT and IIS. I learned so many things from these colleagues. So I feel it's a time to actually giving back to India to grow the industry. So it is truly remarkable to see India now emerging as a next generation semiconductor fab. So before actually going to the discussion, I'd like to actually briefly mention about why energy matters for semiconductors. A modern fab, like maybe memory fab or advanced node fab, consume about, depending on the scale, 1 to 3 terawatt hour of energy, which is huge, I think, energy. If you think about India, average household is probably about 1 megawatt hour per year. In Japan, could be like 3 to 4. US could be like probably 10 megawatt hour per year or so. But if you think about this terawatt hour essentially of energy needed for semiconductor fab divided by the number of the people, actually equivalent the household consuming the same power, it's almost like 1 million people. So building the semiconductor fab is almost equivalent to building the medium scale city in India. So that's the astonishing scale of energy needed to actually make semiconductor. At the same time, I think the challenge comes from this company like Apple, Google. These companies are asking essentially to reduce emission. And if you look at your iPhone, 75% emission comes from semiconductor fabrication. And the semiconductor fab itself is probably about 40% of the overall emission. So making this iPhone, approximately about half of, I think, the CO2 emission come from the front end, I think, semiconductor fab. Therefore, it is very important to have clean, reliable, and affordable power that would decide not only the location of the fab, but also actually competitive nature of the fab and semiconductor industry. So that's actually overall context for today's discussion. And to address this topic, I think we have a very, I think, distinguished, I think, the panelists today. And we have Mr. Saurabh Agarwal from the left, from the actually right from you, and then Professor Jagjit Nanda on my left. You know, we just actually met today, so I thought about maybe instead of actually me introducing each one of you, that introduce yourself with self-introduction would be good. So if you can actually briefly share your name, your role in institution, you know, a little bit about your professional journey so far. So probably start with the Professor Jagjit.
Late morning and back to home. So very nice to be here, and thank you for giving the opportunity to talk about my journey from semiconductor quantum dots to battery storage system. I started my journey on working on colloidal quantum dots at Indian Institute of Science, Bangalore. My training years were still doing 2.6, 4.6 semiconductor, the nano mission days, and then moved to Stanford, and then did a lot of translational research across the industry and national lab. So I'll try to tell a little bit the answer the questions that the moderator has in context of semiconductors and sustainability. But at Stanford and SLAC, I'm bridging the translational battery research, where I say that the circularity is the main issues. And the circularity aspects I'll highlight on linked to the sustainability, which is circularity is one aspect of the sustainability. And I'll try to tell how batteries and energy storage are integral part of the ecosystem for energy transitions that India is racing along, inspired by the leader, Prime Minister Narendra Modi ji. Yesterday, it was very inspiring to be sitting behind his the podium here and listening to his talks and so also many industries things. So I'll keep these things short so that I have much more questions and maybe some from audience if time permits. I'll pass on to Saurabh.
Thank you, Professor. So I'm Saurabh Agarwal. I have been working as a partner with Ernst & Young. Last 7 years, I have been focusing primarily on Make in India initiative of the Indian government. Out of the 17 odd PLI and you can see semiconductor and other programs which have come, which is 14 PLI plus other programs. It was a privilege to represent the industry in either advocating the changes in the program or on behalf of the government coming up with some of the drafts in that particular programs. You know, when I was invited on this particular session more on the green energy, 15 years back, I still remember when solar was not being talked about much, and we started with few companies in India who started building up the solar capacities compared to today where everyone is talking about solar. You know, as the prof said, we have been talking about the battery energy storage as well and the pump storage. I think Semicon as an industry, it's a highly energy intensive industry which requires a significant electricity to overall for the uses of HVAC and the cleaning of the water. I think in this particular industry, compared to many other countries who are moving from the gray energy to the green energy as far as the fabs are concerned, I think for India, I think we are in a position where we are still developing our fabs facilities. So it's more easier for us to directly move into the greener energy part of it. I think as we move around into the session, we'll be talking about some of these things and the way the government policies are helping in achieving the greener objectives.
Thank you, Saurabh. Maybe I think I will actually start a conversation, but first question actually goes to Mr. Saurabh. But as you mentioned in your introduction, you're an expert on this large infrastructure project, and I've been curious about what incentives, financing models, and partnership are typically needed to make such large infrastructure projects like renewables and semiconductors. And also in case if you see any regulatory hurdles that you see, and then what are the methodology we can unlock some of these regulatory hurdles? Could you comment?
Thank you, Masa. So as I said in my opening remarks, for a decent size fab, you need 100 to 200 megawatt per hour of electricity. This electricity requirement is somewhere around close to lightning around 1 lakh households around a small city in India overall. So the point, many a times it is said that renewable is an option which the fabs or the semiconductor industry should look at. In my view, it's no more an option because the cost of renewable electricity is going down significantly over a period of time, and therefore it is becoming more of a necessity wherein to our industry where there is a high operation cost of electricity, and renewable can surely act as a measure in which you can bring down the overall cost. And even from an investor standpoint, when we are looking at our long-term investors and the ESG funds, typically the ask has been around to have a greener energy or a sustainability as one of the important focus. Three levers, when I talk about bankability, the three levers which become important in my view is the role of the government as an anchor into it. And I'll be talking about what Indian government has done, but because, it's a 20-25 year contract, so as far as the fab manufacturer is concerned, they look for a credible electricity source with a fixed cost over a period of time compared to when we talk about a green energy developer, a power developer looks for guarantees and the credibility so that the long-term investments which they are making into the capex program, I think those are well taken care of. So I think government, when it acts as an anchor, it helps in giving a sovereign guarantee. It acts to the overall, you can say, it brings down the risk. And we have seen in Dholera, so we can see in Dholera there is around a 5 gigawatt worth of solar park which is being established, and the government is acting. SECI is the one who has been inviting tenders in this regard, and the likes of the developers like Adani, Renew, Wari, etc. have been bidding for these projects. Effectively, it is like a back by the government because SECI is the one who is actually entering into a PPA in those cases, and actually that energy is getting further supplied into the, you can say, the fab facilities. I think another way, while the first part with respect to scope 1 of energy transition is being taken care, but what is important is to more look into the manner in which the entire supply chain, when we talk about the semicon supply chain, the entire ecosystem, we can look and explore the possibility of building larger green energy parks like what TSMC is doing in Taiwan, so that effectively we can overall reduce the carbon footprint. And this can be done more by a consortium of developers coming together to build in ultra mega renewable parks in the country. The next thing which is important is the multilateral agencies like IFC, ADB, and in India, REC, PFC coming forward to fund some of these greener energy projects. I think, Masa, another thing which more or less I have been seeing and I have been, at least I have been talking about is that the way the investors should look at the valuations as far as the semicon industry is concerned, I think they should not look at the traditional models of DCF, but if we can look at more of a model of which are multi-layered decision models, wherein, 4 things become very important in my view. First is the premium per wafer, which should come on account of a wafer generated through green energy. Second point which comes is the discount rate reduction for lower regulatory risk, because when you use a green energy, the regulatory risk gets lowered down. The next point which becomes important is the valuation on avoidance of future carbon taxes. And the most important, the customers today have their own sustainability goals. The likes of Apple, the like of Teslas, they have their own sustainability goals. They would want to buy from those semicon fabs or display fabs who actually are using greener energy. And this will ensure that we are not risking our customers by way of using green energy. And I think for India, I think there's a story because we are just developing the entire semicon industry.
Thank you very much. Very insightful on the business side. And then one thing I'd like to mention is that the business on one side of things, I think the Saurabh mentioned. On the other hand, if you think about the semiconductor industry, we need to provide this 24/7 energy. And as India, we've been actually growing, I think, GDP now. Countries always scarce on energy resources as well. So therefore, we probably need some sort of innovative technology or storage technology needs to be blended. And you've been seeing, I think, the substantial innovation in Stanford in the US. And then, I know you have a passion bringing some innovation to India. What are, I think, the key innovations or technology that could potentially apply to enable a clean 24/7 energy in India? Any comments?
Yeah, I've been taking strong, since I left India, early 2000, I've been taking keen interest in Indian energy storage, how it evolved. And I'll try to benchmark a little bit the ecosystem, especially the long duration energy storage, the Indian context here. So as you know that with respect to semiconductor industries, like need 24/7 electricity, let's think a little bit about switch gears and think about the storage needs, where we need resiliency, reliability, and also cost. So in that aspect, so you can see that if you see long duration energy storage, the lithium ion technology, which is the elephant in the room here, is slowly attending a cost parity, which is really competing with other cheaper electricity. But it's also, if you see from 2 hours to 4 hours to 8 hours, you can see lithium iron phosphate technologies. People who are working, the domain experts can say that the cost of iron phosphate technology is scaling down to $50 per kilowatt hour, which is unprecedented a decade before. But with that situation, the penetration of which provides challenge to other renewable energies in battery system, for example. And that's basically the so cost sensitive systems. But I think the future, if I single out what is beyond lithium, lithium ion, what are the technologies, some of the iron and zinc systems can be things. But where I can see that more or more getting the storage, obviously lithium ion will be the dominant one for many needs, for transportation, for example. But with the BESS, grid storage, is still going to play a very dominant role. So coming back to our semiconductor system, if somebody asks a question that, okay, we need 24/7 electricity, so we still need to really have big battery storage system for our renewable, for solar and wind. Because solar and wind are almost achieving zero cost, give and take. But for making storage compatible to meet the cost and reliability, especially the cost, the techno-economic model says that it should be 5 cents per kilowatt hour. So what I see that based on those Western projections, when I talk to experts here or my friends in Niti Aayog or ministry, I visit every year to visit secretaries here and see, check notes, the Department of Energy. So what they do is that there's a 5 cents compared to some rupee equivalent, and that makes sense. But to make it as a scale, that's Indian context is going to be a big challenge here because storage is still expensive. And if you look at how to make it happen, it brings down to not only the technology, but also supply chain aspects. So these are the two key things, I think, to have a uninterrupted power, 24/7 reliable power for semiconductor. The storage cost has to come out and it come down. And second thing has to have the kind of, compatible to the supply chain and geographical needs of the Indian context. Iron, zinc, manganese. So the people who are trying to develop still technologies alternative to lithium iron phosphate, I would suggest that they start going with the IITs and IIScs, the ecosystem. Think about earth abundant technologies, manganese, zinc, titanium, those are the things which can make high developed cathodes, which India still can make. Of course, sodium ion is around the corner, and in the interest of time, I'll not go into there, but the sodium ion is picking up in Indian ecosystem here. It's still a long way to go globally, but these are some of the technologies that I think I'll stop here and come back to the next round of the circuit. So we need 24/7 electricity for solar and wind technologies. We need cost parity, 5 cents per kilowatt hour or lower for Indian context. The supply chain gap has to be fixed, so India has to decide which are the storage chemistry they have to adopt, having that cost parity. So I'll now go back to your next questions.
Okay. Thank you very much. Supply chain affordability is very important, I think, for technology. I fully agree with that. Maybe then I think coming back to, I think, little bit to Mr. Agarwal one more time, talking a little bit of business side of it. I think you mentioned about maybe customer, premier wafers, these are important, but at the same time, always this kind of trade-off exists between sustainability, clean energy, versus this like, economics, right? So one question that I have is like, how do you see like India's policy essentially helping to reduce emission without compromising manufacturing competitiveness? And then if there's any, given the broad range of stakeholders eventually involved in this, like what specific policy would you suggest essentially to the government to, I think making sure I think the sustainability and cost and competitiveness can be achieved at the same time?
Thanks, Masa. So, as of now, if we look at the manufacturing for semiconductor is still developing in India. The Indian government offered a subsidy on the central government side, around a 50% subsidy on the project capex cost, followed by the state governments offering around 30 to 40% subsidies of the project cost. So effectively 80 to 90% is what is being offered by the Indian government as far as the semiconductor manufacturing is concerned. But somewhere I think the effective part of those incentives could have been linked to the green energy, which may not be true in the present case. So for on-site green energy, which is more like rooftop or some bit of, you can say, other renewable sources which you are using on-site into the production facility, you can use some of these subsidies or incentives. But as far as off-site, which is the larger part, because end of the day, if you are looking forward to serve the electricity to the fab through a rooftops, it's not possible. So you have to go off-site effectively. In all such cases, I think today the government has not announced any specific incentives in that area. But Masa, it's very important to understand that along with the semiconductor program, Indian government has also been running a green hydrogen program. In the recent past, the government has allowed that for green hydrogen and green ammonia, they can power such facilities through power plants being set up into an SEZ. So effectively, you can have a green hydrogen and ammonia facility into an SEZ, and you can have a power plant also into an SEZ. So by having a power plant into an SEZ, you bring down the capex cost substantially, because the entire taxes which are incurred when you buy all these equipments, you don't have to make the payment of those taxes. I think a similar change was done for semiconductors as well, wherein the land area requirement for setting up into an SEZ was reduced. But I think there is a requirement of an hour wherein the government should somewhere look at one, allowing the SEZs set up for green energy, which can be subsequently supplied to a semiconductor facility, which is also into an SEZ. That's one area which the government should look at. The second part, when I look at US or Europe, and of course, both you and Prof will have better understanding about those countries. When I look at the CHIP Act, the way the US has been incentivizing if the chips are being made through a green energy, or even in Europe, the way the CBAM is being implemented to have higher tariffs. I think somewhere in India, because the industry is getting developed as of now, so the focus is not that much on the green energy incentives. But I think as we move forward and as the facilities start getting in, start developing and they start the commencement of production, I think it will be very important for us to look at some of these green incentives. At the same time, while it was great that the government has come out with a SEZ policy for, or allowing SEZ for a semiconductor facility, I think some relaxations on the NFE, which is a net foreign exchange requirement into a special economic zone, is also a must today, because for such a capital intensive industry to meet the net foreign exchange earning in a block or in a one block or 2 blocks, which is a 5-year or 10-year period, may not be possible easily. Similarly, for green energy, I think co-developer or developer model into an SEZ can also be looked into, which can bring down the cost of setting up these particular plants, and in turn leading to a reduced cost of electricity as well.
Got it. Thank you very much. And then I'll actually come back to the in-person Nanda on technical aspect a little bit. You mentioned about, LFP, sodium ion. There are a little brief mention from, I think, the Mr. Agarwal on the hydrogen ammonia. I think the India now actually bringing this technology to locally and then produce semiconductor. So far, as I mentioned, a lot of my mentors in the US and India, so a lot of talent actually overflow from India to outside. But now potentially the time I think India to innovate as well on this technology. So from your perspective, what should India invest in this kind of frontier technology? What are the opportunities for India to innovate in storage or energy technology in your view?
Yeah, let me continue where I left a few minutes earlier on. I mostly talked about battery chemistries, but as you know, there is hydrogen mission going on. There is, and so we had to have orange to orange, apple to apple comparison actually, because at the end of the day, sustainability part is one thing, but it has to be, the industry has to make money out of it. Okay. So there are some emerging things that are coming up. I was told by recently, yesterday, meeting with the NTPC MD and chairman, they have a supercritical CO2, and the round trip efficiency is 72%. I was excited because, one thing you have to understand that a lot of metal air and a lot of these alternate technologies, non-electrochemical or thermal energy storage, that's my job, bread and butter. I give lectures on that and practice it. The round trip efficiency is a very important part which goes into your techno-economic analysis. Any 50% round trip efficiency is something you have to be really, as a researcher, day to day, you have to be very skeptical and be honest about we as a professor or a researcher community has an obligation to the venture world and the technologies and people who fund it to be honest broker, tell them that, okay, this is the shortcomings. It's not that it looks very innovative and promising, but let's be honest. Lithium-ion batteries was invented, it's long back time, but 1991. So it takes 15, 20 years for 1991 commercialized by Sony. And then by the time 2011 and 2012, it came to cars. So let's be honest, any new chemistry, any new innovation, to come to that scale, it takes 20 to 30 years. There is no black magic. So if somebody tells to you that, okay, I have a fantastic battery chemistry that can give you return of investment, I think that's not, let's be skeptical about it, because there is, battery technology is more evolutionary than revolutionary. Okay, it's not like an app or AI that you can just do it. It has to grow naturally, like the real time on that. So coming back to that, again, coming back to the Indian ecosystem, which is my passion here to see, I've been telling Niti Aayog, my members respectively when they visit Stanford, that we have no dearth of manganese, we have no dearth of titanium, we have no iron, and few other critical elements, and you can have fantastic high energy density chemistry by two combinations. You don't have to go for nickel, cobalt, NMC, where I am an expert in that area for 20 years in America, because we can have maintained the cost structure of that. It's coming back slowly. If you do call to SECRES and of IISc Bangalore, they're coming up with new pilot plant, but it'll take time to come up with that. So I'm a little bullish about right now that a lot of this mature technology that is hungry, like India is hungry now to implement. So what you will see right now for renewable energy, for basically in BES, you will see that they will pack all the energy battery packs in these containers of 2 megawatt hours. But then one has to still careful about the safety aspect, but you can't dump the batteries. Even lithium iron phosphate is safe. You really can't. So you have to develop codes and standards in Indian context. I think there's a lot of work going on. Slowly they're thinking that we can pack a lot of these 2 megawatt hour containers for BES storage. But that's industry can make it. I think we have the scale, but we have to import that cells and packs right now, and somehow rapidly manufacturing here for internal domestic demand with huge demand. So there is, everybody is working to have those packs and the cells manufactured in India, and that's why all the PLI schemes and everything is going on. Long story short, I'm a little passionate about this because we are little late catchers in everything in a way. So hopefully there are some new emerging technology like sodium. There is some new emerging technology, non-conventional like CO2 or what is going on, which India and bioenergy. I'm not talking about the bioenergy right now. There's another 40 minutes or another 1 hour. Bioenergy part is picking up. They're co-firing things, things which is not actually renewable energy in a way, but it's close to practical, like gray and green hydrogen type of things. So long story short, let's go back to the sustainability aspects. Now, right now, only globally, 8 to 10% of the lithium-ion batteries, even 5% of lithium-ion battery is recycled. And this is a huge opportunity here. Because see lead-acid batteries. Lead-acid batteries is 99% recycled. It took a long time. So if you want to make lithium-ion battery recycling, we have plenty of opportunities here to start thinking of the recycling business, which is very cost-sensitive. But Indian skilled labor force, if I talk to Amara Rajas of the world here, and talk to all the companies that's coming up, startups coming up, I think recycling is one of the critical areas that we should also focus on. Even LFP recycling, it sounds very thing, but you can extract the lithium salt from that or regenerate LFP to make it happen. So long story short, again, I think sustainability, circularity of battery chemistries, lowering the cost down will feed the right chain for 24/7 electricity to the fabs, which cannot go at all, things. So the grid has to be resilient, a resilient 24/7 reliable grid backed by renewable energy is the way to go. It sounds like common sense, of course, but the cost economics and the supply chain gaps has to be met. And we have to move away from critical materials in batteries and those materials. So that's in a way, I'm summarizing the technology aspects right now.
That's good. And then hearing from both, essentially, not only just investing in SEMICON, but also building the supply chain and the ecosystem. That's quite important, actually, to make it sustainable. I'm actually watching the time. Seems like we actually have a reduced time, given that we have actually fewer people than originally planned. So we actually coming to the, I think, close of a session. But before we close, I think any final words from each of you, like maybe what we should keep in mind, essentially, in making sure this session effort is going to be successful.
I think I look at it as that developing a robust ecosystem in any sector to that extent. When India started with developing electronic manufacturing, we started with more of our assembly. We started doing more bit of localization into it, and then and we have seen the rare earth crisis very recently as far as the auto electronics is concerned. I think looking into the way the country is developing and the fact the goal of the Honorable Prime Minister with respect to self-reliant Bharat or Atmanirbhar Bharat, it's very important that while we talk about semiconductor manufacturing, at the same time the government should look at developing a semiconductor ecosystem, which is the focus around the ancillaries. And then when we talk about the emission, one in the form of energy emission, two in the form of the gases which are being released, and the third level of emission, which I talked in the initial opening remarks as well, coming from the entire ecosystem, how we can actually, you can say, create a larger green energy parks and the larger semiconductor parks, wherein we have fabs we have ancillaries into it, which are all served by those green energy, which will help in actually bringing down the overall emission from the ecosystem.
So again, we need ultra pure water. So let's come back again. I spoke a lot about in battery chemistries and renewable energy storage system. But coming back to semiconductor ecosystem, one aspect is obviously India has challenges in water. Water is used for agriculture, and getting ultra pure water for semiconductors needs is going to be everybody who is making this big plant are very cognizant of that. 2 to 3 million gallons for every plant they needs. And I was told the purity level is more than the distilled water purity for ultra pure water. Also has energy needs. But I'm not also talking about making chips, AI chips, not only these normal chips for semiconductors, automotive, the power demand will be exponential. But even before that, I was doing a back of envelope calculation for the amount of 50 degrees centigrade in Delhi and other cities, the amount of AC we need, air conditioners, the power demand is exponential. So if you take this exponential of exponential for AI chip demand and for weather, climate change and all these hot summers that we're having, energy storage is a critical aspect of the whole ecosystem, because you have to have sustainable energy storage for not only a semiconductor revolution, achieving net zero goals for climate energies. So the common theme is sustainable energy has to be thought as parallelly as we plan our semiconductor development and growth. Today, the real leaders of the world made it clear. Right now, as you speak, is going to be a roundtable executive meeting. Right after this, the leader is going to talk about that with Prime Minister Modi ji. And so to wrap up with that, so this energy water nexus. So we have been, a lot of conferences, we have been really champion of energy water nexus. And energy water nexus is actually one domain semiconductor really reflects the nexus between energy and water. So I'll end with that.
Okay, thank you very much. So that's actually, I'm seeing time's up on the screen now, so I'd like to actually close here. But thank you very much for Saurabh and Jagji joining this session, and thank you very much for the audience to join. I was actually quite energized by actually seeing a lot of opportunity for innovation, and also I think the substantial, the regulations and financial institution needs to the semiconductor, and I'm personally kind of interested in how the progress goes in the next few years. Thank you very much.
Thank you very much, and let's give a round of applause for all the 3 panelists. Thank you, sir. Yes, indeed, I'm pretty sure that the panelists will be available offline, and we can ask any questions, if any, to the esteemed panelists. Well, ladies and gentlemen, we now move on to the next important aspect of today's deliberations with regards to investments. Now, catalyzing investments in semiconductor sectors and, of course, the role of financial institutions. Right from morning, we had a couple of fireside chats which were indeed illuminating and at the same time thought-provoking. And we are going to have a similar sort of fireside chat now. And immediately after that, there will be a couple of panel discussions before we head for lunch. Now, catalyzing investments is an important aspect. At the same time, the role of financial institutions are also very important in terms of accelerating the growth of India's semiconductor event. Now, moderating this particular session will be Mr. Vinod Subramanian, the Vice President, Technology, Invest India. Let's give a round of applause and welcome on stage. They're already there, all 3 of them are there. Yes. Ladies and gentlemen, put your hands together, please. Mr. Vinod Subramanian, more than 30 years of, kindly be seated, sirs. 30 years of industry experience, having worked at various technology companies, And Vishal Iyer is the Managing Director, Corporate and Institutional Banking, the Hong Kong and Shanghai Banking Corporation Limited. And of course, more than 2 decades of experience behind Mr. Vishal Iyer. And finally, Mr. Brajesh B. Chalil, more than 25 years of experience in financial markets and, of course, leadership roles at various banking institutions. He currently heads the Treasury Market Sales and Trade and Treasury for SMEs at Axis Bank. So, ladies and gentlemen, for some of you who have just come in, let's give a round of applause once again to all the 3 esteemed panelists. And straight away, I'll hand over the session to Mr. Vinod Subramanian to take us through. Over to you, sir.
Good morning, everyone. I'm audible. Thank you very much. Welcome, Vishal Brajesh, to this wonderful conversation around investments. Money is what drives all business. Allow me to set the context with a few fundamental things around electronics and semiconductor industry. Semiconductor industry globally is about a $600 billion, racing towards $1 trillion market size, driven heavily by AI. Given that kind of large market opportunity and growth, India is not really competing with anybody else. I think there is space for everybody to play their rightful share. Semiconductor industry specifically is very cyclic, so you will see some parts of it exponentially growing over a few years, and there are some other timelines where it's comparatively flatter growth. So that's the market dynamics. India's ambitions overall in the electronics industry, which is probably one of the fastest growing, is to reach a $500 billion by 2030. Of which we believe about 100 to 110 billion will be semiconductors. So that's a phenomenal opportunity here. If you look at the global landscape and growth, India contributes between 16 and 18% of the global GDP growth, and possibly raising towards touching 1/5 of the global GDP. What that really ideally should mean is somebody who is making investments, if they've got $100, they should ideally be allocating 1/5 of that capital towards India, and that's probably what we would ideally like to drive towards. India's technology landscape, of course, now we are got 10 projects which are approved by the government right now, 1 fab, a bunch of packaging units, and a few compound semi projects, and all of them, of course, there's a lot of capital support from the government, but given that it will drive a lot of downstream projects and requirements as well, there's going to be a lot of funding requirements coming up there. Government globally has been supporting these industries. US has announced 50 billion plus of funding. India ourselves have already done 10 billion plus of committed, and electronics is probably the only industry where the amount of budget allocated got to committed projects the fastest. So the appetite and hunger from the industry is very high, and that has inspired the ministry to actually drive the next level of PLI scheme for components, which is currently in the application phase, and we believe a really good number of players from the ecosystem will get approval through that. Given this backdrop, when I speak to global investors, probably across the last 500 conversations in the last 18 months, what I do see is nobody is ignoring India. Corporates, when they look at India, they could look at India from a continuum of opportunities. There's market opportunity or market that they can capture, that is for the sales perspective. They could look at India for setting up their back office, which is usually finance, accounting, extra, but graduating into R&D and product and innovation. So we've got about 2,000 GCCs out there. Manufacturing companies look at India for sourcing components and supplies. Of course, you get into real full-scale manufacturing as well, and that's a big boost for the economy from an employment perspective as well as long-term commitment. Also, there is AI as well as startups, which also could be of interest for these larger organizations. So that's the momentum that we overall see. From Invest India, we've got a new initiative to marry investors with policy as well as investable project. We are calling it the iCube initiative. With that backdrop, when we really look at the industry, what we see is while there are a lot of successes, there are also companies which have gone bust, filed for bankruptcies, and that really leads to the question of, hey, why did it happen? And more often than not, it's all related to their actual, how they run their business, how they manage their finances, and who best to give us insights into this. I'd like to invite the esteemed panel here. Vishal and Brijesh, would you like to do a quick one-line introductions, and then we can jump into the topics?
Sure. Thanks a lot, Vinod, and thanks for that introduction as well. And thank you for having us here. So I'm a corporate banker with close to about 23 years of experience, split between two organizations. I've been working for HSBC for close to about 23 years now. Now, as the bank, you may know, is a global bank. We're present as HSBC in 60 countries and territories with a universal banking construct which helps provide all kinds of services to its clients across the globe. So it's largely the globality that defines us. Coming down to India, I think we are as local as what we can be. We've been in the country for over 170 years. We acquired the Mercantile Bank in 1853, and since then we've evolved and taken shapes and forms to be today a leading foreign bank in the country with probably the largest assets amongst all foreign banks, right? So we've got a balance sheet size of about 42 billion. We're present in 26 cities. We've got approvals to open another 20 branches, which we will largely focus on building wealth and ecosystem kind of a banking situation for HSBC in India and try to be of use to counterparties there. So I mean, there's a lot to speak about. When you give a banker a mic and ask him to speak about his organization and what he does or she does, I think it can just go on, but I'll pass it on to my colleague, Brijesh.
Thanks. First of all, Vinod, thanks for having us here, ISM, SEMICON, and it's an honor to be here. But as my colleague Vishal was talking about banking, I've been 25 years in the industry between 3 banks, 2 foreign banks, and now Axis. We're the 3rd largest private sector bank in the country. About $200 billion is the balance sheet size. We have about 6,000 branches. We're a full stack bank from investment banking to credit cards. Our retail banking app is pretty well known. So I think today what you've managed to do, Vinod, is get one of the best global banks on the stage, and very proud that Axis is also here as a local bank. So happy to be part of this and can't wait to get started.
Thank you. Let's dive in to a topic of relevance here. Opening question, hey, how do you assess the market opportunity here? How do you evaluate investable projects? And what do you see as risks in the semiconductor and electronic space?
So I think the agenda is all set for us, and it was fascinating listening to the speakers earlier. But from a banker's lens, when we look at the opportunity, it's obviously massive. We know that India has a need. But if I just look at some of the numbers, and this is where I think the bigger story will unfold. So urbanization, for example, is one big reason why you need all kinds of gadgets, and hence you need chips. So for example, if you look at India's statistics, we're about 35% urbanized, as against possibly a China at 60, or a global average of 65, and US probably at even 70 or 80. So I think that will give one massive fillip. If you also look at the usage, so for example, for the first time, India is really chasing this Make in India dream, and I think the PLI schemes are amazing. So as that next wave, so we've already become a net exporter of mobile phones. I mean, I'm very happy and very proud to hear that, but as the PLI schemes keep unfolding, you will continuously see this need for more and more chips, and I think the opportunity is just, going to pick up from here. I think what India needs to be smart about and do is try to be at all parts of the value chain. I know it's very easy to say that it's a long journey. You start probably, we've got one fab that's launched, a couple of OSATs, but I think somewhere globally it would be nice for us to have a vision where, for example, India's become the IT service for the whole world. But if we could look at being at the top end of this, for example, there's no reason why tomorrow India can't have in the next 5-10 years some design, companies that it still won't hit anywhere near the levels of NVIDIA and all of that, but there's no reason why we can't kind of aspire for that. So I think the opportunity is massive. Happy to hear your thoughts as well.
No, sure. So I think more or less in sync in terms of what Rajesh just mentioned, but I think the growth propeller would largely come from certain sectors that we look at, right? So I think there is significant opportunity for growth within sectors such as mobile handsets, IT, technology, 5G, and so on and so forth, where there's going to be huge demand for semiconductors. And that will get, that demand will get sufficed and fulfilled by virtue of local production that we get in. The keenness with respect to an ATP or an OSAT or with respect to semi-fabs, etc., is quite high, right? I think it's only a matter of time before the first supplies start rolling out and a little bit of consistency gets built in out there, on the basis of which the positive effects will rub off on other interested parties that are waiting as well. So I think there is immense opportunity in terms of growth. Having said that, I think some challenges also remain, right? And it's only fair that we spell out those challenges too. And that would largely be around the high capital cost that is involved in such investments and proposals that come through. I think building a resilient supply chain is a very important constituent and a being successful in this space, because of late, over the last 2 years or so, we've seen many, many disruptions happen across on supply chains. So I think building a resilient supply chain is very, very critical. And of course, the technology keeps changing, right? And it changes at a very rapid pace. So for your manufacturing capabilities to be able to cope up with advanced and differentiated kind of offerings and make those tweaks in terms of your capabilities is also a very critical component. So there, I think, are the three challenges that we have. Other than that, I think specifically on things like an IoT or maybe anything on 5G, it will promulgate demand in the way in which we see this. And those will be the key opportunities that will come through. Obviously, the underpinning factor for whatever that happens is largely the support that comes in from the government through the fiscal incentives that it gives, right? So I think it's a starting point for almost all financial institutions such as ours to predicate our support upon and take the larger leap with respect to what we want to do. But yeah, so that's two opportunities and advances that I feel is quite important.
Very nice, thank you. So a bit of lens on now how this is moving, IP and design houses, and a view on supply chain. So when you look at from financing these projects, how do you assess the risks? What do you see as the risks?
So bankers take money from people and then lend it to other people. So the first thing is the safety and security of that money. It's sacrosanct. So when from a banker's lens, I think if I were to plot out the risks, one is it's for India at least, it's a relatively new industry. So when you look at a credit officer who's signing off, he's worried that there is no historic evidence. You don't know the real selling points. And as Vishal was correctly pointing out, the gestation period is so long. And by the time you get the products out, new technology has come in. So I think that is kind of one worry. There is no way this industry can take off without the government support, and it's amazing, the support that, country like India has given for this. But then there is that dependency on subsidies, right? It's almost 50 plus 20, 70%. Yeah, so then that subsidy dependency is also something that bankers will look at. And of course, we've all very well aware of the supply chain challenges. Globally, tariffs is now something that is scaring all of us. I mean, we just saw what happened where NVIDIA wasn't allowed to give chips to China, right? And then maybe only certain chips were allowed. So as the tariff patterns change globally, and you'll have some countries holding back key raw materials, which could also make life challenging in this industry. And then there is the talent pool. I was very happy to hear the first session where it was I never knew that we had such a nice lineup. Of course, I heard the gaps about it in the industry. So, but from a financials perspective, I would rate all of these as, the big risks, Vinod.
No, I think just to add, I think it's very new, as what Brijesh just mentioned, right? So all of us are learning on the job with respect to being able to evaluate such proposals. So you need to develop a view, both you as business as well as credit, while we are, diligencing these proposals over a period of time and across cycles. That takes a little bit of doing in terms of being able to put it in the right framework so that everybody understands what they're signing off on. So from a concerns perspective, I wouldn't call it risks. I mean, just want to reword it as concerns. So there are a few concerns that come up, right, in this specific industry. So one is obsolescence. Then you've got cyclical demand specifically that can specifically set in. Then you've got supply chain disruptions. Then you've got geopolitical factors. Now, these are potentially the concerns that are very high and top of the mind, and obviously the high cost of capital, right? So there are ways and means of being able to capture these concerns and try to mitigate that a wide variety of factors, right? So you can typically build up proposals with very strong collaterals. You may want to risk diversify yourself by virtue of selling down certain exposures so that you have dry gunpowder ready to be able to meet various other occasions that the project management company may come to you for. And potentially a few other hedging strategies, et cetera, that can help mitigate all of that risk and get comfortable on the situation. So that's how we see it. We're all learning on the job on this one, to be very honest. It's yet to be tested in entirety, but I'm sure it'll come through, because one important aspect that we all need to remember is there is a bit of a natural moat that is created here, right? Because of the capital intensive nature of such projects, you will only see the bluest of the blue, at least thus far, to get involved in terms of being invested in such projects. And these customers for us, whether it's globally or in India, tend to be clients of the bank, right? So we draw a lot of comfort. So that aspect of both aspects meeting together works well.
Thank you. Very interesting. You're capturing the mood of the nation. There is long gestation period that you mentioned, Brijesh, and also the cyclical nature as well as the supply chain things that Vishal, you talked about. So probably the next round I'm going to start with you, Vishal. Long gestation periods, that means you need to look at life cycle financing here. You also touched on the need for government support, which of course it's publicly visible at this point of time what's coming out. As a corporate banker, how would you look at the market scenario here?
Now look, okay, so one is financing modes over the life cycle. But prior to all of that, and first and foremost, it's largely the fiscal support that is coming from the SEMICON India program to the extent of about 50% of the project cost on a pari passu basis. That basically underpins all the other ensuing support that comes through. Add to this, the supplemental benefits that come in from what the state gives actually lightens the risk burden and makes the proposal very viable, right, for most of the bankers to have a look at. So I think the cornerstone of the entire activity is the partnership along with the government and the incentives and the subsidies that basically come through. So that's that. Now when you come in terms of life cycle financing and which modes a potential private capital or a project management company would want to adopt, I think it depends. We all know that there is an initial phase, which is basically the setup phase, and then we have the commencement of production stage, right? So in the initial phase is the most challenging one, because once you start producing and it starts hitting the market, then you'll have a lot of people coming to you and they will want to bank you and so on and so forth. So the initial stages are very critical, and that's where the corporate basically requires financing with respect to setting up manufacturing facilities, buying equipments, OPEX, and so on, right? So all of these can typically get met at that particular point in time through either rupee loans, more often through external commercial borrowings and credits, because it gives them the duration and fits the purpose as well, and obviously working capital cycle to keep them going. Now you would appreciate that the visibility on all of these projects tends to set in with the efflux of time, right? And as you move closer to the commencement of production stage is when you actually strive or endeavor to have a balance in terms of a funding mix, which is basically a matched funding profile. And that's when the partnership assumes a very different level, because then banks would graduate themselves in order to act as coordinators and arrangers on long tenor financing, which typically happens with export credit agencies, development finance institutions, etc. Now, left to the project management company and all things being equal, I think the best way for them to do it is through these DFIs and ECS from day one, but that doesn't happen because there are some practical considerations involved with respect to diligencing and the time that it takes. So yeah, so that's how I would try to break up the financing over the life cycle. So initial is through the modes in which the bank market can potentially help, and then diversify the risk out by refinancing the same thing by getting DFIs and multinationals to come in.
Thank you. Vijesh has a view from a markets guy. What would be your lens on this?
There was a time when markets were so fascinating. We were all the time in front of our Bloombergs and Reuters, but I think today all you need is Twitter and you can see what's happening. It's much faster. But you mentioned, two parts to your question. One was on policy and the other on the risks, and we did cover market risk. So if you look at policy, I think industrial policy sounds like a very boring concept, but I think it's back in a big way. We've had about 40 industrial policies globally till about, say, 2010. That number globally has shot to about 2,000 by 2024. If you look at industrial policy, of course, PLI, SEZ, subsidies, they all form part of that. And for an industry like, semiconductors, that's very important. But just trying to kind of segue to show you how things are changing globally in the same direction, which is probably good for India. If you look at government policy, there was a time when industrial policy was probably barely 8-10% of government policy. Today, it's almost 1/3 of every government policy. So the other facet is globalization. That was a massive trend going on for a while. Today, what you see is bilateral agreements. So every country is doing what is right for them, and they can deal with whoever they choose in whichever way they form. And if you look at RTAs, again, very, very massive growing trend. So while globalization is down, trade is up, but through RTAs. So from India's perspective, we do about $450 billion in exports. I'd say about only 120 billion was through RTAs. But with the RTAs being negotiated, and by the end of this financial year, I think we'd probably have an additional 200 billion going through that. So that's on policy, and hence I think all of these policies will kind of definitely help the case that we have here. From a risk, Vishal covered, and he very aptly said, there are takeouts and there are DFIs and ESAs that would have to kind of do the longer gestation takeout, because you need a massive amount of money for this. And I don't think, India in that sense is well capitalized, all the banks put together. It does help to have global banks. They have access to global pools of money. And of course, local banks will chip in where we can. The risk, again, is right now, it's very linked to tariffs. Because if you go back in history, and they say history repeats itself, in 1930s, we had the Smoot and Hawley, jump in tariffs. It was unprecedented, 60% in tariffs, 20,000 products were hit. And it was not very dissimilar to what we're seeing now. The next wave after the tariffs got settled, it takes about a year, is the weaponization of currencies. So that is what led to the gold standard being given up. Many countries just devalued their currency to offset the tariffs. It's a very easy play, right? You get tariffed by 40%, devalue your currency 40%. Think what happens to India, right? What happens if dollar rupee jumps to 120? Almost most of the goods and the financing that Vishal spoke about is going to be import-led. And if your cost goes up 15-20%, then you've thrown every project off. So I think hedging, solutioning, working with governments, ensuring the tariffs are also not too tight, make a lot of sense. So I think these are what I would look at risks, Vinod.
Wonderful. You have just walked us through history and also give us a very larger outside-in perspective. So really appreciate that. I'm going to jump onto a few sort of rapid-fire questions. So let's jump deep in. If you're looking at the semiconductor value chain, which part is the highest risk for India, starting from fab, OSAT, ATMP, design IP? Which is the highest risk?
Fab. That's clearly fab, right? So obviously, that's the riskiest one. Longest gestation period, highest amount of capital cost.
Absolutely, and which is why I think even given all the projects launched, we just have one fab at the moment, and the remaining will start as OSATs. And
okay, if you have to pick one as the biggest risk in financing semiconductor, what's that biggest risk?
What's the biggest risk?
Yeah.
I would now, as a banker, wearing my banker's hat, say yes, it's a long project with a lot of subsidies, and hence it's important that the continuity of subsidies, the confidence that the state and the center gives, to bankers to lend that kind of money would be one key factor.
Yeah, I think it's high cost of capital and the long gestation project, right? Now, it just can't be one, sorry. So I'll need to lace it along with a few others. So one's the tenor, and with the tenor is linked the high cost of capital. And then, of course, the policy measures, I think, which is again underpinning with respect to whatever you have to do. So there's no one risk. I think it's all these three put into one, which basically predicate the way in which these things will be dealt with in the future. So that's
okay, reverse question. So as a banker, what's the biggest opportunity for you?
So I think the biggest opportunity comes with respect to, advanced technologies, in my view, right? So AI, Internet of Things, 5G tech, and so on. This is going to lead to an explosion, at least in my personal view, of the requirement of semiconductors as we get along. And to get associated with these sectors and these growth segments early on will give an impetus to the bank as well, right? And I know it's rapid fire, it's a little bit twined as an answer, but I'd say that every bank has a unique mix of which cooperated banks and which is the sector that it gets involved in. Now, when both of these marry in the way in which we are thinking about it, then appetite is very naturally created.
I think Vishal was spot on. It depends, every bank will play to its strength. Probably a global bank like HSBC would probably find it easier to finance very, very large fabs, having done that in other countries. For a bank like Axis, I would think it's the whole ecosystem, because there's no way a semiconductor or a fab can function by itself. You will need trained personnel, they need places to stay, you would be building housing, you would be building warehousing, you would be building logistics. So it's the whole ecosystem, and this $10 billion which we are kicking off with will finally trickle down to MSME. So that is again a strength for Axis Bank. We bank about 8 lakh MSMEs. So I think that's where we see the whole the big action actually.
Okay, thank you very much. I think we are at the end. So really appreciate Vishal and Brijesh for your really insightful comments, both from a banking perspective as well as a market perspective, a little bit of view on history, and also giving confidence to everybody in the industry that, hey, you guys are really positive and bullish on India. Thank you very much.
Thank you.
Thanks
for having us.
So thank you for a wonderful panel. I think that having the finances right is the the most important thing for semiconductors. So, coming from Finland, my name is Meri Helle. I'm a semiconductor entrepreneur for 10 years. I had an academic and industry career before that. But now I've been looking at and studying TSMC and Taiwan and different regions very carefully, and I'm really inspired to be here in India now. I think the chip really happens here in India. But my question goes to okay, is it too loud? Okay. Oh, it's so coming from Finland and the Nordics, and looking at, for example, Northvolt, batteries made in northern Sweden. And I think they lined up the big corporations, the Volkswagens and others, to get the battery supply chain for the electric vehicles, which is a great achievement. And they got the finances and they built their factory in the northern Sweden. But then I think it comes to the ecosystem, as you rightly pointed. And for any company, it's deliver or die. And they didn't deliver. They had immature technology. So how can we avoid these holes or bumps so that we have the whole ecosystem and the whole supply chain, and we have our finances, we have the technology, we have the talent and the market understanding, and really going what we really need, what the world needs, and how can we deliver.
Thank you for the question. If I gather right, what you're concerned about is how do we get the whole ecosystem right? Because if you don't get that, it's a non-starter, right? Thank you for that. And I'll pass the mic to my colleagues as well to take that. But very pertinent question, and you've heard it all. So I don't think anyone has a crystal ball that we can look at and say that we're going to get this right. But if you look at the last 10 years in India, we had a lot of new technologies come in where people were not sure, or new industries. So data centers was new. EVs was new, right? Drones was new. And every time something like this came, they needed a bit of an ecosystem. Of course, the biggest thrust was the government subsidy. It starts from that. If you look at China, that's what they've built, right? I think with ISM, with SEMICON, we're definitely on the right track. You have a good mix of center and state, and you then, and what is good, if you look at the larger projects, they've, by very prestigious houses, they know how to navigate this whole ecosystem and bring it together. And that's what gives probably bankers confidence as well to bank some of those.
Yeah. I can probably add to that, on that, if the thinking is that the business need to be viable, there needs to have the reliable ecosystem out there. So I think the fundamental piece here is people with the knowledge and expertise of that industry, and them guiding the government, the policymakers, the bankers to say, hey, this is what it really takes. We have seen it happening in other countries. And if you look at it from India government's perspective, ISM and the leaders have been exactly thinking in that lens. That's why the theme of saying, hey, let's pick up some anchor unit to start with, to bring them in, and then build the next layer. So if you look at the ECMS, which is the second scheme as that has come out, it's really around that second layer of capability behind the first one, which was focused on mobile phones. Then we bring the second one in, so which is now we are looking at PCBs, batteries, camera modules, blah, blah, right? And then we go down. Similarly, so in every chain, the knowledge, awareness of how that industry works, what are the risk factors is number one. Second is an ability to actually reach out to all the industry players. And of course, some of them are, some geographies are very good. You know that, Japan, Korea, Taiwan, US is where some of these intellectual capital lies. How do you entice those companies to see the India opportunity on a larger scale? And that's what we have been attempting to do from government as well as from Invest India.
Wonderful. Let's make chip happen in India.
Okay. Thank you very much, gentlemen, and have a good day. Okay, I think we've got a few more minutes up there, so if there are a couple of two more questions, yes?
I think we did good for one, so thanks.
Okay, I think we're good. No other questions? There's a question there? Yeah.
The mic will come to you, don't worry. Can we have the mic, please? Yeah, there. Run, run. Bhago bhai.
Good afternoon. My name is Jagdish Kumar. I'm from SBI, in fact, Center of Excellence. We have a department which is looking into the financing of the sunrise industry, and semiconductor being the sunrise industry right now. I'm very pleased to be here. And sir, as you were saying initially about while we are looking into financing of the industry, we also have cases across the globe where companies have gone bankrupt. And recently I've reading about a company called Wolfspeed, which has gone bankrupt in US, specifically in compound semiconductor. So can you just share your experience, if at all any you have, on that narrative?
Okay, interesting. By the way, when I was finishing my first narrative saying there are companies who have gone bust as well, of course that was in the back of my mind, but I didn't want to really take out any specific names out here. I will leave the bankers, if you're familiar, to talk about, but for who are unfamiliar, one of the very well-known brands globally, and when people look at it, they had, if I understand correctly, probably about 2 billion as cash in the bank, while their short-term loans was about only 650 million kind of range. So everybody thought like they are very, very good, but it's really about that life cycle financing. There was long-term debts which was piling up, and there was lying on a few guys, and that's probably my understanding. But if you're familiar, Vishal, Brijesh, would love for you to comment on it.
Yeah. So no exposures here. All right. So let me just be very clear on that one first. Second is it's all about match funding profile, right? I think we spoke about it some time back. You need to have the mix in terms of your ALM very accurate out here, right? So you could have bridges to start off with, but then you cannot be dependent with respect to short tenor financing to roll over for a longer purpose. So I think the background over there was one, A, with respect to some supply constraints, and two, with respect to a non-matched funding profile. So that's what you need to get right.
Thank you, Vishal. Really appreciate that answer. Okay, I guess we are done. Thank you very much. We'll hand it over back to you.
Thank you very much. Let's give a round of applause. They have been very, it was a comprehensive fireside chat. And we now move on to a couple of panel discussions before we all go towards the lunch arena. It's different states of Karnataka. We all know that India is known for unity in diversity. So we have the frontliners represent from different states, turning the India's semiconductor vision into reality. Now, as I mentioned earlier, each of the state has its own unique vision, but at the end of the day, the progressive policies, infrastructure, and growing pool of skilled talent will help us in reaching the goal. The senior officials will drive the state-level semiconductor initiatives on the ground, and moderating for this particular session on semiconductors, SEMICON India backdrop, panel discussion on states implementing the various semiconductor projects. I would like to call upon Shri Alkesh Kumar Sharma to kindly come over to moderate this particular session. Ladies and gentlemen, put your hands together for Mr. Alkesh Kumar Sharma, who has worked as Secretary in the Ministry of Electronics and Information Technology, Government of India. So he knows it all. And during his tenure, he implemented very important programs like Digital ISR, Digital Governance, India Stack Global, Digital Public Infrastructure, Digital India Language. And let's give a round of applause for Mr. Alkesh. And I can see the panel now is like a team, so all the panelists are accompanying the moderator, Mr. Anurag Yadav, Principal Secretary, IT&D, Government of Uttar Pradesh, Mr. Ravi Kota, the Chief Secretary of Government of Assam. Let's hear it for them. And Mr. Bhaskar Kattamneni, Secretary, IT, E&C, Government of Andhra Pradesh. We are expected to be joined by Ms. P. Bharati, Secretary, DST, Government of Gujarat. She's just sent in a message. And also Mr. Vishal Dev, Principal Secretary, Electronics and IT, Government of Odisha, also will join in just a few moments from now. Well, A couple of lines before they take over, Sri Anurag Yadav, the Principal Secretary, Department of IT and Electronics of Government of Uttar Pradesh. His career reflects his unwavering commitment to public service and his continuous efforts to drive progress and innovation in Uttar Pradesh. And talking about Mr. Ravi Kota, the Chief Secretary, Government of Assam, well, has been a gold medalist with a PhD in agronomy, joined the Indian Administrative Service, and brings in more than 3 decades of experience along with him. He has played a key role in fostering deeper engagement between the US and India's economic partnership. And of course, it's a very important aspect on the part of Mr. Ravi Kota, the Chief Secretary, who has put in a lot of efforts. And Mr. Bhaskar Kattamneni from Government of Andhra Pradesh also is a senior Indian administrative officer, and he has contributed towards Andhra Pradesh's all-round infrastructure, education, and healthcare sectors. So, without much ado, the panelists are all ready to go. Let's give a round of applause, ladies and gentlemen, and welcome the panel, because this is very important. The decision-making is the key in a country like India, and these senior officials will drive us through. I'll now straight away hand over the session to the moderator, Sri Alkeshji. Over to you, sir. It's all yours.
Yes, so good morning, and thank you for joining this session, my distinguished panel members and friends. You know, as we have seen in last couple of sessions, and of course, in the inaugural address, as the Prime Minister spoke about the ecosystem. So we have to build a strong ecosystem as India marches towards, going to the next chapter of this new journey in semiconductor. We thought India needs to create an ecosystem, and an ecosystem which should be strong, which is built on the basic pillars. And the basic pillars of any important ecosystem, it includes right from creating a world-class infrastructure, utilities, as somebody said, water and power, most important, and the logistics and the supply chain systems that goes along. We have to create a good set of workforce, skilled manpower. Availability has to be ensured, both at cutting edge level as well as at the deep tech level. We also have to ensure that while the project is under execution, there will be different challenges. What are the risk mitigation framework and the systems? We also look at how strong is the multi-stakeholder coordination framework in the state. And we also have to look at the kind of incentives and the regulatory environment which the state has created over a period of time. While Government of India, while I was there, as Secretary, we started this India Semiconductor Mission, and the applications were invited, details were worked out, all 5 components of $10 billion project which was started under ISM, right from building fab to creating, the display system, the compound semicon, and all ATMP and OSAT and design-linked incentive scheme was started. We also simultaneously started working on creating workforce, because we knew we will be needing a massive number of skilled manpower. So we created chips to startup system. We also created, we brought in almost 238 odd universities in India, which will actually work on that. Create a pool of talent, which will be needed by all, at all levels. While Government of India will be giving incentives, will also enable skill development programs, rope in universities and institutions, IITs and other institutions, but it's ultimately the states. We work in a federal system where union and the state governments, they work in tandem. And all these 10 projects which have been sanctioned in last 3 years, 22 to 25, we find that actual action is in states. And where the states are proactive, where states have been able to create an enabling ecosystem, the investor community has started moving to those states. And now we see that my distinguished policy leaders, they are the ones who are creating policies, creating framework, also ensuring that things get delivered on the ground. So they are here. So I think without doing much ado, I would straight away go on to the questions. I think two states which have taken the lead, where work is actually on the ground and in the execution stage. I think I'll begin with those. Of course, it was Gujarat which started first, but we are waiting for the Secretary of Gujarat to join us sometime. But before we go to that, I would take you to the next state which is important, and that is Assam. Assam, if you talk about Northeast, you know, it's an emerging economic semicon hub in the Northeast. They have really created a system and have actually changed the perception and the image of Northeast. The things get delivered fast. And that is being done not by none other than the Chief Secretary of Assam. We have Mr. Ravi Kota with us. I would ask you, Ravi, what have been the facilities in terms of infrastructure, utilities, the kind of logistic support? So what are the facilities which you have created which actually have brought Tata to set up their OSAT plant there?
Thank you, sir. First of all, I would like to mention it's a proud privilege for a state like Assam to be part of emerging semiconductor ecosystem in the country. Thanks to Honorable Prime Minister's vision to get involved such an important region of the country, which is the springboard for the Act East policy of the country when we are looking at ASEAN countries and that kind of economic relation in semiconductor kind of industry. And when it comes to the nimbleness and the fastness and agility at which Assam government moved, February 2024, Union Cabinet approved the project, and by August, the Bhumi Pujan was done. There so many steps were involved in between. So we had an excellent piece of land, which was earlier a government sector paper mill, central government sector. So the land was with the state government. In the south, there is a lush green huge hill. Then there is a huge plot of land through which the National Highway 27 is traversing through, and a railway line next to it, and hardly any distance from Guwahati. So that land identification happened so fast, and we have at a nominal rate, we transferred the land to Tata. Then the water is another important thing. Next to this, there is a river called Kopili, and pristine rainwater is available. So we are constructing the pipeline. And the green power is something which is already there in the system. And also for future, we signed an MOU with another arm of Tata Group, Tata Power, to develop the green energy that in due course of time it's available, and the power grid and other kind of a connectivity is also at the doorsteps and readily available now. And the work is going at a faster pace, and 48 million chips capacity per day plant. Now 1/4 of its capacity, we are expecting it to get ready by next June. And the new terminal of Guwahati Airport is getting inaugurated by Honorable Prime Minister very soon in the month of November or December. Existing terminal getting converted into a modern cargo handling facility so that the sophisticated semiconductor kind of a thing can be handled. Then there is another important project is coming up, Guwahati Ring Road. So the Ring Road will have kind of a component for a smooth transition from airport to the semiconductor plant. And skills part, both IIT Guwahati and Nailet University of Meiti, they also have been, we are closely working with them. And apart from that, we have very unique ADB funded Assam Skill University, with which also we are working. And Nailet University, we have given the land next to the plant. The university campus is going to start, but meanwhile in Guwahati University, they are starting the training and capacity building programs very soon. Lastly, the soft component is about that whole the township we are developing. There is we call it as a Ratan Tata Electronic City and also township. Next to that, the land has been identified and the initial stages of the project preparation with substantial amount of almost 8,000 crores of estimated cost will be involved in developing the complete township requirements with the ADB assistance and other MDB assistance and with our own funds. And the work hostel around 5,000 capacity has already been 750 people capacity has already been, this work has started. So we have been trying to develop, and at the same time, lastly, I would like to mention that last 11 months, if we count 17 high-level delegations from Japan and other countries have visited. That shows how important and how keenly they are watching the developments, and that has helped us to understand their requirements also. Yes. Thank you, sir. Thank you so much.
Yeah, I'll come to that also in my next question, but let me move on to UP. You know, the Uttar Pradesh has been doing a transformative work. The way they have developed their infrastructure, the way they have been attracting investment. And one of the states which used to be called laggards a couple of years ago is one of the most promising and potential state. So now let me ask Anurag, what are your infra plans to basically, quickly grounding and, bring operational readiness into semiconductor plants?
Sir, I think to begin with quickly, we already have Foxconn SCL, which has been sanctioned by India Semiconductor Mission, and the state is working on that. But I'll take just 1 minute to elaborate on how we see the whole ecosystem or the chain of semiconductor mission.
Right. So we talk about infrastructure. I'll follow on questions.
I'll just elaborate a bit
focusing on infra and utilities.
So if you connect what state is doing with something called in philosophy, we say man se, vachan se, karm se. So what's our ideology? What is our thought process, which is man se? So we visualize, we have a vision where we say that India ka time aayega ya aa gaya hai on these critical technologies. So when we look at semiconductor mission, it has already set a vision for India, and with that vision, the state has aligned its vision. So now once you have got the vision, how do you translate it into policy is vachan se. So we have got a semiconductor mission policy, which is aligned with Government of India's policy, where we facilitate all the required infrastructure. And because there has been some existing physical infrastructure advantage to the state of Uttar Pradesh in terms of electronic manufacturing already, we have Noida, Greater Noida as an electronic manufacturing hub. We dedicated a large piece of land for semiconductors. It's more than 1,000-acre park, which has been dedicated, designated zone, where every ready-made infrastructure has been made available. So it's kind of a plug-and-play facility where you have, whether it is power or water need or other connected infrastructure. So basically the physical infrastructure is already in place, and a firm needs to just invest itself, come there as a plug-and-play. Now when it comes to Karm Se, so you have the physical infrastructure, and what we facilitate is by complementing the policies in terms of giving capital subsidy, land subsidy. So land subsidy is 75%, which is I mean almost like a free, because 75% of the subsidy on the land cost with 100% exemptions on stamp duties, with duties exemptions on electricity. So what we are trying to do is it's creating all those ecosystems which can facilitate somebody to make a decision of making investment, particularly in such capital intensive sector. So we have been successful not only with getting Foxconn, but there has been other intents also with other firms.
And those proposals are already been cleared by cabinet of the state, and we are awaiting probably maybe ISM 2 we are expecting very soon from Government of India, and those proposals I believe will be cleared. So we can say that we will try to emerge as a hub for semiconductor, because we also have a very good ecosystem in terms of research and development. We have 2 ITs in UP, particularly IT Kanpur has all, I would say, all its alumni are, if you see any IT company, you will find IT Kanpur there. We have IIMs there. We have more than 1,500 technical colleges, which provide a ready-made R&D HR, I would say. So you name a company in IT sector, so from design to manufacturing, I believe end to end now, UP will emerge as a hub of semiconductor. And I think if there is another question on anything else which UP is offering, I'll be more happy to answer. Thank you, sir.
Oh, thank you. Yes, so you talked about plug and play facility. Now let me move on to Odisha, because Odisha has actually emerged as a dark horse. I mean, it started, but then I am sure with 2 projects in hand and many more to come, I think they have really started attracting semicon investment with a very proactive approach. So I would like to ask you, what is your infrastructure facilities where you are going to set up these facilities, and how do you ensure that the water and power redundancy, which is important for these kind of projects. So how does Odisha work out on their infrastructure projects?
Good morning, sir, and good morning, everyone. So before I think we go to answer these specific questions about utilities, sir, I would like to take a step back and just talk about Odisha in general, because it's important for any company to know about the state that they are planning to go to.
I'm sure they would have seen that. So I'll come to my next question will be on that also. Okay. What is your policy and how you have come about? Odisha had really made a mark. So maybe, a little about that, and then on infra alone. Yeah. Okay. Then I'll be having other questions, talking about your policy and your skill and all that. Okay.
Sir, what I wanted to say is that over the last 25 years, if you look at the development that has happened across the country, I think Odisha stands out among all the states when it comes to transformation. Between 2000 and now, if you look at it, we were a state which was in dire straits. I mean, Anurag spoke about Bimaru states. We were even lower than Bimaru states. We were right at the bottom when it came to social indicators and all. But today, if I just give you a brief indication, Niti Aayog released the Fiscal Health Index about 4 months back. Odisha was the #1 state on that. We topped the Niti Aayog's fiscal, and we've been known as a fiscally prudent state for quite some time now. We've been growing at a rate which is at least 1% higher than the national average growth rate. The gap between the national per capita income and the state's per capita income has narrowed from 31% in 2015 to about 8% now. So growing at the current pace, sir, we should be exceeding the national per capita income in the next 4 or 5 years. So I think it's important to kind of, put things in perspective about where are we coming from. You look at health indicators, the highest reduction in infant mortality rate, the highest reduction in maternal mortality rate over the last 10 years has happened in Odisha. And currently, the national government, all the states promote institutional deliveries. We were nowhere, when it came to healthcare and institutional deliveries. We are currently at 93%. We are #4 in the country. So the idea is, of course, we want industrial development, but what is happening as far as the overall state is concerned, because I think that is what companies are bothered about. So today, it will not be an exaggeration if I say that Odisha stands out as a model of good governance in the country. I can name many other things. We are a leader in disaster management. You talk of sports development, we've created a model which kind of is being replicated across the country now. And by the way, if you type sports capital of Odisha in Google, you will be sports capital of India in Google, you will be surprised to see that Odisha figures over there. So this is, the general context about the state. Coming to the specific point of infrastructure. As far as power is concerned, we are a power surplus state. We provide part of the northern, southern grids. We were the first state in the country to take up power sector reforms, unbundling of transmission, generation, and distribution. The first state in the country to have privatized distribution. Our distribution sector is run by Tata Power, and 3 of the 4 distribution companies in Odisha are ranked among the top 10. So power surplus state, also the cheapest power in the country. Our industrial power tariff is rupees 485 per unit to 5 rupees 85 per unit. And on top of that, sir, we give a reimbursement of 2 rupees per unit for a period of 10 years to semiconductor and electronics industries because it's a thrust sector. Our IT parks are located within 15 kilometers from the airport. We currently have 2 IT parks. The electronics manufacturing cluster is located in a park called Info Valley. Overall 750 acres, of which the electronics cluster part is about 210 acres. That's where the 2 new companies which were sanctioned by the Union Cabinet last month, they will be setting up their units over there in the EMC cluster in Info Valley. Land has already been allotted. In fact, we have site visits by the companies on the 5th of this month. On the roads, again, just to give you an example, in 2000, we were spending about 3,000 crores. On roads and bridges, the current year's budget is about 20,000 crores. And we have also been, since 2017 onwards, we've been the #1 state as far as Pradhan Mantri Gram Sadak Yojana is concerned. So roads, you have to come and see for yourself. I would not really like to say anything on that, sir. We have an international airport, and Odisha was also the first state in the country to introduce VGF for international flights. We were very keen that we start international connectivity. We have international connectivity to Bhubaneswar. We were the first state to provide VGF, and even today we have flights running from Bhubaneswar to Dubai, Bangkok, and Singapore, which are part funded by the government through the VGF.
Thank you. Thank you, Vishal. Now we have Bharati from Gujarat, and I must say that Gujarat was the first state to announce Semicon policy, and I was part of that also. And of course, I was part of Semicon city, because the city which they have declared as Semicon city was Dholera, which was built by us when I was CEO of the MIDC. And this building where we are sitting now has also been planned and executed when I was CEO of the MICDC. So with those, I think Gujarat has really taken the lead. We were the first mover. So you have to tell us what kind of infrastructure, the kind of utilities in terms of power and water infra, as well as the supply chain. What is that Gujarat has done, which has really attracted, I think 3 of the 4 of the 10 have actually gone to Gujarat. So you should tell us what have been your selling in terms of infra alone.
Sir, extremely sorry, sir. I'm attending another roundtable, and sir, as you mentioned, sir, a lot of hard work happened in Gujarat, sir, and especially this logistics and utility and infrastructure we talk about. Gujarat, sir, in regarding power, we are the power surplus state. We are the #1 in government of India. We have reliable, redundant electricity supply. Not only at DISCOM level, we have redundancy at substation level, and as well as at we'll be reaching at grid level also. Sir, we are having in fact two DISCOMs, sir, one government and one private. And when redundancy, we are having we have supply from our DISCOM, as well as now with power grid, we are having one more redundant level connecting to national grid also, that we are going to achieve in Dholera. And sir, out of total installed capacity, 54% is green power also we are having. Then second, sir, water security. Sir, in Dholera we have 100 MLD committed good quality potable water, and with water treatment plant, which is currently at 50 MLD water treatment, which will be extending up to 150 MLD. And then Sanand, sir, which is a cluster-based our GIDC cluster. We have 90 MLD water treatment plant. And sir, we have underground complete network of gas, internet, all utilities we have underground networks. And common effluent treatment, we have 20 MLD at Dholera and as well as 10 MLD at Sanand. Sir, logistics, you all know, sir, we have 19 airports with 3 international airports, and we dedicated international airport at Dholera, and dedicated expressway for Dholera, and world-class infrastructure and social infrastructure is going to come up in Dholera, sir. And in with 2.0, ASM 2.0 and EMC 2.0, we are going to have warehousing solutions, especially semi-grade warehousing solutions, globally benchmarked common clean room facilities, not only for fab units, also for tools and other testing units also. So sir, these are all coming up. We are going to gear up for next round ecosystem plots. Right now our policy is, first phase is for anchor units and industry critical enablers. Then we are going up to for ecosystem partners and all. So sir, we are fully geared up, sir, Gujarat, for infrastructure, social infrastructure also.
Thank you, Bharti. In fact, this will be the one of the world's largest greenfield industrial township, 922 square kilometer, which is bigger than Mumbai or Chandigarh or any Indian city. And I think we have putting up a 5 gigawatt solar power also there. So that plant is also there. So, yes, I think now I must turn to Andhra Pradesh. Mr. Bhaskar, you have also been a pioneer in IT development, and now they have moved into SEMICON space. So tell us, you have got your first investment there. So what is the kind of infra and which are the regions where you are going to set up SEMICON facilities?
Thank you, sir. Thank you for having here. Of course, sir, we are the youngest state in the terms that the last state to be formed is Andhra Pradesh. And which makes it really a startup state in a psychological sense. It's not in terms of infrastructure. So we are very hungry for development in that sense. And we are a very unique state which is going to do things second time. Like as a combined state of Andhra Pradesh, along with Telangana, we did Hyderabad. Now we're going to do it again. So we have this experience of doing it the Hyderabad, so we do it again. So we're quite confident doing that. So the first project that we got, the oversight project with ASIP, 2 weeks back the project was announced, sir. We are confident that before 90 days of the announcement of the project, the construction on the physical construction on the project will start. So those are the timelines with which we are looking, because we pride ourselves in not only in a sense of ease of doing business, but speed of doing business. We take quick decisions and we stick to it, and then in a very nimble way we want to move forward. And we have been blessed with certain physical attributes. In terms of geography, we are blessed because the region of Rayalaseema, which is basically sandwiched, basically it's a triangular region between 3 huge metropolitan regions of Hyderabad, Bangalore and Chennai. And historically these places have been rain-fed areas under the rain shadow region, not much of rainfall, which made these regions backward, which in turn ensured that the land values were cheaper. But fortunately over the last 2 decades, we were fortunate to get water from different areas where the entire country was talking of linking of the rivers. This discussion was going on for a few decades. We actually linked the river Godavari with river Krishna, where we do intertransfer of around more than 100 TMC of water in a season we transferred. That water we have now brought to the Rayalaseema region. I am happy to announce that just about yesterday, the water from the surplus water from river Krishna has touched the southern boundary of the state with Karnataka. Reached a place called Kuppam, very close to Bangalore, and we brought the water there. And other side, Anantapur, which was like, I think, which was only next to the Rajasthan, Jaisalmer area in terms of the water deficit, is now the horticulture capital of the country. We produce a lot of horticulture crops because we could get water from the Krishna. So what I meant to say is that we have water available, we have surplus water available, and this water is going to be there because anyway around 3000 TMC of water goes to sea, which nobody can use it. That water is going to be surplus for ages to come. So we have water available, and power anyway we have surplus, and as I speak, around 60 gigawatts of green energy projects have been on the works across the state in the same Rayalaseema region, and that can be used, and of course energy that is going to be cheaper, and we try to provide energy at a very cheaper cost, and not only at a cheaper cost, a very good quality energy is available, and over that we provide subsidies. Like, I don't want to repeat the subsidies, almost all the states we compete, maybe a difference of half a rupee or 1 rupee there, but power subsidies we do provide. And another thing that core advantage we have is that, in terms of IT industry or in terms of hardware industry, anywhere you go to any state, in fact you go to US or most of the high-tech industry sector you go, you ask a people full of IT and hardware guys, if there are 100 people, you ask them, raise hand, how many of you speak Telugu? There is a very likelihood that 1/3 of them are Telugu speaking people. We have that core advantage because of the kind of human resources we have developed over the last 2 decades. More than 150 good solid colleges churning out good graduates, and also polytechnics, ITIs. So what we are trying to do with this semiconductor thing, we're not spreading it across the state. So the semiconductor industry would be spread across the region between Bangalore and Chennai. So 5,000 acres we have 2 hours away from Chennai airport, similarly from Bangalore airport, 2 hours away from Bangalore airport, another 5,000 acres, we're keeping it ready with all the infrastructure, and where the semiconductor industry can really start off. We are looking at the entire value chain. We may not be looking at a big fab factory like Gujarat, but we want to do the entire value chain, all the parts of the ecosystem to develop, with good R&D to be developed. And one thing which we are promising every industry that comes is that the day the industry comes to us and we go to them, in fact, is we go to them, we sign them up before they construct their factory and they start their production. The number of the talented manpower they require, it's our responsibility to start finding the people, training them. We are converting the local ITI and polytechnics to focus on that particular core technology, train the people, make them ready the day the factory starts. You have the people available, and 25% of the kind of shop floor requirement is there. Every year an additional requirement will keep on churning out, and making them available, good quality, talented people is one thing we bring to the table, and a policy framework which is like nimble and which is very forthcoming and not without much of a lot of red tape. And we pride ourselves that though we say that we give all clearances in 21 days, 21 days is an exception. We generally do everything before that because the entire ecosystem works on a very singular platform, and we aim to do that. As I committed that the semiconductor proposal which was cleared 2 weeks back, in 90 days that the groundbreaking and the construction will start in the 90 days. That is what the commitment Andhra brings to the table. Thank you.
Thank you, Bhaskar. Yeah. So while all the states have got an enabling policy which is acting as an enabler and a catalyst, and also the kind of skill workforce which is being developed in all these states. But there have always been, when you look at regulatory and implementation framework, there are always bottlenecks, either on the statutory approvals, regulatory issues, implementation challenges. Now, how have we addressed that? Let's begin with Gujarat, because you have implemented, while you are developing these, 3 industries are coming up there. Now, what are the kind of implementation challenges you faced in terms of regulations, in terms of, availability of man, machine, materials, Or is there any other change, the kind of risk which you faced, and how did you address those?
Sir, not exactly challenges. We understand the specific needs of semiconductor industry and what are the complexities involved. So we are aligned completely with ISM, India Semiconductor Mission. So we parallelly formed a GSEM, Gujarat State Electronics Mission. We have a dedicated...
If I can be a little more focused, you know, one of the issues which come time and again that they have to go for all kinds of approvals, water connection, power, environment, you know, and they have to go from pillar to post. So have you created a mechanism whereby, you know, I mean, we talk about national single window clearance, but now, have there been those bottlenecks in spite of all this, which is still there?
Yes, sir.
So how did you address those? Because your projects are coming up very well in time. So how did you address those issues? And had there been challenges? So how did you face
This GCM, sir, which I'm talking, this is the single point facilitator for, sir. We have dedicated nodal office for each company, and the highest level from GSM, then as a secretary, then chief secretary, sir, and honorable CM, sir. We have regular meetings for multiple departments, issues we solve at every week. That is one thing, sir. We understand that more than policy framework, this governance and facilitation is more important. That's what we have learned, sir. So in fact, sir, during this in construction, we understood that we had to change some special economic zone regulations. So we are coordinated with Ministry of Commerce, and we could do it that also. And one more to increase female participation, if we had to change some rules in Factory Act. So those things also, whenever we face challenges with highest level commitment and sincerity and speed, we follow it up and we are doing it. That is the plus thing we understood, and that is the most important than just and incentives also, sir. Very, very fast driven governance we are following, like within 7 days. In fact, we commit that within 7 days that we'll, in the TRA agreement also, we commit ourselves that we'll give it within time. And sir, these are the things which are evolving, and as and when we face it, we are able to
you have a system and a mechanism
system in
which
place. We have streamlined that administrative procedures.
Yeah, and if we go look at Assam, I think when we talk about Northeast, you know, project implementation challenges have always been in our minds. You know, every time we talk about, when I was looking after highways, you know, it's always, it used to take longer. But all that is changing. The perception is changing. The way Assam had changed, they have adopted a good strategy and your program management approach. So would you like to tell us about your implementation hurdles and how did you overcome those hurdles, especially in your Tata project?
Thank you, sir, for asking this question. In Assam, after quite some time, I mean, tea, oil and gas, after that, if there is any biggest investment, that too one investment of 27,000 crore coming, semiconductor and OSAT plant of Tata, is something very watershed kind of a moment for the state. So this particular project with the Tata team, our work and our principles are very simple, and we know that there have been many challenges in day-to-day implementation. The first and foremost point is that we don't initiate these, I mean, addressing these things through paperwork. So our Secretary Industries, Dr. Lakshmanan, who is sitting here, so he has weekly meetings with the Tata team at the site, and along with all those individual members from the state government, whoever are the stakeholders. Each of those minutest of the point, wherever it is, I mean, one way it's a micro kind of a management we do. Then every 15 days, as Chief Secretary, I take a meeting and see that what are the areas we need to improve and expedite the things. So the decisions are taken, and thereafter we follow up with the paperwork. And thirdly, Honorable Chief Minister also takes every fortnight the kind of a, what is the updation status and what are the challenges. That is number one, and therefore many of those usual kind of a problems of getting permissions, approvals, and working with various other stakeholders, they are hardly there. And the entire government, the whole of government has that approach that this particular industry is an industry of the country. And this is a very unique kind of, this is one big kind of approach by which we are resolving a lot of issues. Second thing is about even Tata team as such, because we have experience of doing bigger projects like refineries, etc. So the moment of out of size dimension kind of equipment and all those things, how to move through river Brahmaputra or by road, or some of the things, how to get them fabricated on the site. So that those decisions Tatas have been able to do quickly, and we were able to connect them to various other experienced industries who are already doing job there. So that's the second point. And third point is that, and wherever the issues, Tata team need to have some kind of a decision should to be done by their headquarters. So highest level we coordinate and we get that expedited also. So in this way, we have been able to move forward as per the schedule and in a record time. And so therefore, by early next year, we will have the formal production of at least 1/4 capacity.
Thank you. Yeah, Vishal, you know, stakeholder consultation and coordination with all the stakeholders is very important for implementing projects. Now you have got 2 of these projects. What is the kind of hurdles you face, and what is your stakeholder coordination mechanism which we would like to Assam, no, Odisha. Yes, Vishal will work on that. Yeah.
Sir, we have a fairly well-developed ecosystem in the state, sir. There are currently about more than 500 companies, including all the big majors, and about 60,000 people in Bhubaneswar who work in the tech sector. So the system is kind of attuned to the working and the requirements. We've also brought about necessary changes on the regulatory compliance issues, sir, Labor Act, Factories Act, etc., allowing women to work for 24 hours. So all that has been done. We have a system of monthly meetings, sir, with the industry stakeholders. There is a forum, and there's also an online grievance portal. So the endeavor is to try and see that all issues are resolved within a week's time. We have, on the approval side, sir, we have a online single window mechanism which has also been awarded and very well recognized. So the state level single window meets every month, clears projects, and thereafter, if required, if more than 1,000 crores of investment is happening, it goes to the Chief Minister's high level clearance authority. But on the regulatory side, the challenge that I'm sure all my colleagues here would agree, the biggest hurdle that I think we as a country face is obtaining environmental clearances and forest clearances. That is something which we've not been able to solve as yet. And the maximum amount of delay from the time that you've identified land for a project till you invite companies to invest and they start their project, I think the maximum delay happens in obtaining environment and forest clearances. So that is where, sir, I think we as a country need to work.
I think, Anurag, you also probably would be looking at some of the challenges and hurdles. So what is your coordination mechanism? I'm sure because your NCR part, you know, there are a lot of industries, and the SEMICON, you know, SCL Foxconn is already coming there. They've got approval now, they have to ground the project. So what is the kind of coordination mechanism so that you are able to handle those things immediately?
Sir, we have been evolving day by day on the issue, because these are the issues, sir, where there cannot be a full stop. So whether it was beginning with the ease of doing business template which was circulated to states, and looking at those templates, we tried, I mean, if just to give a history on that. So state made all those requirements when we had EODV ranking, and we reached to second in the country on that. So what it entails into when it translates on the ground, you have to have institutional structure. So like others, all my colleagues in other states have suggested, sir, probably all of us are now following single window clearance. All of us are following online systems. So UP also has been on that, sir. We have a template where all 30, 40 clearances which are required are counted. But what we do is that, sir, we have a dialogue regularly with the investor who is coming and trying to understand what are the bottlenecks. And this process is, sir, evolving all the time. So what paperwork has to be converted into a digital form, or what has to be reduced, what compliance burden has to be taken care of. All these, sir, there has been a focus, I believe, from ministry, from the center, and the states are also following it, sir. So within UP, I would say that it's a responsive regime. It's a timely response to whatever issues comes into. And issues like, for example, you rightly said, sir, issues like water, environment, these which take some time. So how do you, how can I reduce, say, for example, environmental clearance for a mega project, which has been, let's say, taking 180 days. Now from getting this study done for them, EMP plan has to be put in place, and getting our meetings done timely, getting it clearance from whatever layers are there. Let's say there are 4 layers to get. You put time compliances and you monitor it. So what we are trying to do is that if a number of 180 days can be reduced to, say, 30 days, can we achieve that? Maybe in one project you achieve 30 and in the next you try to do it to 15. So that is how I believe, sir, the states are evolving, and in the state of UP also, there is a focus on that. And what I said in the initially, sir, that you have to do it through your man, vachan and karma. So that's the philosophy which we are working to facilitate. And I believe earlier, I mean, when I came into the service, sir, we were more like regulators. But in 25 years of my career, I would say, and with guidance of seniors like you, sir, we have become facilitators, and we are now today trying to every day, I mean, whatever we have learned from our the legacy which has been there, we are trying to improve upon it day by day, sir. That's how I will try to put it. So.
Thank you. Yeah, I think this is important. You know, when you talk about environment clearance, I'll give you an example how we handled it. You know, when we started these greenfield industrial township, right from Dholera, Aurangabad, you know, Greater Noida. So what we did, we took the environment clearance for the whole town, the whole city. So now there is an upper limit on the air quality indices and all that. As long as you are within those, you don't have to go for a separate EC. So whatever units we have set up in Aurangabad, we have in Dholera also these units are coming up. They don't have to go for. So Odisha can take a leap from that. And I think Odisha also is part of NICDC corridor. So you check up how they are doing it, and that would help you. Now let me come to Bhaskar. I mean, when you talk about e-governance and services to the people, I think Andhra had taken the lead. Now tell us, what is your coordination and stakeholders consultation mechanism which expedites projects and avoids delays?
Yes, sir. Thanks for that appreciation about e-governance initiatives. Sir, all the state governments, mostly in India now, are in a single window online process that is very well established with fixed timelines and all. That's all good, sir. We do that. In fact, we are the pioneer state doing that. Now, what we do is that unless we actually sit on the other side of the table, we don't understand what the industry goes through. So what we have done is that our approval committee has the members from the industry on the approval committee. Not only the industry associations, but individual industries are there on the approval committee. But the government entities, officers are not a majority on that. In fact, the majority is headed by the industries themselves, so that they will appreciate this thing, how much time it takes and all. Not only clearances, they have the 2 tasks. One task is that, of course, approving it, approving in terms of the project approval, the approval of the DPR and approval of the incentives, and approval of land pricing, electricity, subsidies, everything is done by this committee, which is mostly having the industry associations and industries apart from the government officers in that. Thereby, we want to achieve that, what industry feels a little bit of a problem, disadvantage, we want to do that. Apart from that, sir, this is a fixed day meeting. It's not that, we push around files just trying to get a meeting to be done. This meeting is done every Monday on a fixed date. So that all the proposals which come during the week get cleared that week. And the next week exactly, the Thursday, the cabinet meeting is done. So that we push all these clearances, whichever require cabinet clearance, to the next cabinet. In fact, last 1 year, almost 31 cabinet meetings have happened to clear such proposals, so that proposals which require the highest level clearance also do happen. And these are part of what we now call a real-time governance system, in which the clearances also become part of the different parameters. At the highest level, the Chief Minister and the CS also monitor, which includes industrial clearances and permissions also are part of the real-time governance system that which we have, we monitor on a real-time basis. By having, I think, the industry as a major stakeholder in approvals and also in also analyzing and reviewing the process of approvals, I think we are able to give a little bit of additional advantage to the industry in getting things done faster. Sir. Thank you.
Thank you. Yeah, now we all know that these Semicon projects are capital-intensive projects. Government of India is already giving 50% subsidy. They're going for Semicon 2.0 now. The next cabinet note should be coming. States are also giving a lot of incentives. Now, a lot of money that goes into this, but then we need faster project development. So I would like two of you to tell us what are the, how do we bring in a strong center-state collaboration so that the projects get, grounded faster. So I'll begin with Assam. Ravi, you are the senior most, so you should tell us center-state collaboration. Is there anything which is missing now in this complementarity?
So in fact, perhaps the last Semicon India 2024, we would have been thinking that no more projects should come. Now I think we are all talking about the ecosystem with more than 10 important projects are here. So when we talk about the ecosystem as a country, like Gujarat may come up with a very robust infrastructure, and Andhra may come up with its skilled manpower. UP, Noida may be its proximity to the domestic market. Odisha, its strategic location. Similarly, Assam, our location, strategic location to Southeast Asia, etc. So when we have this kind of a strengths identified as a country together, in fact, often we hear about the unhealthy competition between the states. But at a particular phase, that unhealthy, quotes unquote, competition may be required to initial stage when the first kind of a company is getting into this. But I don't think now companies are really looking for incentives kind of a thing. Incentives anyway it's given at a particular, but beyond a point, incentives alone will push the companies like a semiconductors to get into that. So therefore, when we are talking about the ecosystem, the collaboration with central government is inevitable. And our experience is that we work like a one team. When we were working about our incentives, our policies, whatever, even till today, we are like skill development, and whoever IIT Guwahati is going to help in train or NAILET University, those kind of a people in Assam getting trained can be used anywhere in the country and elsewhere, and vice versa. So that kind of a collaboration, and even when we worked out this incentive policies also exactly, we worked with the MAITI and Semiconductor mission that how much you give, how much we have to give. Not only that, when we are administering these incentives and other kind of a things, that rather than repeating the kind of a the so-called scrutinization of the claims, follow when Government of India has released something and automatically you release the whatever you committed in terms of the proportionate kind of an amount. And so in every aspect there is a huge area of collaboration. Without that, when as a country we are going to create an ecosystem, there is someone should be, as a nodal point, should collaborate, should coordinate with all these states. So that kind of a things, we see that it's happening. And perhaps as we move forward with more entrants from the private sector into the semiconductor industry and more states playing the role, I think we can bring that kind of a synergy among all the states.
Good, thank you. Yeah, I think it's important. And a connected question, which is again, we talked about center-state collaboration. You know, now we also look at the quality of infrastructure that we need for semiconductor. It needs a lot of funds. Resources are limited. Can we look at, creating semicon hubs, which could be interstate? Like probably Odisha and Andhra could join hands, and like we did it in NICDC, industrial corridors. We have set up hubs which are connecting interstates. So Vishal, would you like to tell us, what is the possibility of doing something similar? We did it in industrial corridor, but in semiconductors, environment, can we do something in this sector as well?
Sir, it's a wonderful idea. And I often say that all our policies, ultimately become a race about which state is offering more incentives. Now, again, if we take a step back, sir, India is a small player when it comes to the global semiconductor industry. I think all of us should work towards increasing the size of the cake, by which mechanism each state will have, sir, its own pie of the cake. And in some other areas, sir, we've thought of this interstate collaborations and the idea of having regional hubs. One region, having certain strengths. For example, on the East Coast, again, Assam and Odisha have that strategic location of being closer to the Southeast Asia part. So we could perhaps look at catering to Japan, Korea, that Southeast Asia market. So that is one. The other thing, sir, you asked about was how do we see that projects are executed faster. So when the number of projects is smaller, for example, in our case, we had RIR Power Semiconductors come last year. Groundbreaking happened on the 6th of September. They will now start trial production in December, and they will be going into full-fledged production in March next year. So less than 2 years. What we did was we put a dedicated team to support them, sir. And we will do the same for these two, the new projects which have been sanctioned. The issue is when the number of companies or investors coming in increases, how do you institutionalize this mechanism? So that is another area which we all need to think about, introspect, and figure a way out. So.
Thank you. Yes, I think we have only 3 minutes left, so I would stick to the timeline. Now, I would like to ask each one of you, one of the best practices which you have, especially Gujarat and Assam, because you have implementing projects, which you think is needed, either the best practice or the precaution which we need to take to ensure that the project get executed faster, especially in semicon space. So I'll begin with Gujarat. Bharti, your view, 30 seconds.
Sir, best practice, sir, I feel multinodal coordination, sir, and regular meetings and following up, and dedicated officers for each projects, and collaboration with, as you ask, central government, and strong governance, sir, and with a lot of clarity and understanding the semiconductor industry specific issues. This clarity is more important, and lot of ambitions also, so that we could act faster and to come up with this semiconductor revolution.
Yeah, I think we should plan better so that execution becomes faster. Yes, Ravi, your.
Perhaps, sir, I also say the same thing, but in a different manner, because we have, like Bhaskar is talking about this ease of doing business, real-time kind of a governance is something all the states are doing. But for this kind of a project, those things keep happening. Beyond that, there are a large number of surprises, they keep coming. For that, the real-time governance is that governance only it is happening in the sitting across on the project site or in an office where all the stakeholders are there. And that team has that authority to decide on the spot and follow up with the documentation, whatever is required, and do it. And we have weekly cabinet meetings, and most of the cabinet meetings, as an informal kind of an item also, these issues come and get decided there. I think that is the best part of what we could experience in Assam as a matter of a best practice.
Fantastic. Yeah, Anurag? Any precaution or any best, you know?
In the state of UP, yes. Is it working? Yeah. Sir, in UP, if you ask me one single practice, so sometimes it is considered as politically code, but actually it works in administrative and institutional manner. Is called double engine ki sarkar. So when we use that term, it basically means that the vision from the center, and particularly for such critical technology sector like SEMICON, I believe this is one of the best representation of a federal structure where a program of such national mission importance is getting rolled out across the country in form of a semiconductor mission. This would be probably one of the finest example of federal structure, sir, where ministry has constituted semiconductor ISM, and then states have become the entities as a body to carry out that program. So if we both work in synergy, probably, and that is what, if you ask me as a state of UP, one of single thing, I believe we would like to carry forward that vision, and that is what we practice, sir. So if I have to share this with my colleagues in other states, I would say that please look into what ISM is doing, and with them you start, I mean, you कहते हैं कंधे से कंधा मिला के, with them and you will be able to resolve issues. So that's what I would like to say. Thank you, sir.
Thank you. Yeah, I think I'm lucky that we have all our panel members are double engine Sarkar. Of course, AP is part of NDA, so they are also double engine. Yes, Bhaskar, your one-liner comment on any precaution or any best practice for executing, you know, SEMICON projects fast. Because we are already, time is up, but then we still, I would request him to give us a minute.
Yes, sir, I'll be brief, sir. Best practices, I'll just tell an incident, sir. Our minister one day sent me a WhatsApp message in which a guy not from my state, he runs a small mill where the wheat flour is made. He put up a saying that India shines. I required 21 permissions to run this mill. That moved him. He said that if I can order something online, I can get something on Swiggy and Zomato by one message or one this thing. Why can't he get everything, you know, in one message? So now, sir, all the permissions that you required, we put up on a WhatsApp message. On a number, you just have to send a hi message to it. And then we pick up all the data sets, what permissions he require. They go to the departments, permissions come back, and automatically, seamlessly, we can push it back to him. It is not fully done, ideally not done. We still get some problems in some department, they get stuck for a day or two. But I think it's one good step that, you know, we can do in which, you know, seamlessly somebody can ask for it and, you know, and then he can get it delivered online virtually without actually having to go through even through a web service to apply for it. It should be as seamless as just sending a small text and, you know, getting this thing. For small things, you know, for small industries and all, of course, very high-tech things and all, environmental clearances and all, might not be possible, but fairly 90% of the cases, I think it should be something which should be possible.
Vishal, your one-liner. You are concluding it.
Sir, I'll say two lines, sir. One is, sir, our online...
two lines is okay.
Online single window clearance mechanism. It's very comprehensive. It's not just about applying or putting your proposal online. It's also about providing all clearances, water, power, everything through the system. That's one. The second is, sir, Odisha is very particular, and we've kind of refined the art of whole of government approach. So we have a concept called Team Odisha, where all the stakeholder departments come together as one, sir, and we deliver as one. So we normally say that it's Team Odisha which is delivering. So these two things stand out.
Thank you. Thank you. I think time is up, so panelists are already available. I think we can have discussion offline. I would like to thank each one of you for this wonderful discussion, and thanks to each one of you for listening to us patiently. Thank you.
Thank you very much, Mr. Alkesh Kumar Sharma, for moderating this session. And yes, all the esteemed panelists, Ms. P. Bharati, joined in late Secretary, DST Government of Gujarat, Mr. Anurag Yadav, Principal Secretary, IT&E, Government of Uttar Pradesh, Mr. Ravi Kota, Chief Secretary, Government of Assam, Mr. Vishal Dev, Principal Secretary, Electronics and IT, Government of Odisha, and Mr. Bhaskar Kattamaneni, Secretary, IT and E&C, Government of Andhra Pradesh. Thank you all, and in fact, they have explored the discussion to a next level, giving momentum to the Indian semiconductor revolution. Thank you all, sir, and as our moderator mentioned, they will be available offline to take some questions. So thank you very much. Now, in the interest of time, we now move on to the discussion prior to the lunch interval, and the panel discussion on the various state policies. Emerging horizons, unlocking new frontiers for semiconductor ecosystem in India. Well, ladies and gentlemen, you would all agree this will be another highly strategic discussions wherein the state policies would attract global investments and at the same time catalyze innovation and drive ecosystem development. This session explores how emerging Indian states are positioning themselves as the next destinations for semiconductor manufacturing. I would request all the audience to kindly clear the way in front of the stage, please. Please do not have any discussions. I would request our friends from Semiconductor Mission to kindly usher them away. Well, the session will be moderated by Mr. Ajay Prakash Soni, the former Secretary of the Ministry of Electronics and Information Technology, Mighty Government of India. With a career spanning both state and central government, he is recognized for his leadership in advancing Digital India, promoting e-governance and shaping India's electronics manufacturing ecosystem. So please put your hands together and let's welcome Mr. Ajay Prakash Soni onto the stage, please. I've told them, no, somebody has to go and do it. I've announced. Sir, excuse me, sirs, all the senior officials, sir, kindly take your seats, please. Don't think otherwise. Please be seated. We have another session. We have Mr. Rajamanikam, Advisor to Guidance Government of Tamil Nadu. Please put your hands together for Mr. Rajamanikam. Humble beginnings to becoming a trusted entrepreneur and voice in the semiconductor industry. And that's the journey behind IVP Semi founders Rajamanikam. Vanakkam, sir. Please come over. And we also have with us Mr. Sanjeev Kumar Gupta, the CEO of Digital Economy Mission, Government of Karnataka, contributing and accelerating the growth of the state's digital economy. Namaskara, Gupta aure bani. Please come. And thereafter, we have Ms. Ritu Sain, Investment Commissioner, Government of Chhattisgarh, a distinguished officer with over 2 decades of impactful public service and known for her globally acclaimed women-led waste management model in Ambikapur. Hearty welcome to you, ma'am. Namaskar. Shri Deependra Singh Kushwa, Development Commissioner, Government of Maharashtra. Yeah, kindly come over, sir. Has received several awards and in fact contributing immensely as a distinguished record of launching initiative to upskill youth and foster startup innovation. Let's give a round of applause for Shri Deependra Singh. Yeah, please come. So this will be a very interesting session, and without much delay, I would straight away hand over the session to Mr. Ajay Prakash to take us through. Over to you, sir.
Thank you, and thanks for inviting us for this session. I think we have a very distinguished panel, And we've just gone through a wonderful discussion. We have seen this discussion with the states which already have projects that are sanctioned by the India Semiconductor Mission. And now we have states which are among the leading states in industry development in many ways. And they already have huge presence of companies that are likely to go in for semiconductor projects. And I think we'll have a discussion now on what are the learnings from states that have already gone in for such projects. What are the preparatory actions that other states are making and can make? What are the learnings, especially on incentives? You know, especially I would like to focus a little bit on what should be the focus of center and then what should be the focus of states, because I think the two sets of incentives are somewhat different. So, we'll move on from there. So I think we'll start with Mr. Raja Manikam. He's actually representing the government of Tamil Nadu, and I was also mentioning to him that he is the person on this panel who knows this industry extremely well. He's been a part of this industry. He's been very much an expert in many, many issues. And first of all, your perspective on, you know, what is it that Tamil Nadu has as a conducive ecosystem for semiconductors. How are you with what kind of land parcels you have identified or hubs you have identified as potential areas for such activity? And what is your advice to the government and to other governments on the preparatory action?
Thank you, sir.
Yeah.
Thank you. Thank you. Hello. Okay. Yeah, this is working. Thank you, sir. First of all, you know, I always wanted to be an IAS officer, but I then ended up being in the industry. So finally, I fulfilled my dream of sitting along with the IAS officers. So please, you know, send me this picture so I can say I'm one among them. So I think, you know, from a Tamil Nadu standpoint, it's a very progressive state. Unfortunately for the state, there is multiple, you know, electronic manufacturing units that has been there for the last 10, 15 years, and it's growing very rapidly. And the workforce as well, right? You know, you probably know there is tremendous, you know, engineering skills all the way from PhDs to, you know, technicians and all that. So I think in a way we're fortunate in this state compared to some other states. But I think, you know, one of the important things that has come about is they've identified within the state the strengths in each of the regions, right? So what is the Chennai region? What's the Coimbatore region? What is the Trichy, Tirunelveli, Toothukudi, and so on. And each one of them, you know, brings certain strengths. So if you look at it from, you know, I come from the industry, and the industry, besides land and all that incentive, right? So they're looking for the strengths of the local place. So for example, Coimbatore is a place where there is a lot of, you know, mechanical innovation that happens. You know, naturally it has been there through decades, right? They're just very good at, you know, re-engineering stuff, right? Very good at mechanical stuff, re-engineering. They build the pumps and, you know, stuff like that. So I think, you know, one of the things is mapping out the strengths of each region. And, you know, my advice, if you may, right, to all the other states as well. Each state has got its own strengths, and within that also, right, there is pockets of strength. I've worked with Bhubaneswar. I see some strengths over there. You know, there are strengths in Pune, for example. It has got some unique strength, and so on. So I think, you know, one of the what the
state has done to really, grow, not only, to entice, foreign companies to come, but also, indigenously develop. I think we've got to understand the strengths of it and then incentivize them from an infrastructure standpoint rather than, just land and money and so on. So I think that has been the experience of the state.
Yeah. So, Sanjeev, I think let's talk about Karnataka. Karnataka, I think, is home to the largest sort of ecosystem that is very close to semiconductors. So tell us something about what is it that you feel are the strengths, and apart from the existing strengths, what kind of preparatory action are you looking at?
Thank you, sir, and thank you for giving an opportunity to being here. Karnataka has been a leading state in tech industry. Bangalore is called the 4th largest tech cluster of the world. We are also called as the semiconductor perspective, the 2nd largest in the world from a design services perspective. Sir, just to let you know, we are 100,000 chip design engineers right now in the state.
How many?
100,000.
100,000.
Right. So we have around people of those kinds of working in different parts of the chip designs as well. The ecosystem in the state of Karnataka is very, very different and unique. As I said, from a semiconductor design perspective, leading to design to now the assembly and testing and packaging. Some part of it been there for long. In fact, Radhaji set up the TISOL was another part of this long time back, almost 2 decades back. And then from there onwards, the entire journey of testing, validation, looking at certification, systems designs came into place. Manufacturing, EMS facilities, and the backward integration of PCB fabs, looking at the other elements. I think this entire ecosystem of end product manufacturing of electronics from the basic of chip designing is there. What unique has come forward, sir, in a couple of years is, I would say last 4-5 years. One is the Center of Excellence on Design that we set up called SAFAL. And sir, under your leadership at that point of time, it also reached a stage where it showed the map of how a design link incentive can be planned for the country as well. So the DLI called up eyes for design and engineers to look at those initiatives. I think that's an ecosystem. This has a little deeper root because the startup and innovation ecosystem in the state of Karnataka is amazing. As you all know, out of 105 unicorns born, 52 are born from the state of Karnataka alone. Right? And likewise, these unicorns. Under the ESDM, sir, we have got this fabulous startups playing a very important and key role. And some of the chips are getting tipped out right now, and which is upfront and which is very one. RISC-4 and us are on the pipelines as well. The other element is the other center of excellences on different kinds like Sensi, Center of Excellence in ISC campus, which is of a horizontal layer, look at nanoscience, material science, going into different domains of healthcare and etc. That's another area. Then look at the areas of IoT and etc. The next point, the uniqueness that the Karnataka state has, the R&D facilities of the Fortune 500 companies. Out of Fortune 500 companies, 400 R&D capabilities there. So you have an ecosystem of very different kind and unique in the state. But sir, I go back to that point which we were discussing earlier. I think my point of view towards the India as a brand is more important than a state brand. And I think that's where we have to play a card where, as Radhaji was talking about, we need a mapping of the strengths of each state and locations. Or not all the locations are fertile lands. Figure it out, the strengths of these each, map it properly, brand India, and then take an India mission to, because we are fighting with Malaysia, we are fighting with China, we are fighting with Vietnam. So in fact, some of these fabs are looking at Vietnam, which is, I'm surprised, how it can be possible. I think we need to fight with those type of countries as a brand India. And brand India comprises of the united nature or sense of the states, sir. It is nothing as brand India without states, right? So it's a state's brand which comes up. How do we cumulatively pick up this as an India brand and position it? And how do we drive the competition with the other countries and get this investments coming to states and wherever it comes, on the strength of wherever the industry feels far better. I think that's my one single point of request and submission to the larger audience and the government of India as well, to consider that. I will take a pause here, but maybe next question.
So one of your suggestions that becomes an action point is maybe when ISM organizes some visits to other countries, states should get included, and so that a number of states get an opportunity to showcase their strengths and actually convince the companies to come in. The first thing is that we have to convince those companies to come in.
Correct.
Where they come in is the next aspect.
Exactly, and I think that this, thank you for raising this point, sir. We feel industry is what? Industry for India is a client outside. If a client is getting confused with my ABCC strengths, I don't think that we're doing the right job. So what we need to do is to have the clients understand that what India offers,
yes.
right? And in that way, India should lead it. So for example, MITI or Invest India leading a mission to, let's say, Taiwan or South Korea or Japan or another Middle East country, or anywhere in Europe. Netherlands is another hub for semiconductors. So we need to take a mission there. Take the strengths of the states, share the perspective to this, let it buy the India brand, let them come back. And then they should come to every state and look at their respective policies, benefits, talent, ecosystem, decide what the best is supposed to be done. I think that's where my humble submission would be.
Right. So, Ritu, you are the commissioner, investment commissioner for Chhattisgarh. And I think you already have success in attracting some semiconductor player, significant one. So what are you planning by way of infrastructure, by way of enabling steps, by way of any policy tweaks to the policy that you already have in place? Tell us about that.
Namaskar, sir, and thank you for having us here. First, sir, I'll tell you that why we could attract people, and the reason is that my co-panelists, they don't have and they cannot have that, and that is below 60 AQI and 20 minutes of commute time in Naya Raipur. So I think in a city which is developed with a vision to develop it as a IT hub in central India, and with Chhattisgarh's location, which is like a bridge between north and south and also east and west. But along with that, what we have is four things very clearly. Surplus power, 24/7 with no downtime. And that's going to be there because we are with the highest installed capacity of thermal power in the country. And that power comes very cheap at competitive rates like 4.75. In the previous panel, Urisa was saying that they give it at 4.85 or so. So we become the cheapest in terms of availability of power. Again, with water, the water is available. And Naya Raipur, we have created that capacity in the city itself because it's a greenfield city, that the water is available. And particularly water is available for such industries, where they have the water for these industries, like the pure water we were talking about. The third thing we have is the raw material. I mean, you name any mineral which is required for this industry, and we have that in Chhattisgarh. And Naya Raipur with like world-class amenities with the fiber connectivity and all that. So in terms of the physical, placement of the industry, the most important thing any investor wants is that they get these services, plus their investment should be safe. So, sir, in terms of seismic zones, Chhattisgarh has this advantage that we are natural disaster proof state, because neither we are in seismic zone, nor we are in cyclone zone, nor we are in flood zone, nor we are in drought prone zones. So that way, naturally, you are in the investments are in safe zone. The one more thing which any investor would look at would be the policy stability, political stability, and fiscal stability. Sir, in fiscal stability, the Chhattisgarh stands second in the Niti Aayog's Fiscal Health Index. The policy stability, we have launched our policy last year in 2024, and it's going to be there for next 4 to 6 years. In political stability, we again have double engine Sarkar, and Chhattisgarh has been a politically stable state with very low, law and order issues. And the example and evidence for that is, sir, that the state has, after formation, has grown 20 times in manufacturing sector. And the per capita income has also increased 15 times. We produce 25% of steel of India, 16% of aluminum, and 15% of cement, which means that the state has got that industrial ecosystem which can help any investor to get that confidence that this state is safe for my investment. And then the last, the incentive part. Right now, even the MATI's benchmarking says that the state offers best in class, the most competitive incentives. And if the screen is visible, I mean, they range from 38% to 52% depending on the investment size and employment size. And then, sir, the best thing which we have done is that we have brought these both indicators. I mean, we are not looking at only 1,000 crores of investment, we are also looking at the employment generated, and we give a factor advantage of employment. And sir, last point, which could be the last slide of this presentation, is that seeing is believing. So we are not just showing it, because the state is mineral-rich state and we have fiscal surplus as well. So what we promise, we have been able to offer. And sir, the case study, and I would end with that Polymetech, which has come to the state, sir, 45 days, within 45 days, we gave the land. Within 60 days, we grounded, and we gave the bespoke incentives within this time period. So this is what Chhattisgarh offers in terms of this industry. It may be a different thing that in ISM we have not been able to figure a place so far, but I'm sure in the coming days with these strengths, not us, but the industry would come to us that they want to be in Chhattisgarh. Thank you.
Oh, wonderful. Yes, yes, please.
Came to my mind. See, a lot of what Chhattisgarh has to offer really is, I mean, it's the first time I'm hearing about Chhattisgarh, and please pardon me. There's a lot of strengths in that state, which could complement, strengths of some of the states, right? Like what Sanjeev was saying. So we map the strengths. Right? Imagine if both of us go together to a potential investor, right, to come to that. I think certainly we will win, right? So that is the strength of India, right? What Sanjeev was talking about. So I don't know whether there is any mechanism for states to work, right, and saying, look, I mean, certainly, I mean, I'm not from the state, but I work with the state. Very difficult for Tamil Nadu to give 50% subsidy on power, right? Or some of the things that you're talking about, in terms of minerals and all that, right? I can foresee there is a significant amount of manufacturing that happens at pre-wafer fab, right? So that could be an area that requires a lot of power and so on, which Tamil Nadu will not be able to take, even though they might the investor may have comfort because of previous things that we do, or maybe the infrastructure. But we could go together and say, look, this is how we approach it. And from some of the talent that we have, some of the, could complement this. So I would, we got to figure out how, we pool together the strengths of the states, instead of, we're trying to compete for every project, and we will come out ahead with the investor in that sense.
I think that's another takeaway we have from this discussion, that the semiconductor industry is not just, the items which are currently included in the mission and budgeted for. Also wafers have to be, the raw material, the chemicals, so many other things have to happen. So it's the entire ecosystem that we are aiming to go in for. So the ISM could also sort of map which are the best locations for different stages of the materials, and which is where the companies are already existing, where they can be strengthened, where new ones can be brought in for instance, chemicals that go into it. Applied materials is there in a very big way in Karnataka, and many others, Merck and others are there in the country. So I think that kind of mapping also will help, so that brand India and suggestions from India as a country, that these are the best locations for you, and these are the 3 or 4 which you might like to visit and go forward with.
Incentivize, maybe ISM could incentivize when states work together, right, to create that kind of mechanism where they're incentivized actually to work together, and whatever you get from ISM from the center, that's one of the criteria could be.
Eventually, there will always be a point where the states are going to compete. I have been in this game for quite some time, for decades, and I can tell you that there's a point up to which we will work together, and then we will compete. So that's in our DNA. So over to Maharashtra. Dipendra. So Maharashtra is a powerhouse for industry. So what is it that you have in mind when you think of semiconductors, and which are the players you expect? There are existing players in Pune and in Mumbai and everywhere. So headquarters of a large number of companies are in Mumbai in any case. So what are you looking at? Is your current incentive policy or industry policy adequate? Do you need some tweaks? Are you thinking of some tweaks? Which are the areas you are sort of positioning to be semiconductor locations and for different parts of semiconductor ecosystem? Please tell us about that.
Sir, am I audible? Yeah, thank you. Sir, thank you so much for giving us this opportunity. As a country, we have a lot of potential. As a country, we have a biggest market for this semiconductor. It's a captive market available with us. I heard many of the states are doing almost same, giving the capital subsidy, giving PSI benefits, giving land subsidy, ease of doing business. On the similar lines, Maharashtra is also very aggressive to attract all such investment, and we do give all such incentives, whatever has been shown by any of the states. So we are no different from any other state, sir. But in our upcoming policies, we are bringing the electronics and semiconductor manufacturing mission. And under that mission, we are going to set up certain parks, because this is going to be used in various sectors, like defense sectors, like solar manufacturing, even electronics and display and manufacturing. So we are going to set up dedicated parks for these particular sectors, especially, and some of them will be in the semiconductors, so cells manufacturing and chip manufacturing. Second important part is we are bringing new policy for this, but not only electronics and semiconductor policy will be able to drive this mission. We are bringing 12 more policies, additional policies, and every policy will enable the manufacturing of semiconductors in Maharashtra, and this other policies will also create a demand for these particular things, and this will create a holistic ecosystem. So manufacturing of semiconductors allied by the manufacturing of other products which are required to create a holistic product, we are bringing 12 such policies. So in terms of current ecosystem, Mumbai and Pune definitely is the existing hub of electronics manufacturing. We, as a state, Pune is known as the electronic capital of the state, but we are bringing Nagpur, Nashik and Chhatrapati Sambhajinagar as our upcoming electronics hubs in this particular sector. our focus in each policy is on tier 2 and tier 3 cities. So what is required to support this sector? Basically 3 things. One is infrastructure, so we are creating these parks. Second is the policy ecosystem, so we are bringing multiple policies. Third is important is about the skilling ecosystem or skilled workforce. So in Maharashtra, we have best of the best colleges in each and every part. You go to Pune, you go to Mumbai, Nashik, Nagpur, everywhere we have hundreds of engineering colleges and management colleges. Now in our new education policy, we are adding these subjects, especially the emerging technology subjects in the curriculum of the schools and college education. So this will enable the students to get the knowledge at the very early stage of these things, and this will help them build their skill and get ready for this particular sector. Sir, we are also aligning with the sustainability and green initiative, how these things, emerging technology and the industrial growth can go together with the sustainability. So we are working and we are bringing a lot of new and additional provisions to support the sustainability.
So the major financial incentives are basically offered by the center, and center has the resources to offer such incentives. So should the competition among states be much more towards enabling infrastructure, facilitation, on-ground facilitation, and do we need to be a little careful about what we promise by way of the fiscal kind of financial kind of an incentive? Are upper caps a useful tool in that? Do your state policies have that or already in place? How do we make it sustainable? Because this is just the very beginning. And of course, the first few investors are always given an extraordinary kind of incentive package. But as we move towards more and more, how do we make it sustainable for the country, for the states? The country possibly has much deeper pockets, but for the states, I am aware, all of us have worked with states, and states have a somewhat limited capacity. So what should your limited resources really focus on? Let's concentrate on that. Raja Manikamji.
Yeah, I think this is a very, very important question. I think in some cases, I think we may be setting a dangerous precedent in the sense that, each state is trying to outdo each other, 20%, 25%, 30%, and so on, right? So, since I have seen this, across many countries, right, the incentives that are given, between the center and the state is significantly generous, in my opinion. And there's no equity stake as well, right? The government doesn't take any equity as well, which I would say that, consideration should be given to taking some equity, in the future. I think, this is where, the focus should be a lot more on the infrastructure and building of those kind of things, rather than, financial incentive, because, as a country, right, we have limited resource and it's not sustainable in the long run as well. So if the companies are coming just for that, right, then it's a dangerous precedent. My suggestion would be that some of the states, coordinate this so that, we don't end up, upping each other, rather than, create, infrastructures that will help in the longer run.
So a lot of focus on infrastructure, a lot of focus on on-ground enablement, quick decision making,
yes,
and help with when a project comes in, they need help in all kinds of ways. You need urban infrastructure because these are not, just factory floor workers. They are highly educated people who will be working there. They will aspire to have urban, infrastructure available to them for their families and for their staying. So that, I think, requires in some places it will require some effort. dormitories and housing arrangements sometimes requires an effort. So what is it that one could do in that direction? Any thoughts?
Sir, I think if you look at a futuristic perspective, right, fiscal incentives, I think every state gives the almost equal there. So there's nothing very different marginally here and there will be a difference on that. More important is if we can turn this investments or subsidies to a different manner. A, if we are giving a power, can we give a clean power? Because at the end of the day, the product which is going to be serving the world can save the planet. So how do we create much more clean power and green power which can add? So example, if I talk about Karnataka, we are 55% plus renewable sources of energy from a total production of the power. So that when we say to our industry, say, look, we are giving you 50% clean power, right? So that's one way of looking at investments to go into field. Second, sir, investment would be should look into of the talent side, which is very, very critical. And the talent, we can say, sir, we have, Karnataka, we have 1,777 ITIs, 325 polytechnics, more than 250 engineering colleges. But that's okay. More important is what is the quality of the talent which is coming out and productive in the environment immediately. And that is changing so fast in the industry of the semiconductor design, electronic systems. You pick up an electrical vehicle, sir, right? Domain changes. Go to space technologies, the game changes. Likewise, medtech, the domain changes. We need to have a very highly skilled people coming out, which are domain specific on the technologies. And that's where the investment from, I would say, a little bit more focus on those parts. The third element, sir, is about the innovation. Tomorrow's world is so unpredictable, it can be a little bit of safer grounds if we have a pathway towards designing that what is the innovation ecosystem is there in your location, in your cluster, or in your state, which can infuse the growth of an engine of an economy in that level. So the investment should be how do we create industry partnerships of center of excellence? How do we create more startups coming up in those domains? What are the mentor ecosystem that we can bring into the part of it? Sir, if you go to any of the industry of the investments, the fiscal incentives, because the government of India has great commitment of 50% fund, very attractive, sir, very attractive. But apart, if you remove this part of the part for a while, then the decision is based on only two things, not on the fiscal incentives. You tell me your talent ecosystem, your industry ecosystem current today, and your innovation ecosystem. If these three are wonderful here, and I think every state will have to invest those cycles into it to make a much more stronger pitch out of this. That's what my legitimate experience says, sir.
Rituji?
Sir, I absolutely agree with whatever is said, but there is one element, which is the state-specific context. So the needs for Tamil Nadu and Karnataka may be very different, and the needs for states like Chhattisgarh and Jharkhand may be very different. So though fiscal incentives are offered by states to attract industry, and everyone knows that that's not the only criteria. So to my mind, states like Chhattisgarh, they need to invest the money in three things. One is, of course, developing that infrastructure, which is both the physical infrastructure specific to the industry and also the social infrastructure, because these states are new, upcoming, and they didn't have that ecosystem in place, which is required to sustain and retain that highly skilled talent and workforce. The second is also the skill development part, because we also have like many institutions, but they may not be equipped with the right kind of courses, right kind of equipments, right kind of, the infrastructure in those campuses. Third part, which I'll again come on the incentives, a state like Chhattisgarh will have to offer those incentives to the non-core industries. Like in our state, we don't offer incentives for steel industry because that's already the core industry. But for industry like semiconductors, IT, electronics, we need to offer, because somewhere the industry needs that incentive, that extra bit from the state to make it viable in that state, to complement the gaps which that state might have. So that's the clear reason for us when we were making our policy, that how do we give industry that push or that boost to make that spreadsheet look attractive for making investments in Chhattisgarh. And sir, I would say the fourth part, which is also like which is very important, but we give very little focus in enhancing the state capacity to deliver, which includes everything, which includes putting the right system, giving the right exposure, building the capacity of the people who are going to ground these investments. So somewhere we need to keep that building state capacity and the institutions in the state to make these investments viable, sustainable, and ultimately profitable for the investors. Thank you.
Yeah, thank you. Dipendraji.
Sir, in terms of infrastructure support required for this whole ecosystem, industrial infrastructure, social infrastructure, and allied infrastructure. So we are working on all the fronts to provide the best of the infrastructure in all the sectors. Like in Maharashtra, we have 300 plus industrial townships equipped with all kind of ready infrastructure. We have one of the best in the state, country, plug and play facilities to come and start. But that is not suffice. But people go and will work there, so they require quality city life, city infrastructure. So state is heavily investing in the city infrastructure as well as the social infrastructure, especially education, health, and the skilling component. And that is going to make Maharashtra or any state, whosoever is going to invest in this particular sector, allied with the industrial infra, will get the more benefit and will get more investment and will survive for longer time in terms of industrial growth and industrial development. Maharashtra is a 50%, almost 50% urbanized state. And two of our cities falls in top 10 cities of the countries, Mumbai and Pune. So we are definitely building necessary infrastructure, including metro and road connectivity, educational institutes. But we are focusing, as I mentioned earlier also, we are focusing on tier 2 cities. So this will help us to stop the migration from smaller towns to the bigger towns, and we are creating necessary infrastructure there only, and we are trying to hold the talent pool there only, and we are trying to bring a regional balance by doing this.
Yeah.
Sir, if I add a point here,
please.
Permission. Sir, the investment that we are achieving today is great to begin a semiconductor industry in India. But look at the technology which has been there in the world. Are we attracting the latest technologies to come here, or are we attracting the a bit later, decades-old industry here? Good point for begin, maybe it's a decade old. But our aspiration should be very high. And in this aspiration, I think the effort of the states comes into play. I just request that what will happen if the quantum hardwares are available in the market space? Right? How is it going to change the world in terms of the semiconductor industry and the related industries along it? Then from material sciences to power electronics to other PCB materials, the resistors, active and passive components. So if you divide the entire value chain from this part and the latest technology of quantum building in, then you will find at least, I would expect, 10 to 12 different segments of this value chain. And in these 10 to 12 segments of value chain, we require an expertise of knowledge, expertise of industry, and expertise of innovation coming in place. So can we find out 10 to 12 hubs in the country which are popular for the best resistors are designed and manufactured in this location. The best material sciences research happens here and the production happens here. The best chemicals, the PCB fabs here. And then the entire fabs can come in any place in the country will be happy. Bring an industry, bring an academic institution together in that location and drive the powerfulness. Where we say is, how can we leap forward from the new technology, but designing a new technology altogether for that purpose. So maybe we want to leap forward rather than just copying what is happening around it. Where the states combination will come into place. I think that's another request to ISM 2.0 to look at seriously to see that how do we create this ecosystem for future now, not just competing with ourselves. Just want to add with that.
Yeah, the entire comprehensive ecosystem, including those things which are leading to semiconductor, which are feeder industries to semiconductors.
Correct.
Within semiconductor industry as also, one very important thing is design. And almost anyone can engage in design. Each one of the states has excellent institutions. So how do we, I'm sure, we don't even have to discuss in Tamil Nadu and Karnataka and Chhattisgarh and Maharashtra, and almost every state in the country today has excellent educational institutions, IITs, IIITs, Indian Institutes of Science. So what do we do for talent at that level which gets into design, and it's two elements to it. One is the element of providing ready workforce for design entities. The second one is creating our own products and bringing the business to fabs. So how do we go about doing that? What are your strongest institutions? What is happening in that space? Is it adequate? Do you feel that something more needs to happen? IIT Madras, for instance, is extraordinary in this area.
Yeah, I think, see, when we talk about incentives and so on, right, the trend is always to go and attract some big company to come, right? And usually it's a foreign company, and we go out of our way to roll the red carpet for them and give all the money and so forth. I think I would defer to the Taiwan model, where majority is a homegrown, right? The TSMCs and ASE, MediaTek, they're all homegrown Taiwanese companies. And I think for India, that would be probably the better model than, trying to attract all the, MNCs and so on. I think, we need some of this, and it's probably the GCC mindset that we have. But I think for semiconductor, we could be a lot more indigenous. There are people like me, we're very passionate about it. We don't have too much money, and we don't have a brand. But there's a lot of passionate youngsters who are very smart, geniuses within our community. And each state, maybe focus a little bit more on funding these guys. I usually call it, adopt a startup. Because, they get very frugal money. Adopt them in the sense that, maybe, pair them with an Indian industry. And the government, backs them up. A lot of startups which is very passionate, and if you look historically, whether it's Qualcomm or Broadcom or AMD or Intel, they're all started by very passionate engineers, not by businesses. So I think, and we are, a country full of passionate people, for various reasons. But I think, that support system, I think it's a little bit more skewed towards, the larger businesses. And in semiconductor specifically, the creation happens, the innovation happens at this, where people are very passionate about. So maybe, a lot more states can do is how do you, incubate them and build them to become, great companies. So that would be my suggestion, sir.
I think wonderful suggestion that concentration on incubation is as important, because we need to grow the next generation which will really build our own semiconductor entities as well. So there's one point, Rajamanikam-ji, I'm tempted to ask you, because you know the industry, you have seen it from inside. Entire growth, almost the entire growth of semiconductors in China happened through relocation of existing old nodes. A lot of it happened through relocation. I think at least about 18 to 20 existing fabs shifted from the West, and they mostly, one or two I think probably landed up in Korea at the right in the beginning, but later on they all landed up in China. Do we still have, should the states look at Are there any more existing fabs, old nodes, which are ready to shift and which can be very good candidates to target? Because they are much lower investment, and that gets you going in that sector. It will establish the ecosystem, and then based on that ecosystem, bigger players will also come in.
Yes, I think you're absolutely right. Motorola went to China, NXP went, NXP part of Motorola, they went to China, and many of these, TI, I'm from TI, we put a fab over there. So all of them, right, Chinese, learned a lot from this, right? It'll be 2 or 3 generations behind, but that is an excellent learning curve. And we need to learn how to walk before we run. So there's no question about doing this. Unfortunately, I think, even though we have rolled out very good, incentive plans, we don't seem to be attracting that, right, for some reason. So here again, right, I would think that, maybe incentivize the local companies to do a joint venture with some of this and bring the older technologies. Within 4 or 5 years, right, we'll get to a point where our expertise in this area will be quite enough, right? Then we can go and, and scale it to the next level. So certainly, I think, that's a path that China took. And, they're reaping the benefits today. And I think for Indians also another criteria, very good thing about us is we make do with very little that we have.
Yes.
Right? So when you have a lower technology node, our designers will figure out how to, get the maximum out of it. And through design skills, there are certain things you can do. So I think, that kind of, will be very different from, the Western approach, to solving a problem. So, but give them the ecosystem, the infrastructure to do it. I think you're right on the spot. Let's try to get it, as quickly as possible. It doesn't matter, whether we get 28 nanometer or so. We get 65, 130 is good enough. And then we have, sensors, MEMS, and all other things that will go along with that.
Yes. Sanjeev, your take, would it be a good policy to sort of help existing large industry players and encourage them to acquire, these and bring them in?
Sir, absolutely.
Because numbers will not happen only through the absolute new greenfield investments. That will take too long a time.
Sir, absolutely right. And my experience in this field is that in the last 3 years, we were actually discussing with one display fab, which is old enough to shift with lock and barrel. I think the questions comes up is, let's say X company, their great leaders wants to come out, bring that entire fab along with it. They will raise some funding from somewhere. But the confidence on them to make it happen is very less by ourselves, because there is no big brand which is coming up. So the problem here is that we need to find some solution in thinking in an ISM, that how do we pick up those great engineers who are passing out, they have convinced their parent company to give that part, bring them here and set up with the part, and they will also looking at a vendor. So we have experienced that. Unfortunately, we couldn't solve the problem. The second piece is today, which is a golden opportunity for us. China is becoming a very complicated and complex environment to operate for many of these East Asian companies, Taiwanese or Koreans or anyone who has set up their facility there, even the US. It's a golden opportunity when now ISM and maybe all of us together can see that how we can shift that entire stuff from China to here. They shifted from West to China, but they are not Chinese company. They're actually outside China company. We can bring them here. And that should be a very special package and a policy for that perspective which can attract them. And some of them could be in the fab side, somebody could be into the component side, somebody could be and manufacturing products of various kinds. So I think we can divide that, and then the strength of the states will also come in. So it's a good suggestion, sir. I completely agree with you. Experience is there that I've seen myself. There are 2 different locations where I've interacted with them. Unfortunately, we couldn't solve the problem, but I think if policy comes up, it will definitely help.
So apart from design, which everyone can get into, I think this is another area, because you all have huge industries already existing with you. Huge companies, companies with deep pockets. And this is one aspect where we can sort of
even if they're not shifting the entire
new
piece,
entities. Yeah.
but they're trusting their own senior leadership to coming out from that and giving some part of it and saying, okay, you can start something here now, right, which can be done. So all the equipments, everything is given by them itself. I think there's a possibility to bring not even the whole part, but at least, let's say, 25–30% of that as well.
Yes. And what you started with is, Ritu, is GAN already, which is, you know, extremely important for almost everything. So how should we go about attracting more in compound semiconductors, in GaN and silicon carbide, and is that an area of opportunity? Because the investment required is of a lower magnitude, and the market is all around us today. It's a hugely growing market.
So right now, a state like Chhattisgarh cannot have that choice that you come and you don't
Yeah,
come.
of course,
Whoever comes, we are welcoming everyone. But yes, given the kind of minerals we have, we need to bring those, I mean, we need to have those building blocks in place. And particularly with our policy, we are actually promoting the anchor units to come, set up and bring the ancillary units. And our policy has a very specific provision for it. So, sir, whoever is coming with 1,000 crores of investment, we offer them a bespoke model where they ask what exactly they need to set up that industry, and if that requires some additional benefits or some concession or some exemption somewhere, we consider that. Sir, in terms of, I mean, again, I would be talking very state specific. In terms of the ecosystem, I mean, we are only a 25-year-old state. And all our institutions, whether it is IIT, whether it is IIIT, whether the other institutions are in a state where we need to actually build that complementary, you know, skill ecosystem, both in terms of talent and both in terms of innovation and research. What state is doing now is what all is required in terms of research and development, where we can bring whom. So we are, you know, as you said that there is a hit list and we are trying to, so like what IIT Bhilai can do, what NIT Raipur can do, and what IIIT can do. We are trying to map that. Then second, sir, like in this industry also, all the 4 verticals, we are trying to reach out that who can find Chhattisgarh as their destination, next destination for investment. So frankly speaking, sir, we are not being very particular. We are just offering what we have, both in terms of natural resources and in terms of the policy incentives. And those who are finding it competitive, compatible, and like, you know, profitable, we are trying to facilitate. So at this stage, the choice is very clear that we need to, because we have already made our city, Naya Raipur. So we are trying to bring people there, industries there, particularly IT electronics, to make it, you know, I mean, the hub of the state.
Yeah, Dipender, so, almost we are coming close to the end of this panel discussion.
So for this, so we as a nation and all the state now should focus on industry, academia, and the government partnership. And we should promote the R&D to the maximum level. And which is we are going to do in our upcoming policy. R&D will be the focus area to support the design component and design and then manufacturing. So Karnataka sir is here as a Maharashtra and Karnataka almost houses more than 60% of the startup of the countries. Both are the Bangalore is the capital of the country. Maharashtra is housing highest number of the startup in the state. We need to create a system where these startup can be supported through an incubation facility. We need to create these incubation facility across the state, especially in tier 2 and tier 3 towns. We need to find a solution by converging the efforts by industry, by the government and by the academia to find more solutions to create new designs. Also, we need to change the attitude of the or approach of all the aspirants or the students in the academic institutions. They should not focus only on getting jobs coming out of the education institute. They should focus on creating new products, creating new design, creating the whole new economy. So we need to sensitize them, and that kind of ecosystem we need to build, and I am sure when industry, academia and government comes together, this is going to happen in India.
Okay, we'll keep room for at least one question. So maybe one more. Yes.
Hello, my name is Meri Helle. I'm a semiconductor entrepreneur from Nokia Nation, from Finland. And absolutely wonderful comments, and I'm really thrilled and honored to be here in India. The next chip happens in India now. But one thing about, I think we should separate silicon and then the new technologies, packaging, compound semiconductor. And I think the secret of Nokia mobile phones, it was not just about the technology commercialization, but it was mainly ecosystem building. And the secret for that was that the Nokia had a vision. It was the former CEO who convinced the governments and everything to align with training, education, but also manufacturing. And they wanted to see the whole electronic supply chain, starting from silicon, wafers, raw materials, transistor, chip manufacturing, packaging, everything, and then the components to the mobile phones. But the secret is that they had the chip factory. They had Micronas, who had licensed the technology from Micropower Systems in California, our advisory board member, the person who sold ST Microelectronics chips to Nokia later on. He was there for 2 years, learned how to manufacture the chips, then built the clean room in Finland, and they started the process. And the key is that they were working together with the Nokia design engineers. So having the design and manufacturing. And what TSMC and others are doing for silicon, that is beautiful, but that is already set up. But now we are moving into era of advanced packaging, putting chips together, and we have compound semiconductors for power and RF, for automotive, and they all have special requirements, and the key is how to design and manufacture and package to the system level, how to the signal, the power, heat. So it's wonderful. Let's just make it happen together.
Thank you so much. Thank you for your intervention. Thank you. I think the time is up, so I think we'll need to close now. Thank you to all my esteemed panelists for their valuable suggestions. Finally, if you have a wish list, do you want something from ISM or Government of India? This is the last chance to say so. Time is already up, but yeah.
I think as far as Chhattisgarh goes, I just learned quite a bit about it. A lot of innovation in semiconductors is happening at a materials level. So you have an advantage over many other people. What you could do is, possibly, and it's good for the country as well, that we have, by changing the materials, we could leapfrog, into the future. So whether it's GaN, gallium oxide or germanium and all kind of things. So huge amount of innovation is going to happen away from silicon. So that could be one area that, ISM can support in a big way for the next 10 years, 20 years. So it's a long-term effort.
Just one sentence and one point.
I think ISM can start looking now in the ISM 2.2 is about the existing strengths of the ecosystem there. Don't miss it out, because that is required for the future industry. Right.
A project in Chhattisgarh from ISM 2.
So India is a big market, and we can collaborate and we can work together, and we can make India as a hub of the semiconductor manufacturing and design in the world. Thank you.
We were very privileged to have him as our moderator. Sir, hands up to you, sir. We were looking forward to have interaction with you all the time whenever you're juniors to you. Today, you have been interviewing with us, sir. Such a nice and honor for all of us. Thank you so much, sir.
Well, ladies and gentlemen, let's give a huge round of applause for this wonderful session. And thank you, Mr. Ajay Soni, for moderating this session. And we would also like to thank all the esteemed panelists, Mr. Rajamanikam, Advisor to Guidance, Government of Tamil Nadu, Mr. Sanjeev Kumar Gupta, the CEO of Digital Economy Mission, Government of Karnataka, Ms. Ritu Sain, the Investment Commissioner, Government of Chhattisgarh, Mr. Deependra Singh Kushwaha, the Development Commissioner, Industries, Government of Maharashtra. Well, ladies and gentlemen, with this we move on to the lunch break, and as we are all aware, you know the designated places for lunch. The dignitaries, pass holders will move to towards Juhi, while the delegates are requested to move to Amaltas. All other distinguished attendees, like exhibitors, visitors, and so on, may move to the food court. Now, behind the exhibition hall, there is the food arrangement for all of you. So enjoy your lunch and do come back by 2:40 sharp. Thank you very much. Namaskar, and all of you take care. participants to occupy the seats at the back. So please, without any hesitation, please come forward, occupy the seats in the front, as we are intending to start the session in the next 5 minutes or so.
Every great revolution starts with a spark. That's Narendra Modi's visionary leadership. Transformative policy reforms have driven exponential growth in India's electronics manufacturing sector. India's semiconductor market is projected to reach $110 billion by 2030 in the $1 trillion global semiconductor market. India's semiconductor mission started with launch of SEMICON India program in December 2021, with a vision of positioning India as a trusted global partner in the semiconductor supply chain. This landmark initiative marked a turning point for India's transformation into a global semiconductor hub. DLI scheme empowers domestic companies with support up to 50% cost for chip design and 6 to 4% of net sales turnover, along with EDA tools, third-party IP cores and post-SI validation.
हमारा सपना है कि दुनिया की हर डिवाइस में इंडियन मेड चिप हो.
10 projects approved. These include Silicon Fab, Silicon Carbide Fab, and 8 packaging facilities producing 24 billion chips annually. With focused investments, policy support, and collaboration across industry and academia, India's semiconductor revolution is taking shape across the country. There are 20% of the world's semiconductor design engineers in India. Under DLI scheme, 23 startups have been approved for designing semiconductor chips. 60,000 students trained under the Chips to Startup program. Together with Design-Linked Initiative Scheme, electronic design automation tools provided to over 280 plus institutes and 72 startups, making it the world's largest centralized EDA tools facility provided to students. These transformative projects will open up thousands of new job opportunities for startups, technicians and engineers. Revised semiconductor curriculum implemented by AICTE in more than 500 institutes. MOUs and MOCs with the US, Japan, Singapore and the EU. Partnerships with multiple countries for R&D and workforce development. India, it is crafting an overall ecosystem that is growing rapidly with investment commitments coming from global majors. Under New Bharat, industry will be encouraged to do R&D and setting up manufacturing facilities for equipment, semiconductor-grade chemicals, gases and materials for the development of complete ecosystem.
और अब भारत अगले 25 वर्षों के लक्ष्य पर काम कर रहा है.
From spark to silicon, from ambition to achievement, Bharat is rising and emerging as a reliable and trusted partner in global supply chains. This is Bharat, building the next semiconductor powerhouse. Jai Hind. Every great revolution starts with a spark that spreads its energy and changes the landscape around it forever. Semiconductors, the tiny silicon marvels that beat at the heart of every device. Semiconductors are the new oil, powering intelligence. In the last 10 years, under Prime Minister Shri Narendra Modi's visionary leadership, transformative policy reforms have driven exponential growth in India's electronics manufacturing sector. India's semiconductor market is projected to
your lunch, and after a very fruitful discussion since yesterday, particularly after the Honorable Prime Minister Shri Narendra Modi ji gave a clarion call that India will be the next big hub for semiconductor, and the revolution has started in the right earnest. And compound semiconductor and display will be the topic which we will start off in the first session after lunch. We have with us the COO of Infineon, Mr. Alexander Gorsky. Please put your hands together and let's welcome on stage Mr. Alexander Gorsky, who's it's a German-based world's leading semiconductor and product company, indulged in designs and manufacturers of a range of semiconductor devices across the automotive, power electronics, industrial power control, security, IC and IoT markets. He has started working with Infineon since 1998, so almost close to 20 years, and has led operations and manufacturing scaling. He focuses on expanding production for SiC and power devices to meet automotive and energy transition demands. So ladies and gentlemen, let's give a round of applause once again to Mr. Alexander Gorsky. It's yours.
No, I will walk a little bit.
Mic is put on you? No?
I have no mic. Yeah. No. Then I have to stay here?
No.
Yeah.
Just start. I'll get the...
So I'm waiting for the microphone, so please be patient for a few minutes. But if it takes too long, then I do it from here. It's no problem. Yeah? Okay. Is it on? You need to switch it on. Is the microphone working? No. Can you switch on the microphone, please? Is it working? Yeah? Yeah. This one is not working. Yeah.
Check. Hey.
Is this working? Okay, good. Thank you. So, good afternoon from my side. So obviously we have room for improvement on operational excellence. Yeah? So next year I hope we can do a little bit better preparing the infrastructure before the presentation. Good, so let me give you an update on Infineon and our activities, in particular in the area of compound semiconductors. So first of all, Infineon has a clear vision to drive decarbonization and digitalization together with our customers, together with our partners. And our products enable game-changing solutions in the area of green, efficient energy, safe and clean mobility, and third, smart and secure IoT. Infineon globally has around 60,000 employees, and in the last fiscal year we had a revenue of around 15 billion euro. And you can see that we have a very balanced portfolio of businesses. So we have a strong leg in automotive with more than 50% of the revenue, microcontroller business, but all kind of power solutions for the automotive. In addition to that, we have a strong business in industrial, in renewable, but also in powering AI. Means our power products go into AI server farms. We have a collaboration with NVIDIA, but also with other important players in the area of AI. And last, but still very important, is connectivity, secure connectivity, which is in particular important for the business in IoT. I would like to start with innovation. Yeah? And Infineon clearly has a strong culture, strong focus, a DNA to drive innovation. And I would like to start with an illustrative picture showing the evolution of semiconductor technologies. So as you might know, the first transistor has been invented in the year 1947. And since then, the semiconductor tree has grown tremendously following Moore's law, but also the tree has built very strong branches with regard to memory, sensors, analog mixed signal, microcontroller, and power semiconductors. And Infineon is a leader in many different fields. In microcontroller, for example, we are the clear number one, not just in automotive, but also industrial microcontrollers. We are the clear number one in that arena. We have a strong portfolio in analog mixed signal. We have a strong portfolio in sensors, and we want to further bring forward our sensor portfolio. And in power, we are the clear number one. So looking at power, and now coming also to the compound semiconductor, when you look at power, Infineon is the clear market, technology, and innovation leader across all three materials: silicon, silicon carbide, gallium nitride. And as an innovation leader, we continuously raise the bar with regard to innovation. So for example, in the area of silicon, we have recently announced the thinnest silicon 300 millimeter wafer in the world, only 25% as thick as a human hair, and 50% thinner than the current market standard, which is great innovation, and that drives power efficiency. In the arena of gallium nitride, we are the first demonstrating 300 millimeter manufacturability, which is super complex, in particular in the area of EPI. And last, in silicon carbide, we are launching now the next generation of technology, where we couple our superior trench technology, which has a lot of benefit in the area of reliability, with superjunction cell concept. So Infineon has a strong focus in innovation, and we drive innovation, and we raise the bar on a continuous basis. The transition from silicon into wide bandgap will not go digital, it will go application by application. And Infineon is a one-stop shop for our customers, and we can offer our customers the right fit technology for the respective application. So we are not a company who only have silicon carbide and all our customers have to use silicon carbide, or we only have gallium nitride and we try to convince our customers to only use gallium nitride, or we only have silicon. We have everything, and we can offer our customers the right fit technology for the respective application. And the transition from silicon into wide bandgap will go gradually and in a different approach, in a different speed by application. So now let me also talk about the manufacturing environment. You're all experts in semiconductor manufacturing, and you all know how complex and how capital intensive semiconductor manufacturing is. Some of our products, they have to take more than 1,000 steps to be completed, and investment decisions have to be prepared well ahead of time. So building a factory takes a few years, ordering new equipment can take up to 1 year. And in times of highest uncertainty, also related to the geopolitical situation, that gives a real challenge to the entire industry. Other than that, you also know that semiconductor manufacturing needs to be embedded into a strong local ecosystem. So you cannot build up a manufacturing site somewhere in the desert on a green field without a strong ecosystem. So you need the right suppliers for material, for equipment, you need innovation partners, you need universities, you need a good labor market, and so on and so forth. And that ecosystem needs to be established, needs to be developed in order to really scale semiconductor manufacturing. And that's for India an important job over the next years, and Infineon is actively contributing, and I come to that in a moment. Talking about decarbonization. As I told you at the beginning, our vision is to drive decarbonization and digitalization. Decarbonization, not just through our products, and our products, they save 45 times more CO2 than emitted during the manufacturing. We also take that serious in running our manufacturing facilities. So we recycle up to 40% of the consumed water. We have very ambitious targets to reduce energy consumption across the board. We are using green electricity wherever possible, and we are spending a lot of money to equip our manufacturing facilities with the most modern abatement systems to avoid pollution. Now coming to India, having a closer look on Infineon's presence in India. So Infineon is present in India for more than 25 years. It's a long time. We have a lot of very good experience with the Indian country, with the people, with the culture. We have in the meantime more than 2,500 employees in India, sitting in 4 locations, and we are planning to open more locations, and we are also planning to further increase our workforce here in India. Is a great pool of talents. On the customer side, we are serving more than 1,200 customers here in India, and this is what I said before, we are actively contributing to build up a very strong ecosystem here in India. And what do we do here? So first of all, we are working closely and very successful together with the government, the central government in India, but also the state government, as well as the agencies. For example, to shape important standards for the semiconductor industry. We are also working together closely with universities to enhance the education system, to bring the latest knowledge on semiconductor products, on technologies, into the recipe, into the education of universities for bachelor degree as well as for master degree. Then we are at the moment expanding the collaboration with local manufacturing partners here in India. So just yesterday, we have announced a MOU with Keynes. Keynes is a packaging and test partner which we are using here in India. Infineon is providing leading-edge silicon microphone technology to Keynes, and Keynes is complementing with their packaging capabilities, with understanding the local market here in India, and by that we have a made India silicon microphone which you will find in some of the earbuds in the next weeks and months. And very, very important, we actively work together with a handful of startup companies. We provide them our expertise, we provide them our products, we provide them resources if needed, and we provide them money. So we do funding. And there are in the meantime very tangible results from the startup collaboration, contributing to electromobility, to electro infrastructure, but also to smart health solutions here in India. And this is what we are doing, and by that we spend a lot of money, effort, resources, and competence to build up a strong ecosystem here in India as a basis to scale manufacturing in India in the next years and decades. And there's a clear commitment from Infineon to actively contribute, and we are very proud to be in the heart of that development. India is a super important market, not just for Infineon, for everybody, but it's also a great pool of talents. It's an innovation hub, and we are committed to the market here in India. Thank you.
We'll have just one question in the interest of time, and you can always ask questions offline, okay?
Okay, sure.
Straight away come to the question.
Yeah.
No comments, straight to the question.
Yeah. In SiC, do you use in your 2.3 or 3.3 trench silicon carbide power modules? Do you use trench or only limited to silicon IGBT?
Can you please repeat? It was difficult to understand at the beginning.
Sorry, in your power modules, whether it is silicon IGBT, SiC based, do you use trench in silicon carbide, for example, more than 1.2 kV power class?
I will come to you later and answer it next to you because it's easier for me then to understand.
Okay, sure. Thank you. Thank you.
Thank you very much. The right earnest, we started off the session in the post-lunch. We now move on. A very interesting, another interesting personality we have here, a great motivator, Mr. Chung Hoon Lee, the CEO of Seoul Semiconductors. Please give a huge round of applause for Mr. Lee. Well, ladies and gentlemen, the company has grown into the world's #3 LED manufacturer securing over 18,000 patents and delivering solutions to more than 1,000 customers, and is known for a fierce defender of intellectual property rights. Hearty welcome to you, Lee, and it's all yours.
It's an honor to have this kind of a chance in SEMICON India. I would like to have 3 sections for 7-8 minutes and 2-3 minutes Q&A. First, about Seoul Semiconductor. Second, about compound semiconductor. Third, about application. So let's think about what is the light. Anybody knows what is the light? Light is very mysterious. Let's think about. First, about us. In 30 years from small land office, it is the second time to long hairs to demonstrate intellectual property, expectation for young, ordinary people's vision. The birth is not fair. We are here. Why? We are not son of the or daughter of the Elon Musk. Birth is not fair, but opportunity must be fair. So we try to contribute for this one. In any circumstance, we invest 10% of our revenue, more than, and $100 million R&D. So we produce from, sorry. It doesn't work. The pointer doesn't work. It's okay. The 10 micron to this kind of module. We produce everything in line in our factory. In this module, micro LED, about 500,000 chips. Third, about our company. We are leading second generation LED. For instance, in order to make a micro LED, we need no wire technology. In order to make a micro LED, we need, without packaging, robust structure. In order to make an AR or transparent display, we need RGB one chip. So we are the only one company in the world to develop and produce this technology. We have 18,000 IPs, overwhelming. And during the last 20 years, we won more than 100 litigation in 8 different countries. So many people say COB or MIP or CSP, but if that is without wire, that is like a stolen car and his own tag, and then he said, oh, this is my car. That's bad. That's bad. That's not fair, isn't it? If you agree, please say yes. If no, you can say no. Do you agree? Yes, yes, that's right. Second, let's talk about compound semiconductors. First, if we categorize by the material, silicon semiconductor and the compound semiconductors. But if you look at the 10 years later, opto semiconductors market size will be 1/4 of silicon memory chip. Why it is so strongly grow? Because of the micro LED. Everybody use mobile phone in this day, but everybody is going to use glass, no more phone. And if we characterize the material by materials, yeah, silicon is a very good semiconductors, but gallium nitride, this kind of compound semiconductor, has a special characteristic. For instance, the missile has a very high temperature operation is needed. Compound semiconductor can make high temperature operation, high speed, high powers. So certain application, we need compound semiconductor technology. What is the sun spectrum? People does not know what the sun spectrum is, most of the people. We are under the here, this is LED light, but that is a junk. That destroy all your family's healthy. Why? Natural sunlight has thousands different colors, that means different spectrum. So, if the spectrum in the morning, can you see the spectrum? Then, if we observe this morning spectrum, serotonin hormone is become generate, then alertness is improving. But the evening light, then serotonin hormone is generate and become sleepy 2-3 hours later. Then during the deep sleep, 70–80% of the cell generate during the time. So everybody looking for cheaper bulb, but few dollars. But coffee, Starbucks, few dollars. It's ridiculous, isn't it? UV is a lot of functions, but I will skip because of the time. Neo IR LED has a very important future for various applications. Let's skip. Now I would like to talk again about micro LED. I mentioned AR glass. As time being, pilot is not going to use the dashboard. He'll use the helmet. He display everything. Even transparent display. All windows will be used transparent display. In order to make a transparent display, RGB should be one chip. OLED makes transparent, but it is still 50% more or less. But RGB one chip, we can make 90% transparency. Another micro LED, AI, need more speed and a lot of electric consumption. But if we use micro LED communication, we can reduce. So this is the next generation of HBM. And yeah, Infineon talked about 300 micro gallium nitride wafer, but let me show you. This is a silicon chip, 300 micro. It should be more bigger and bigger. However, micro LED, can you see this one? It's a powder, something like. This is 100 micron by 100 micron RGB one chip. But if we use 10 micron, then we can use almost 80 million chips. 80 million chips. 4-inch wafer, AR glass, 250 glass. So based on our current capacity, we can make almost 400 million AR glass. So we can supply almost all India families. Thank you. And if you allow, I would like to plus one more. Can I? Okay. Oh. This is an advertisement on the Wall Street Journal 3 times, Financial Times twice, Nikkei once. Bourse is not fair, but opportunity must be fair. We spent $100,000 for this advertisement. Why I am emphasizing intellectual property? You see, before 19th century, 9 out of 10 people was hunger. 5 out of 10 baby die before 5 years old. But because of the UK intellectual property system, steam engine is generated. Galileo developed the microscope, but at that time there is no intellectual property. So Galileo hid the old technology. So microscope become known after dying. US, second time. So electricity and the IP is invented in US. So all innovation, creation, stimulated by the intellectual property. And no LED means no AI, no AR glass, plane, satellite, and no LED, dark city. Dark city. Last page. We are a small company. I started this business based on mortgage my small apartment in the bank in the start. So I don't have much money. So I'm looking for joint venture in India. So if anybody interested, please connect to our homepage and leave some message. Then our people will contact. Thank you, sir. Too much time? Thank you.
Well, he's looking for some joint venture. I can see some smiling faces in the crowd, which means some of you are interested. Anyway, he's available offline. You can always get in touch with him. But you all forgot to give him a huge round of applause for the wonderful presentation. Thank you very much. And as we are all aware, the pattern has been pretty simple. Now 2 keynote addresses, and we'll follow it up with a wonderful panel discussion. Now, the panel discussion will throw in a lot of inputs, which would go a long way towards making the more interesting and give momentum to the compound semiconductor. And the global academia experts have congregated here. And in a short while, we'll be starting the panel discussion. Now, this panel discussion will give us information on the global landscape of compound semiconductors and the collaboration which is needed between industry and academia to fuel innovation. Now, considering the environment in India, it's very important that both industry and academia will have to be in unison, will have to be on the same page in order to make this a quick-paced and fast-paced. So it will be interesting to watch how our experts will deal with this particular aspect. And to moderate this session, we have Mr. Srinivasan Raghavan, Professor, Center for Nanoscience and Engineering from Indian Institute of Science, Bengaluru. So please give a huge round of applause and hearty welcome to you, Mr. Srinivasan Raghavan, to moderate this session. He works at the interface between material science and electronic devices and has spent the last 20 years working on GAN for power and RF electronics and UV applications. Welcome to you, sir. Please take your seat. And we'll have an esteemed panel of experts coming in. Please give a round of applause and let's welcome Mr. Surya Iyer, the President and COO at Polar Semiconductor and previously held senior positions at Cypress Semiconductor Corp and Applied Materials, and has 20 patents related to semiconductor processing and equipment design. Nice to have you here, Mr. Iyer. Hearty welcome to you. We also have with us Professor Shripad Karmalkar, who has expertise in semiconductor devices and education. His work on semiconductor devices includes development and manufacturing processes, a 2-year entrepreneurial attempt, and widely viewed online video lectures. Welcome to you, Professor Shripad. Yeah. After that, we have Mr. Guru Talapaneni, the Managing Director of SIC SEM Private Limited, leading efforts to establish a SIC-based compound semiconductor fab in India with more than 4 decades of experience in the global semiconductor industry. Welcome to you, Shri Guru. We also have with us Mr. Perry Shugart, the Chief Marketing Officer and Head of Business Development for RIR Power. Welcome to you, sir. The smile says it all. You're happy to be here in Delhi and in India. Hearty welcome to you. In his role, Perry is responsible for defining, promoting, and growing RIR Power's SIC and SI products and solutions globally. Welcome to you. And it's a big panel. And finally, we have Dr. Rao Maganti, a technologist, entrepreneur, and academician with over 4 decades of leadership in LED display technologies, embedded systems, ICT, and of course, biomedical engineering. As President and CEO of Crystal Matrix, driving India's first integrated GAN epitaxy and so on. It's very gratifying. Put your hands together for Dr. Rao. And I'm very happy to note that post-lunch, the audience is very active. So let's give a huge round of applause for the entire panel. I would now hand over the session to Professor Srinivasan Raghavan. Take it away, sir.
Thank you. Can you hear me? Okay, that's great. It's great to see that on the second day of SEMICON, post-launch, compound semiconductors still elicit the kind of interest we have in the audience today. I'm kind of heartened by it. It's interesting that I was noting that when SEMICON started yesterday morning, in the movie that was played, semiconductors were equated to silicon. So it's the responsibility of this panel to change that narrative and say that compound semiconductors are important. Granted that silicon is the gorilla, there is no doubt about it. When you talk about silicon, the device revenue, you speak about $1 trillion. And as we saw from the last presentation, if you talk about the compound semiconductor device revenue, you're still in the tens of billions, even though the systems revenue might be about 10 times. But I must admit, and maybe that's something that the panel can pick up, silicon is at 2 nanometers. So the next semiconductors that might take up CMOS are possibly molybdenum disulfide and tungsten selenide, and those are compound semiconductors. So it'll be interesting to see how the world looks like in 2035. So with that, those introductory remarks, we have an eminent panel here. We have distinguished industry veterans, Professor Shripad Karmarkar is a veteran in the GAN field. He has worked with Umesh Mishra. Some of you may know him as the founder of Transform. And I'm looking forward to a lively discussion with all of you. To keep things efficient and not interrupt the panel too much, I have already circulated 2 questions with them. The first question will be on markets, because that's what people are interested to know about. What are the markets for compound semiconductors? Are there silicon markets that compound semiconductors will tap into, will complement? What do you think? You can be controversial. As a compound semiconductor man, I start by saying we will replace silicon, although I know it's almost impossible. And the second question will be, how does one break into? So all semi is about a supply chain, right from making the silicon wafer all the way to making the chip, to packaging it, to integrating it in a system. So there's a supply chain, and so countries are looking to break into the supply chain at various parts. So my second question will be about where you think India can break into that supply chain, and more importantly, how do you move up the value chain? You could be doing packaging, or you could be chip making, and the value at those 2 points are very different. So with that, I'll throw the panel open. Maybe we can start with you, Surya, on the market opportunities for compound semi, in particular power. And do you see it as competition, given that you're in a silicon power?
I wouldn't characterize myself as a silicon guy. I'm flexible.
Okay.
I can be a compound. Okay. Actually, one of the things you mentioned, Transform, you mentioned Umesh Mishra. Polar Semiconductor announced approximately maybe 2 or 3 months ago a license agreement with Renesas, which owns Transform. So now Polar is also a compound semiconductor company. So we are making gallium nitride on silicon. So gallium nitride on silicon, the reason we chose gallium nitride as part of our company's strategy was because there's certain things that you need gallium nitride for, and the industry is driving in that direction. I think those who were here earlier for Alexander Gorsky's presentation, he had a nice slide which talked about the different applications for silicon versus silicon carbide versus gallium nitride. And in terms of applications, again, I have to make a confession. I'm a operations type of a person, manufacturing, high volume manufacturing, that's my background. And to me, the key things is that the industry will drive to new technologies, new materials because of need, but it'll adopt only if it is at the right cost. And that is a major challenge for some of these new technologies that are coming in, the silicon carbide, gallium nitride, drive. I think my microphone is kind of going on and off, but hopefully you all can hear what I'm saying. The cost piece is very important. Silicon, especially as you drive to 300 millimeter, you can make a lot of these chips at very, very low cost. Now you have silicon carbide, where there's, of course, added cost of the substrate, added cost of the epitaxy. The equipment is not necessarily cheap either, so there's a lot of operational costs, material costs that added to make it work. So can you hear me? Okay, maybe I should just switch.
Yeah.
I think maybe that one needs the gallium nitride chip or something. That'll make it work.
That would make it more reliable than silicon.
Exactly. Silicon is very reliable too, actually. Silicon's highly reliable because I think the understanding of silicon is just so much. There's decades and decades and so much activity that's gone into understanding the reliability of silicon. Reliability is not that much of an issue. But there are certain applications, for example, very high temperature applications that silicon cannot perform at. You must use GaN, silicon carbide. There's absolutely no choice there. There's some switching reasons that you need to go to silicon carbide GaN. So there's high power reasons that you need to go to silicon carbide GaN. So there's applications that drive you, like the XCV type of applications that Polar is specifically interested in, because we're an automotive manufacturer, so that's of specific interest to us. So those are directions where there'll be several applications that need higher power, better switching speeds, higher temperature operations that will require gallium nitride to replace silicon. Now, I do want to mention that silicon people are not just sitting idly by. There's a lot of activity going on to push silicon's performance beyond what it is today. In fact, one of our customers that is working at Polar is their whole theme is that they can do with silicon what silicon carbide is doing today. So they have some special technology, special secret sauce that they're trying to push the envelope of silicon. So I think the prediction that I'm going to make is that there's going to be certain applications, especially silicon carbide is going to be narrower and narrower as silicon and gallium nitride take over most of the volume in the compound semiconductor silicon industry.
I see Guru is smiling there. I see Guru was smiling there as he was saying that silicon and GaN will edge out silicon carbide.
But the small, narrow portion might make a lot of money, so he doesn't have to worry about it.
But I'll just ask you a quick question, and just for the audience, in case you didn't know, that most GaN optoelectronics of the kind that you heard in the previous talk is on sapphire. Most GaN RF is on silicon carbide, and most GaN power is on silicon, although GaN on silicon for low-cost RF is also coming up. So when you say you you're working with Renesas, this is on GaN on silicon for power or for low-cost RF?
So again, Polar is a foundry. So we bought the process technology, and we'll make the wafers, and whoever designs it to whatever application, we can make the devices for them. Currently, the technology that we have is a 650 volt technology. So
it's power.
Yeah, it's power technology. Yeah. But there's, again, that's the other piece that I want the audience to kind of appreciate, is that gallium nitride is in a very interesting stage of its evolution. There's a lot of different types of gallium nitride that are being kind of manufactured, and R&D is going on. So there's aluminum, gallium nitride, and other things for different types of applications, not necessarily just for commercial purposes, but for very specialty applications in aerospace and defense type of things. There's E-mode GaN, D-mode GaN. There's different kinds of EPIs that are still being developed. So it's in a transition. So there's going to be, even within GaN, there's going to be different types of applications that are going to pick different kinds of modes of GaN that could be, more suitable. So I think these are all kind of parts of the evolution process. I think there's a lot of smart people out there who are going to make a lot of different things work.
So, Surya, I'll leave you with a question, and I'll come back to this later, because GaN on power is getting extremely crowded with InnoScience and Infineon, TSMC having thrown its hands up, as is Cree. So it's kind of a brave jump into GaN on power at this point in time. But I'll come back to you on this. So let's go to Guru there to see how he can rebut your point that GaN and silicon are going to edge out silicon carbide. By the way, Guru, you can introduce yourself. You can talk about the ISM opportunity that's coming up through 6M, and then maybe you can make it a little lively and tell Surya it's all going to be silicon carbide and not GaN on silicon.
So I'm Guru Telapaneni, co-founder of 6M. We got approved on August 12th recently by ISM. We are very grateful to the state of Odisha and also ISM meeting.
Guru, you want to hold it closer, the mic?
Which one?
Just hold it closer.
Closer?
Yeah,
okay.
That's better, yeah.
So basically, since you asked me about silicon carbide, You know, if you look at the market right now, the power market is dominated by silicon. It's almost about $30 billion globally. And you know, silicon carbide, if you really look at 2 years ago, it was very high price because of substrate cost. It used to be 6-inch wafers, $1,200 to $1,500 per wafer. Today, because the Chinese, basically making production quality wafers at $400 a wafer, the prices keeps coming down.
This is 400 for 4-inch or 6-inch?
It's 6-inch.
6-inch, okay.
And 8-inch also they are able to offer now around $1,200 to $1,500 a wafer. So to me, you know, like when the silicon carbide wafer prices keeps coming down, and it will also capture more and more silicon market. And because it has inherent strengths, because of higher breakdown voltage, higher thermal conductivity, that means it requires smaller heat sinks. It's also about 1/10 of the size of silicon. And for many industries, for the high voltage applications, high temperature applications, anything above 600 to 700 volts, silicon carbide is the most preferred material. So to me, you know, the future, all the sustainable industries, like electric vehicles, AI data centers, renewable solar inverters. For example, India installs about 50 gigawatts, that's the plan, per year. If a 6% energy efficiency gain with the solar inverters, we could literally gain about 3 gigawatts extra. That means, you know, like it's a big significant saving money terms and also material terms. So to me, you know, like I really believe if you want to electrify the mobility sector in India, also, you know, go for renewable energy, also cut the import cost of oil, that means less carbon polluted industries. So I think silicon carbide provides a great, you know, opportunity for India to spearhead in that field.
So how about 6M's plans? Can you tell us about 6M's plans? Because that's what people are waiting to hear. 6M plans?
Okay. Our plan is basically, you know, like we are looking at as an integrated device manufacturing facility, because we looked at the markets like Infineon, like Mr. Gorski mentioned, like Infineon, Wolfspeed, SC Micro, Renesas, Onsemi, those 5 companies, they're IDMs, they dominate about 90% of market share right now. Unless we are also similar to their business model, I think it's very difficult to compete. So we believe that, you know, we want to go from mines to all the way to the products and even eventually systems. That means we plan to make silicon carbide wafer manufacturing facility here, as well as make MOSFETs and diodes. We have a partner from Classic, from Scotland, the Classic Wafer Fab. And also we have license for ATMP from CDIL, Mohali. They have actually been doing already packaging for a lot of other companies in both silicon and silicon carbide.
This is CDIL, you said?
CDIL.
Yeah, okay.
So, you know, like we are trying to minimize the risk in our business model. And our goal is to make it, you know, cost effective. The reason is that at every step we can improve the yields, reduce the cost, and also we have better control on overall our cost structure. With the incentives that we got from both state and center, we can achieve significant cost advantage over competitors.
So when is your first wafer rolling out? The bare wafer and then the processed wafer?
So we actually worked with IIT Bhubaneswar. The last, in 9 months, we were able to start the project, install the equipment, and able to successfully demonstrate very good quality 8-inch silicon carbide wafers. We were able to grow the ingots. We were able to get polished wafers. We are seeing some wafers as low as 1,000 defects per centimeter square, which is actually much better than what you can get from Wolfspeed or even from SICC.
So let
we
me
have
just,
another 6 to 9 months to
let
perfect
me just
it.
repeat that for the audience because this is incredible. I don't know how many of you have heard of Rapidus. This is a company in Japan that is leapfrogging to get to 2 nanometer technology. And just yesterday I was with their CEO who said that in 18 months they have established that process on the ground. But here, you have established 8-inch silicon carbide wafer capability, which is not at all easy, on the ground in 9 months. That's excellent. So I think he deserves a hand for that.
Yeah, thank you.
Yeah.
Yeah. So Dr. Karmalkar can speak more on that. Yeah.
So when do you think you're from 6M, this of course is a capability that you established in IIT Bhubaneswar, but from 6M, what are the plans in terms of breaking ground, building up the fab for the first wafers to roll out? Roughly how long do you think it's going to happen?
We already bought the land in Info Valley in Odisha, 25 acres. We plan to break the ground in October first week, potentially. And our goal is, get the facilities ready in 12 months from that time. And then next 12 months, we'll bring the equipment and qualify and ramp up to the production. 24 months, we have a target.
Okay. So roughly in 24 months, your first wafers will roll out. What's the capacity expected?
We actually been approved with 5,000 wafers a month. We are hoping to, make close to 10,000 wafers a month. The reason is that most of the automobile companies will not look at you if you don't have close to 10,000 wafers a month capacity.
Okay.
We don't want to be a small player. We want to dream big. We want to move into the direction.
So a question that I'll come back to you on is that the Chinese competition, you yourself said silicon carbide wafers are plummeting, the costs are plummeting. So I'll come back to you on that.
Yeah, if you look at the cost structure.
So you may want to hold on to that. I'll come back to you in the next round. But that's a question that I'll place to you. I'll come back to you at the end. There's a reason I'm going to do that. So maybe we can go to the far end. So we've had power, and the area that actually, oh, your mic is not working. The area that actually put compound semi in the limelight. Actually, if you go back in the 1920s, blue light emission from silicon carbide is the discovery that resulted in the first semiconductor. It's not that silicon was the first semiconductor, but nevertheless, compound semi came into the limelight with the LED. So with that, Mr. Suganti, would you like to go ahead, introduce yourself, what you're going to do with crystal matrix,
Thank you,
and what markets you're going to tap into?
Thank you very much. Fortunately, being an Indian company, we are in displays for past 40 years. We are buying all the components, doing our best in the back end, and taking, especially Niche and Cree, top leaders, and doing the chips. And doing across the globe, we have supplied almost more than few thousand screens. Later, fortunately, thanks to ISM, and we're working with them, and even I was advisor 2013 to 18 in this LED sector. I'm also a LEDMA, LED Manufacturing Association president. We fully focused on this vertical, displays first, where we have tied up with Lumens and Soft AP of Korea. And in fact, Seoul Semi also I visited recently, they did. So main thing, my feeling in India, whatever best as on today available should start. We thought compound semi may be better than, because of our capacity, it's around 3,000 crores project. We applied to ISM. It is under process. So we'll be planning 6,000 wafers per month, and we may increase that one in future. Same way, ATMP also, almost 1 million panels of 8.8 inch displays with various applications. It may be COB or COG based, later AR, VR also. And we were observing the compound semiconductor growth definitely is big because of the automobile industry in India especially. In my view, automobile industry is much more than silicon compound semiconductor will be used because of LiDAR, lighting, and other power electronics applications. I feel one of the best applications where domination of compound semiconductor is the automobile, where there is a very big business in India. Same way, we are trying to buy the equipment, either Vico or Axtron. We want to use 24/7. The main thing is skill development. Thanks to Sense, sir is there, we are tied up with ISC Bangalore for training the manpower in this segment. And we have our own engineering college also. Then we want to tie up with IIT Ahmedabad also. So the manpower is key. Like a small example for a common man understanding, suppose a flight operation, if you use 24/7 operation with a crew or, a pilot, etc., then we can extract a lot of, output or revenue, whatever it may be. So suppose we are buying machines of gallium nitrate based growth for blue, and in fact, InGaN, the red efficiency in InGaN we want to grow in the same wafer RGB also with the soft epi collaboration, but red efficiency is very low, you know. All GaN okay, but in GaN they're trying to improve the efficiency where we can have RGB chips in the same wafer and we can do the mass transfer at 1/3 this thing. And same way, we are focusing on a back-end. We're very, very good at back-end, you know, Indian brains. So chip design is very good, but chip manufacturing may not be there. But with that efficiency of back-end, we are optimizing the software upward, lowering hardware down, like intelligent pixel we patented in 40 countries. For example, we don't use 3 RGB pixels for 1 pixel. We use a 1 LED as a 1 pixel, and we use a depth control. Making use of the depth control, instead of 16-bit, 18-bit, 20-bit we'll go. Whereas in LCD, we can't go beyond 8-bit. So because of that, we are reducing the hardware to compete with Chinese. Same way, at present we are doing 6-inch wafers. Later, 8-inch we migrate. 6-inch wafer, a carbide material we are using, that also we want to do ourselves. So this is our background. Whatever resources available at present and whatever infrastructure we are buying, we want to use 24/7 with the tie-up of training main, which is HR is very, very important. For example, in solar panels in space, we are very good at space, ISRO. So if you can supply solar panels having very high efficiency with the same gallium, instead of gallium nitrate, gallium arsenide we use. We grow the wafers where we get a 30 to 40% efficiency. We can supply to, ISRO, because they're importing a square meter more than $15,000 now, whereas ordinary wafer, not even, silicon is 0.25 per watt, I'm talking, $0.25.
But if I may interrupt you, going back to the GaN LED bit, I understand compound semi, you may also use it as a photovoltaic, but it's a very high-end cost per watt.
Yes.
But as far as crystal matrix is concerned, and you were also part of the recent ISM announcement.
Yes, yes.
In the whole technology chain, what is it that you're planning on implementing in India? Is it just the back end, or you're going to go all the way from epi to the LED device processing to packaging it?
Total, sir, starting from epi, singulation, make chips, packaging the chips, writing the software, video processing, different applications including big virtual production, AI, volumetric control, all the applications of displays. But AR, VR, you know very well, very tough to get less than 10 micron. So we want to do after 5 years. At present, we are doing everything, mini type, including 3D we are doing, 3D interactive displays also we are doing, with the sub-pixel rendering. So we're doing a lot of stuff, everything, % back-end to...
So roughly when will your wafers be rolling out, your LED wafers and then the processed wafers?
I think it takes 12 to 18 months, sir, maximum. 12 months we'll get except wafer, this thing, because the equipment delays are 12 months delay. But within 20 to everything back-end, starting from scratch to we are doing everything, sir.
Okay.
So I request you to guide properly HR main, that is a key in India, sir.
We will, because the director of IIT Bhubaneswar is here, so HR production is happening. But before we get to him, Perry, your thoughts on, your thoughts on compound semi, given what you see from the silicon carbide front, the markets that are going to become available.
Perry Shugart.
Yeah.
Hello, is it on?
Yep.
I'm Perry Shugart from RIR Power, an Indian-based company. We've been around 55 years, focused on power. We do silicon and silicon carbide. We're actually starting our silicon carbide epi this month, fabrication in Odisha, and then we'll build out a full fab by the end of 2027. So the idea is to have a full ecosystem of silicon carbide. The previous presenter put up a really nice graph, I think someone mentioned it earlier, showing silicon, GaN, silicon carbide. There's one thing missing from that graph, another axis, which is voltage. So if you look at that at 650 volts, I would agree. 650 is kind of what we call bloodbath. GaN, SiC, silicon. You look at an EV, it uses all three. It doesn't just use one. All three technologies are going to coexist. It just depends where do they add the most value. If you go up in voltage, and when I say up in voltage, I don't mean 1200 volts, I mean 3,300 volts, 10,000 volts. That graph changes dramatically. What you're going to see is that silicon carbide bubble it's going to pretty much take up the whole graph. And here's an example. 3.3 kV silicon IGBTs. They've been around for a long time. They're workhorse. They're used everywhere. Now 3.3 kV silicon carbide MOSFET modules are coming out. If I look at the same current rating with the silicon carbide module versus the silicon module, the silicon carbide module has 70% less switching losses, 70%. That's huge. So just as another data point, the US looks at its power generation pretty much every year. They want to know what the efficiency is. So if you look at all the energy resources, it could be nuclear, solar, coal, natural gas. If I look at a home, and I look at the total power generated, or total energy generated, because it hasn't done any work yet, by the time it actually does work in that house, it's only 33% of that energy. So 2/3 of the energy is lost, probably due to heat. And we look at the electrification of everything, which we're living in right now. The demand for electricity is growing. And if we build more power plants, that's not going to solve the problem. What we have to figure out is, how do we convert, condition, process energy more efficiently? And this is where the compound wide bandgap semiconductors come in. And as that voltage goes up over 3.3 kV, 10 kV, 20 kV, that opens all new activities. For instance, the eVTOL, the air taxi, it was only silicon carbide that allowed that to happen. Without silicon carbide, that would have never happened. And if you look at where our main load centers in power are, they're far away from generation. And so we have HVDC lines trying to bring that power in at low losses, but you can't build an HVDC station close to the load center. And that's because they use 3.3 kV silicon IGBTs most of the time. What if we replace that 3.3 kV silicon IGBT with a 24 kV silicon carbide IGBT? So I looked at one HVDC station, about 360 levels of silicon IGBTs. You can reduce that down to 80. So that means something that was the size of a sports arena could now almost be the size of a garage. That allows us to port the power more to the load center more efficiently. So it's a lot of these little areas where I see silicon carbide in high voltage really providing that advantage in efficiency. And we all see EVs, but the heavy-duty EVs are also coming on. Trucks, buses, construction equipment. They're all running at a higher voltage. They're using 3.3 kV silicon carbide type devices. We're also seeing other areas, shipping. We're also seeing aircraft. We have fully electrified aircraft now. So silicon carbide is becoming more of an enabler. And as I said, as that voltage goes up on that graph, you're going to see that pattern change dramatically, and the silicon carbide pattern is going to grow quite a bit. And it takes a full ecosystem. So a 24 kV IGBT, how do I package that? And I think this is the opportunity to put that supply chain in place and look at what do we need to do, because we can't just put it in an existing package. We got to put in a higher performing electrical package, higher performing thermal package, and those don't exist right now. So I think the whole infrastructure, as we go up in voltage, is just going to grow.
So do you agree with Guru's assessment that you had to be an IDM to compete favorably in the silicon carbide market, go all the way from, actually he said he's even going to go back to the mines, we'll come back to that later, but going from the wafer all the way to a packaged module? Would you agree with his assessment that?
So he's asking, do you agree with my model going from wafer to all the way to the packages, advanced packages?
Yeah, our business model is not to do the boule. We're not going to make the boule itself, but we will grow the epi on it. I'm a big believer in focus where your core competency is. If it's not your core competency, don't dilute your resources. Partner with someone. So right now, we're starting with the epi, and then we're going to do the full fabrication. And that's where a lot of the IP is.
I see. So we come to Shripad, last but not the least. For those of you who may not know, he's actually worked in GAN for a long time, so he's also taught semiconductors in IIT Madras as a professor for a long time. So and by the way, when we look at field plate technology, I don't know if many people in the audience will look at it, some of the fundamental papers on managing electric fields and GAN power devices came from the work you did earlier. So given how you've seen the evolution of compound semi, and we've seen compound semi power, but we also are missing compound semi RF, and then we have LEDs, how do you see the way it has evolved, and how do you see it going into the future? I think that mic is the problematic one.
So I'll start off by telling why, as an academician, we are interested in power devices. So let me start with that. In last 50 years, if I see the IIT system, how it has evolved, when I did my BTech in 1983 from IIT Madras, the teachers were evaluated, the faculty were evaluated on two parameters, teaching and research. After about 4 decades now, to these two parameters, another 2 parameters have got added, and these are industry-academia collaboration and entrepreneurship development. Now, if we see this particular segment, that is industry-academia collaboration and entrepreneurship development, the compound semiconductor devices, such as silicon carbide devices, they hold out a lot of promise. And the reason is the following. If you want to develop the entire technology for the devices and put in place the equipment and the entire process line, silicon carbide devices or power devices in general have an advantage over silicon on 2 aspects. One is that the silicon devices, CMOS and so on, they are very small geometry devices. So these are possible because of great advances in one process, namely the lithography. And the lithographic process is one of the most important steps in semiconductor technology. Because the silicon carbide or power devices are much bigger, the constraints on the lithography process are much less. And therefore, it is possible to implement this lithography process with not so advanced equipment. So that is one important reason why silicon carbide power devices are advantageous in India. If you want to implement the entire process line and really do the indigenization. There is a difference between importing the chips from abroad and packaging here and doing everything right from, let us say, the powder to the module or the system entirely within the country. So one is the lithography, the size of the device. The another thing is other constraints like the cleanliness of the room required to make these devices. For example, for making silicon devices, you really need very high clean rooms for implementing the various processes. Whereas for silicon carbide, for example, if you want to make the ingot out of the powder, the room in which such a reactor is maintained doesn't need very high cleanliness. So this is another important reason why power devices for academicians, I feel, in India, that is a good area if you want to talk about industry-academia collaboration and implementing your knowledge into actual products, both from the entrepreneurship point of view or industry-academia point of view. So I think that's the point I wanted to make.
But the device fab still needs a clean room.
A device fab needs, but the level of cleanliness required, as I said, for the reactor, for instance. Whereas if you take the similar step in silicon, right, you will need higher cleanliness in more rooms where the equipment is maintained.
What's a class of clean room you need for silicon carbide of similar yield?
For the reactor?
No. For the device process.
I'm talking about the wafer making.
I'm talking of the device process.
I can answer that.
Yeah.
Right.
So basically, you need only where the wafers are exposed to the aisles, where the wafers are, the systems are open. You need typically about class 10. Rest of the area can be class 100.
Okay. So you still need a
and
class
also,
10.
like if you look at a lot of steps, like say CMP polishing the wafers or multi-wire equipment and the crystal growth, they need class 10,000.
Yeah, those are but they...
So those kind of steps, right?
Right.
But the fab itself, you need a class 100 and class 10.
Right.
You don't need a class 1.
Right. Maybe we can break the monotony a bit and take one question from the audience. Does anybody have a question? Go ahead. We'll take one question now. We will come to you later.
A lot of talk about power, but I would like to know a little bit more about RF. And my comment, especially when
you would like to know a little bit more about?
RF.
RF, okay.
When it comes to the compound semiconductor for RF, if you talk about gas, HBT or PHEMT, and there is only one foundry that comes to the top of your mind, WinSemi, I have to dig deep to think about the second one. Similarly, if you talk about GaN on silicon carbide, which are used in RF for power amplifiers.
What's the question for the
So my question is, why is this not a focus for building in India? Why are we not trying to go after the underserved markets where there is not as much competition and go after gas HBT, gas PHEMT, or GaN on silicon carbide?
Can I answer that question? It just so happens that I am the moderator, but I am the one on the panel that is setting up a foundry for doing GaN on silicon carbide RF. And that's why one of my questions to you was whether it's GaN on silicon for low power RF that you're working with Renesas on. As far as gallium arsenide is concerned, in India we don't have anything in the private space, but GATEC is there and they do have a reasonably stable process working. And as far as GaN on silicon carbide RF is concerned, we go down to a CD, since you seem to be knowledgeable about GaN RF. We are planning on going down to 0.12 micron MMICs, going up to the KUKA band in the not too distant future. So we have a stable foundry process running at about 0.5 micron. For GaN
That's
RF
super impressive. I would like to know 0.5 micron or quarter micron GaN on silicon carbide would be very, very welcome by, I mean, I am the CEO of X0 Semiconductor, so we would love to use any of these foundries available.
0.5 and quarter are discretes, 0.12 is an MMIC, X-band.
0.12 is for MMIC.
Yeah.
Got it.
Low watt and that's high wattage. Yeah. So I
Got
hope
it.
that answers
Thanks.
your question. So Guru, maybe there's something that you said that I thought was very interesting. You talked about an integrated manufacturing activity. Now, when you talk about semiconductor IDMs, they start from the wafer going up. You mentioned something about going all the way back to the mines. And when it comes to silicon carbide manufacturing, the purity of the feedstock is equally important, and it's not that easily available. So, and this is a question that I might come to you to later. As far as the India supply chain is concerned, given the LED and the silicon carbide efforts that you're putting up, where do you see threats to your supply chain from the global perspective, and given the current geopolitical context as well?
So right now, we cannot get anything high purity silicon or high purity graphite in India.
Correct.
We need 6N purity. 6N means 99.9999.
Right.
That's a 6N purity. And also we need 6N purity silicon carbide powder.
Right.
We don't get any of that right now.
Right.
But we do believe in India there are enough mines, high purity silicon mines, as well as the high purity graphite mines. We can actually purify to get that quality. It's not that complicated. So we intend to make that happen. And also from those two powders, high purity silicon and high purity silicon graphite, we'll make silicon carbide powder also with 6N purity. And also we need a high purity graphite, same way for isostatic graphite, so that we can use that for crucibles, also the graphite felt, and also graphite paper. All those things can be made by isostatic graphite molds. So we intend to develop all these because India does not lack those two minerals. So we can easily indigenize complete whole ecosystem for wafer manufacturing.
So given that that's one of the agenda items that was given to this panel, that we also identify opportunities. We are trying to create an ecosystem here, right?
That's correct.
So given that there are opportunities we are trying to identify, and you will have your hands full setting up a fab. So if there's somebody outside or in this audience
who is willing to set up the capability to get you high purity silicon carbide, that's an opportunity that's out there
absolutely.
now, right?
If somebody can
Right.
provide us, we'll be happy to work with them in India instead of importing.
Right. By the way, the Murugappa group is one of the biggest producers of abrasive silicon carbide in the world, so they haven't expressed any interest?
No, the problem is that their silicon carbide is a mined silicon carbide, which is abrasive.
Right.
Or diamond industry and all that.
Right.
I think they are able to purify to 5N purity.
I see.
But we require 6N purity.
6N, okay.
6N are even better.
Right.
There are also some technologies, now polymerization technologies.
I see.
We can get even 7N purity.
I
We
see.
are also looking at that seriously.
I see.
And so you need to make chemical means
I see.
to get this purity rather than from mines.
I see. Dr. Maganti, as you know that China has a ban on export of gallium, and you will need a lot of trimethyl gallium and trimethyl aluminum and indium, right? The metal organics for your LED manufacture. So have you looked at that part of your supply chain?
Sapphire, yes, sir. Actually,
No. The metal organics. The metal organics, trimethyl gallium, trimethyl aluminum, trimethyl indium, you will need them in huge quantities, right? So have you identified what sources they are going to be from and where they are going to cater to your fab?
Actually, we are planning to do in Gujarat.
I'm sorry?
Sapphire wafers, we asked our technology partner. He suggested at present Korea is very costly. We have to depend on China. Then we discussed why can't we put ourselves? So if anyone in the audience are willing to supply 10,000 sapphire wafer 6-inch at present, we love to collaborate, or we do want to do ourselves. The reason is also, sir, there's a main component. Suppose if a wafer cost is $150, more than 50% is sapphire cost.
Right.
So we are keen to do sapphire in-house. So then total supply chain, one by one, we select the Indian partners. They can go and get the technologies. Technology is available. More than 10 people in the world can give.
No, but I was referring to the trimethyl gallium. That's extremely critical for you, right? Trimethyl gallium? Hello. The gallium source.
Hello. Gallium, sir?
Yeah.
Gases?
No, the trimethyl, okay. You grow the gallium nitride.
Yeah.
And I think...
In GAN, red color.
Right.
Yeah, exactly, sir. That is in Korea, soft AP, once that is there, we want to support them to do in India.
I see.
Yeah.
But just like there is an opportunity of silicon carbide, there's also an opportunity for high purity metal organics, like trimethyl gallium. Actually, India has a source of gallium. It's just that it's not converted into trimethyl gallium. You something?
About opportunity, there's also opportunity to make the reactors of furnaces for making the crystal growth and making the bowl.
Right.
So like that, there are actually multiple opportunities because just like, the nucleation growth that happens in a chemical reaction, if you have a good nucleus deposits at a point and then all the molecules gather around it. So I think this is a very good opportunity, the scale at which the investments and effort is being done. Once you have an entire fab somewhere, automatically there will be opportunities at various stages of the fab that can be indigenized. Because first we are starting with something imported, but then at multiple points, the people will see opportunities.
Right.
And yes, that is what I wanted to just mention.
But maybe it's good to start identifying those opportunities now. So 2 years down the line, when these things start coming on stream, the supply chain risks are lower. At least you have a diversity.
So we can actually have a website where we can put out that these are the things that...
Absolutely, yeah. Absolutely. So you're coming back to your question, right? You were getting into GAN on silicon for power.
Sir, if you can give me just 1 minute, sir. I'm from the audience.
Can I just ask him this question? I'll come to you, don't worry.
Okay, sir.
Oh, did you have? Okay, go ahead. Go ahead.
Thank you, sir. Thank you. My name is Raja, and I'm coming from Hyderabad, Telangana. Actually, just now I came to know about the opportunities for the silica carbide supplier and engagement into that. We are into mining, and we do supply silica carbide from many years, sir. And it has been approved in so many companies. We are exporting, and also we are interested to tie up with the local manufacturers who are interested to just associate with us. We have mining in Andhra Pradesh and Goa.
That's very good. So maybe you can catch up with him, although he needs, I don't know if you heard him.
Yeah, that's why. I took the opportunity, sir.
99.9999% pure silicon carbide.
Thank you so much, sir.
That's
Thank you.
6 nines. So as I was asking you, Surya, I mean, you were talking about GaN on silicon for power, and there's Infineon and there's InnoScience, and the cost of a fully processed 8-inch wafer with the devices InnoScience is putting out is about, I heard $600 or something like that. And that's insane. That's insanely low. And giving this kind of competition coming from China, and that's also a question to other members of the audience, what is the prognosis for competitors? I mean, it must be as much of a concern for you in the US, and when the ecosystem is coming up in India, unless there are tariffs, it's a fashionable word these days, it's going to be difficult. So what do you think about it?
Well, that's good. If InnoScience is making full epi and device wafer for 600 US dollars, that's good for them. I think that price depends on a lot of things. Price depends on quality, yield, the number of mask layers that the device is getting. So generally speaking, InnoScience throwing a number is meaningless to me. But real challenge of cost. They have huge amount of subsidies, and so that is kind of like the previous presenter was saying, the opportunity needs to be fair, and it's not a fair opportunity if they're being subsidized. But on the other hand, it gives a challenge to the rest of the world to come up with more innovation, be able to drive the technology so that it just doesn't become a cost-based decision, it becomes more than a cost-based decision. So that's kind of the first thing. Again, as I mentioned, we have the GaN technology from Renesas, which is transformed technology. So it's, I would say a very superior, high quality type of technology. So I would say that we're better than Infineon and InnoScience. I hope Alexander Gorsky is still not here, but anyways, so I think we are, again, as I said before, we're at a stage in gallium nitride technology that there's still things that are dynamically changing. As I said, there's D mode, E mode, AlGaN, InGaN. There's silicon substrate, there's sapphire substrate, there's silicon carbide substrate, there's GaN on GaN, which is kind of the vertical GaN. So there's a lot of different things going on, and that'll drive future applications and future adoption and future cost. So I think the story is just beginning. It needs to be written, and we just need to be in the game. And that's kind of one of the reasons we wanted to be in the gallium nitride. Because it's still, the train's still on the station, we can still get on. One of the reasons we didn't want to be in silicon carbide is that there's already a lot of big players in silicon carbide. And these are big companies like Bosch and Infineon and others. They're big major companies who are doing silicon carbide, ST, etc. The one thing I do want to mention in terms of just for the audience to think about and for the panel is that when you're looking at technologies like this, which ones that India should we adopt a full IDM integrated manufacturing model, or somebody does some portion of it, somebody does some other portion, and a more traditional model or a foundry model. There's all these models, right? I think the important thing to consider is, I think as one of our panelists mentioned, core competence, do things that you're good at, do things you can drive costs on, and the materials for the next generation of semiconductors. I think it's a huge opportunity.
We're kind of running out of time now, but Perry, one last parting shot from you on silicon carbide, which survives because you have good single crystals. Yeah? Yeah, so the question is for him. Yeah. So all the high voltage silicon carbide is because you have good silicon carbide single crystals. But if GaN has the same band gap and aluminum nitride is emerging, and like he said, vertical GaN is going to be emerging, so a quick
And most conferences I've been at, they ask the same thing. So what's going to win, GaN or SiC?
Vertical, not the horizontal one.
So I see that high voltage silicon carbide, high voltage again, 300 volts and above. We're starting to see more and more of that. I was at a company that did get a military contract to build a silicon carbide-based converter. This was over 20 years ago. We actually used that to create a pulse power system that was rated at 10 kV using silicon carbide diodes. So that model works really well. From that, you get so many options in different areas to take that technology into places you never even thought of, because if someone doesn't see it, they can't figure out what can I do with it. So I see, from my perspective, high voltage silicon carbide, it's just when. It's not if, it's just when. We're already seeing what I call third wave. And this is going to create the whole ecosystem, because it doesn't exist right now for that kind of product.
So we have something up our sleeves that will continue with that, but we can talk about it later. So Shripad, any parting thoughts since we are running out of time, and also for you to address the HR question?
So I think the parting thing is that we have been teaching these subjects on semiconductor devices for a long time, and the students have been going out to Taiwan, Singapore and so on. I think now there is a great opportunity for all of them to be in India and contribute. That's the parting thing.
The audience, go ahead.
All the experts for the wonderful discussion. But I think one point is missing. Basically, for all the development you are talking about, you need crystals. This country makes very little crystals. Especially those crystals of the size you are referring to. Maybe the committee can make a recommendation to look into this aspect. Crystal growth, silicon crystal by Socrates process. 30 centimeter dia, several inches long. But nothing is happening in this country. Most universities are doing crystal growth. There are 100 universities doing crystal growth, but variety of crystals, small crystals for PhD work. Industry size, there is nothing.
I think you missed it. 6M is setting up an integrated silicon carbide capability that includes in-house 8-inch silicon carbide PVD crystal growth capability.
That I am aware, sir. Silicon crystal growth doesn't exist.
This is a compound silicon. I think we're going to replace silicon. Isn't that right? Okay. I was just kidding. There was one question from here somewhere. One last question. Okay, can I have one last question? Thank you. Thank you for the very insightful discussion here. My question is for the two eminent academicians here. The technology for this entire semiconductor ecosystem in India, technology and the process is one thing. Second thing is the trained manpower. I think the training per se, but the manpower per se, technology of semiconductor is very much limited to the elite institutes of India. So the challenge is pretty much there. So what is your take on what should be our strategy in order to address this gap? Is the question for Shripad or for me? For both of you. Okay, I'll say Shripad take it first.
As I said, we have been producing a large number of MTechs and PhDs in area of semiconductor technology and chip design, right? For chip design, a lot of our people have stayed in India and done design. But for semiconductor technology, manufacturing and so on, the people have gone abroad to Singapore, Taiwan, TSMC and so on. My own students are abroad, many of them. So what we are saying is now, there is opportunity for all of them. You are probably talking about skilling at lower levels, diploma and so on. Is that what you're saying? This entire value chain requires. Yes. Quickly answer your question. There are three parts to that entire value chain. There is design that can be done in almost any college if you have access to software. Then there is the fab, which I agree with you is difficult. And even if you take the US, these fabs are present only in a few select universities. And in India, they are present in 6 IITs and ISC. And anybody in India can access these fabs through the Indian Nanoelectronics Users Program that MIT funds. And the third part, which is the interesting part, is systems integration. Now the chips are getting available in India, and all IITs, etc., have good electrical systems, for example, at least for power, if not RF, systems capability. You can now start doing a lot of system device co-design to make much more efficient, high-performing systems, and that's something you could start thinking of. So device system co-design is a big thing that's coming up.
As a follow-up question, should we have any policy-level intervention?
Sir, I think we can take this offline.
The time is.
Let's give a big applause to our panel. I think we've had a wonderful discussion. Thank you so much.
Well, the time just flew. We couldn't make out time. It was such an interesting discussion, and I'm sure the panelists will be there offline, and you can pose your questions to them. So thank you very much. Let's give a round of applause, and we'll also thank Professor Srinivasan Raghavan for moderating this all-important session. Well, ladies and gentlemen, we now move on to the next important session, which is a fireside chat. We have been a witness to several interesting fireside chats since morning, but right now this will be a different display altogether, because what we see on our screens every day, the smartphones to cutting-edge TVs, this is a fireside chat which would throw more light onto that. And interestingly, this fireside chat will be moderated in such a way that it will be easily understandable, and we can also get the feel of it. The session will be moderated by Mr. Harit Joshi. So, ladies and gentlemen, I would request you not to crowd in front of the... I would request all of you, sir. Stage, kindly move to the side wings. That will be helpful so that it will not be disturbing for the delegates of the next session. So I would request all of you to kindly either be seated or move to the side wings. I would straight away request Mr. Harit Joshi to kindly come over with more than 25 years of entrepreneurial general management, product development, and several other experience. Please come, sir. He's currently the president and CEO at Omniply Technologies, working on sticker electronics. Ladies and gentlemen, give a huge round of applause for Mr. Harit Joshi. Sir, I would request you to kindly clear the way here, please. The esteemed panelists, I would like to call upon Mr. G. Parameshwaran to kindly come over. Mr. Rajeshwaran. Mr. Rajeshwaran, are you there? Yeah. Put your hands together for that. Sorry for that. Professor IIT Madras and Director and CEO of Gainful Technologies. You were blocked by the crowd, so I sent them away. That's the reason. Please come over, sir. Take your seat. G. Rajeshwaran is the Professor at IIT Madras and Director and CEO at Gainful Technologies. And In fact, he was elected as a Fellow of the Society for Information Display for pioneering contributions to the development, manufacturing, and commercialization of AMOLED displays. Welcome to you. And our final panelist is Mr. Abhijit Kotnis. Put your hands together for Mr. Abhijit, a seasoned professional with a strong educational background and extensive experience in the display and consumer durables industry. And he has worked with several prominent companies, and a very hearty welcome to Mr. Abhijit. As we are slightly running behind schedule, I will straight away hand it over to Mr. Harit Doshi. It's all yours. Over to you. Yeah, the mic is working. Don't worry. Yeah. We are able to hear. Go ahead. Go ahead.
Good afternoon. Really excited to be here. How many people here have smartphones? Pretty much everybody, right? How many people here can live with the display, with the latest phones today, or even the next generation phone, but take a display from 3 years ago or 5 years ago? Anybody? I don't see any hands raised. So display is really changing how we consume information. It's really become a centerpiece, especially for the consumer electronic devices of today and what's about to come in the future. But not just that, automotive sections, whether you're looking at the latest cars and what's anticipated in the future, it's really changing how we are interfacing. There are display technologies that are enabling whole new electronics devices that previously would not be possible. So I'm really excited today to have this esteemed panel. I have a lot of experience with display and related technologies. And the focus of the panel is going to be on a couple of different areas. So why displays? So I talk a little bit about why displays. And then why now? And why now for India to start working on actually display manufacturing. So with that, I'm going to actually pass it on to Mr. Abhijit for some of the questions, and what we'll do is I'll start off with some of the questions, and then we'll also take some questions from the audience. Before I pass the question, I just want to say that today about 10% of the displays that are manufactured in the world, so it's about a $150 billion display market. $15 billion of displays are consumed in India. But pretty much no display manufacturing exists here. So one of the companies that's actually building a lot of products using displays is Dixon. So Mr. Abhijit, if you could talk a little bit about your background and what Dixon's doing, and especially about the tremendous growth that your company is seeing and how that's relevant to what could be possible on the display manufacturing side.
Thank you, Harit. Displays particularly touches everybody's life. We use smartphones, we use televisions, automotives. Everywhere you are seeing displays.
अरे मैं ये वो गया ना मैंने उसका ले रखा है यार.
Just to begin with,
मेरा कैमरा तो उस पे लग रहा है.
last 5-6 years,
मेरा कैमरा पहले वाले पे उधर जो पहले बोल रहा था. लगा दिया हटा दे.
There has been a huge interest of.
अरे मेरा कैमरा वहाँ उधर वाले पे था लास्ट वाले हो गया तो नहीं काम हो ना.
Companies, contract manufacturers have really got tremendous opportunity to scale up their productions, build up the ecosystem. One of them is my company, Dixon Technologies. Yeah, we are the one of the top companies who are leading in consumer electronics field, particularly in smartphones, television sets, laptops, and many other components which also do not have displays, but like telecom devices or medical electronics, etc. When we started, and of course there have been a government support all through long to have this growth. The PLI schemes, which was introduced by the government, has been really a success story, particularly in case of mobile handsets and now laptops as well. When few years back, India was not producing any mobile handset here. And in the last 5 years, 100% mobile production has moved to India. Okay, whatever
the policy of the government is clear. Whatever has to be sold in India has to be produced here, okay? And that has given a company, domestic companies like Dixon, a lot of thrust to invest in the ecosystem, bring a lot of manpower, getting them trained, bringing the Chinese. See, today, mostly smartphones are made in China. So all these Chinese companies who are selling phones here are now produced in India. So that has helped us a lot. And the same is being replicated now in the new ECMS scheme, which the government is just about rolled out. And one step backward, that is the component manufacturing for these finished goods. So that's the step-by-step approach by the government. And I think with this, the ecosystem in India is definitely going to grow, and it will help all of us here. Thank you.
Thank you. Next question is for Professor Rajeshwaran. You know, if you can talk a little bit about, you know, your background, because I think one of the things people may not realize that you did some of the pioneering work for OLED displays back in the day when people may not have fully realized what OLED displays are going to be. And even, I remember 10, 15 years ago, when you went to some of the biggest display conferences, people didn't believe OLEDs will ever happen. So if you can talk a little bit about, you know, what the pioneering work that was done at Kodak and the history of OLED, and then also the work that you're doing at IIT Madras on the pilot line.
Sure thing. Can you hear me? First thing, I've been in the display business for industry for 30 years. And before that, I was in the LED industry in the US. And before that was solar. So wherever light comes in or light goes out, those are the types of things I do. These days, I'm doing the same things in IIT Madras, because my hometown, and I'm got a laboratory that I've set up with the help of the Indian government. So trying to bring display technologies, which is now a $50 billion industry on OLED. When I started the industry and made the first OLED display, industry was zero. So you know how it is to start a new industry. You don't have a market, you don't have manufacturing know-how, and nobody believes you, so there's no finance. That's where you started. So I made my pitch to the CEO of Kodak, who fortunately was the previous CEO of Motorola. He knew electronics, and he had moved most of the stuff. He was competing with the Chinese competition at the stage. So to him, it was very clear to him, and I said, Mr. Fisher, can you give me some money to do R&D? Because we have invented something called OLED. The two of my colleagues, who are in line for the Nobel Prize anytime soon, are they interested in the management interested in taking it to market? And they're giving me that job, can you give me some money? So he gave me $15 million and 2 years to show me a real working display. That was in 1995. Then I joined the OLED program along with the inventors, and the job was very clear. Demonstrate real display, because we didn't know what it was for. We invented something. Initially, we were thinking it would be a good LED program with organic light emitting diode. The whole program came about because my colleague, Professor Ching Tang, made a very poor solar cell, and it emitted light. So they'll be discouraged if any other researcher, he decided to understand what the heck is my solar cell emitting light. So that's where we started. That's my background, all the way from the research labs in one of corporate America's good chemistry lab, to begin to understand how do I take this to production? How do I commercialize something that's a curiosity in the lab into something possible? So that's what I've been working on for the last, it took me about 6 years to make the first OLED display. The device had been invented much earlier, in 1980s. But for 10 years, we built a lot of patent portfolio in Kodak, and I was part of the management team there at the time. And that was with that background of intellectual property and basic patents, we were able to launch a program, international program, and at one point in time, I had about 500 people around the world working on making an OLED display. Now, one thing very clear, there is no much difference between OLED display and LCD display like we make it out to be. Everything depends on the backplane technology. The more complex the backplane, it's necessary for OLED. But the carbon, it's not like a new technology, OLED. So what we do, we use the infrastructure in the market. At that time, in the 80s, the IBM PC, notebook PC was already there in the market, driven by thin LCD panels. And that infrastructure was in Japan. So we started out from Rochester, New York, by going to Japan and making partnerships with somebody who had the technology to make backplanes. So that came about because there was an infrastructure, there are people with know-how to make the backplane technologies, but that was not sufficient for OLED. It was very sufficient for LCD of IBM PCs and the Toshiba PCs of those days. But the fab size was a generation 2, and we'll talk about that a little bit more. But that's how I got into the display business. Now it is, product size have gone down actually. The whole display industry has gone up in product size manufacturing because of television. That's been the holy grail of flat panel displays. So fabs became bigger and bigger until you need a multi-billion-dollar Taj Mahal of a factory to make a TV. Remember the one thing, and when you talk about quality, displays for commercial displays have 0 defects. Nothing is, no defects allowed. If you have 1 million pixels, there should be none. So it's not very forgiving as of customers. So you have to develop, as I said, a market pull, which is very important. Television was our market holy grail at that time. And we need know-how, which means you have to learn, do some R&D. If you don't have it currently, you have to work on it. Otherwise, you don't get any benefits, which become a $50 billion industry. So you have to do all of that stuff in order to grow the business. Now I'm enjoying my life after retirement at IIT Madras. I'll tell you more about that later.
Thank you, Raj. It's interesting how long it takes. Definitely deserve an applause for that. So, people don't realize, like, one of the pioneering work that was done almost 35 years ago on OLED, and that was actually recognized at Display Week, one of the larger conferences a couple of years ago. And one of the challenges of the display industry is it takes decades from the time you first start working on a new technology to the time you commercially see it. OLEDs, I remember even in early 2000s, when you go to these conferences and people present the technology, they'll still talk about it's never going to happen. And then it took even 15 years after that before you start seeing the right application for OLEDs in smartphones that LCDs actually couldn't compete against. And LCDs actually fought really hard to stay relevant. And if you look at the history, the LCD technologies have improved dramatically from where they were just to be able to compete. So, Abhijit, my next question is to you. We talked about 10% of the displays are consumed here in India. And, you are one of the biggest EMSs in the world in assembling products for the end customers, including smartphones and televisions and some of the very top brands. Displays really become a big differentiator. If you look at the history of big brands like Samsung, Sharp, even Sony, they were making great devices because they were able to make some differentiated components, including displays. So what's your thoughts on India's roadmap on the display fabs and what needs to be developed and what's needed from the ecosystem perspective?
Yeah, thanks, Harit. See, as you rightly gave some numbers that the global market is around 150 billion US, and India consumes about 15% out of it. So it's a large number still. And unfortunately, we have to depend on mostly China to get the TFT LCDs or the OLEDs right now. But, we are moving in the right direction for sure, because the first step is to bring the finished products. See, earlier, 5-7 years back, even these volumes which India is doing now were not being done here. The first step is bringing the volumes here. To give you a number, India is a market of 150 million smartphones a year, roughly, 150 to 170, depends. Now, out of this 150 to 160, almost more than 120 million or more, even more, is produced in India. So we have been right in the first step itself, right? The second step is, of course, the government incentivized it by the PLI policy. And it has really was a game changer for the industry, right? So, and everybody has got harvested that. The second step is the ECMS scheme, which is recently rolled out. One step back, invest in components, okay? So components means the display, the memory ICs, the camera modules, whatever is needed for that. You know? It's very comprehensive policy. So I think by end of September, it's the deadline to close, and that will be rolled out very soon. So that's the logical next step. A step forward could be going in for a fab. But yes, for a fab, it's a different ball game altogether, okay? Definitely the government has been kind enough to roll out the ISM 1.0, and ISM 2.0 is also in the pipeline. So with the support of the central government and also the state governments, definitely the Indian companies or the global companies have a lot of big opportunity going ahead. Of course, to have the fab in India, because the investment and the capex is humongous. So for that, we have taken the right steps. I mean, we have seen recently now the exhibition is of Semicons. There are so many Semicon companies who have started investing in India. So the infrastructure is getting ready. Of course, first of all, for the fab, you require uninterrupted power. Secondly is ultra pure water, the gases, the materials. So we have to bring all the global players here and build an ecosystem around India. What the government is supporting is building logistic hubs, giving lands, giving a lot of fiscal incentives. Whatever is required within the country, yes. Right? And we are seeing global companies coming into India, investing here. So I'm sure in a couple of years' time, this is going to definitely grow up. So I think we are going step by step. We are not rushing into just fab because, of course, you see globally now China controls almost 70–75% of the fab capacity, right? The Koreans, Japanese are almost have given up almost. OLEDs, yes, they are doing something, but for TFT, LCD, they have almost given up to China. LCD, TFT, right now, the capacity in the industry is overcapacity, right? And it's quite a cyclical business. So we have to keep a balance between all these things. And looking at the consumption growth in India, definitely the fab with the ISM2 support is definitely an in thing. We have to just see who and when will take the first step here. But I think the infra and all the requirements are getting ready. And I think, Harit, we are going in the right direction right now.
Yeah, you mentioned a lot of interesting points. And I would say, you know, there are some synergies between like semiconductor fabs being set up and displays because some of the requirements are same. And if you look at some of the, you know, the exhibitors here, they supply into both the semiconductor world and display world. So there are some synergy, even in the equipment side, there are a lot of players. So I think one would hopefully help the others, the semiconductor side on the display side. So maybe shifting gears a little bit and talking a little bit about technology, Raj. So obviously, there are many different display technologies. Obviously, I'm not going to go to CRT because we don't have time, but let's talk about, LCD versus OLED versus micro LED. There was a time when OLEDs were really picking momentum. People said, oh, okay, LCDs are going to be dead, and obviously we don't see that today. And one thing we realized is it's not the old world where LCDs actually killed CRT, and now in the new world, you'll see multiple technologies coexist. But from your perspective, what are the differences, pros and cons, and what should be the roadmap for India in terms of, fab development, LCD, or different display technology development?
Okay, so I learned through life that whatever the question is asked, you talk about what you know. Okay, so I'll continue just so the audience doesn't think I'm only a technologist. I started as an R&D scientist in the lab, But the industry is here because of manufacturing technologies that got born on the way to make the market capability, et cetera, et cetera. One other thing is, please, all of you, take home one message. OLED is not that different from LCD. How do we develop OLED? Using LCD fab. Okay, so you need an improved LCD fab to make OLED. So they're basically back planes and there's front planes. So when you say technology-wise, it is LCD, OLED, and micro-LED, they're just a tip of the iceberg. The technology lies under the surface, which is the TFT, types of TFT technology that you have to develop. And that's where all the billions of dollars go, not in the front plane at all. So we can always invent front planes which emit light. So the LCD is a voltage-driven technology, much easier to drive with underlying electronics. When you go to OLED and say micro-LED as an example, micro-LED, they are current-driven devices. When you have current-driven devices, you need to have perfect control over the current, voltage and current, to control the grayscales of the display. So remember that when we got to the SEMICON, the display technology actually is the semiconductor that you see. In the gadgets that you make, all the silicon semiconductors are inside. You don't see them. But you always talk about what is inside. But you look at everything on a display that is outside semiconductor. So irrelevant, it's not irrelevant to semiconductor. It is, the session was called Display Semiconductors. The display itself, in the case of organic LED and the backplane, they're all semiconductors. In the case of LCD, it is not. In the case of micro LED, it is another semiconductor, gallium arsenide, gallium 3,5 compounds. So, to your question, just to answer, make sure I answer his question, always in life in the display industry, there's been two major dominant technologies. The second one is always trying to do the first one, how to do the other one. If you don't, you get eaten up by the third one that is always behind you. So the $150 billion industry is talking about, it's all between LCD and OLED today. In our expert opinion of micro LEDs, it's still another 5-10 years ago, a lot of problems to solve. It is not as a manufacturing technology, it should be in the R&D phase of solving those problems. So basically, Abhijit and myself, we only talk about LCD and OLED today because if India needs anything in the next 5 years, that's it. It's not going to be some new technology, and the OLED has not gone away. Did I answer your question?
No, you did. You did.
Okay.
And I think there's not a simple answer because, you know, it depends on the application. It depends on
that's
where
another point.
you're.
Good point. See, the why they have not grown in each of their segments, LCD is suitable for all the IT products and TVs. So it covers a larger customer base. And the base is also growing. And it entirely depends on the supply. Now the oversupply of LCD fabs in China, they're able to take over, and it's no longer cost effective for the Korean guys or the Japanese guys. So it's moved. But OLED is occupying the bottom, which is smartphones. It's absolutely suited for that. Plus it's flexible, you can roll and fold, all that kind of stuff, which LCDs cannot do. The other one is OLED TVs. OLED TVs are also at the top. So it's a percentage, say 5% to 10% of big TV market is OLED. Now, what is happening is technology is moving, so materials are getting better. So we will move the OLED from mobile phones to the notebooks and tablets and others coming. So the combination of backplane and front plane is the important criteria here to determine what will work in a system solution. So OLED is crawling into the IT space, and cost down of the OLED TV will bring it back into contention on the other end. So that's the main fight you can see in the next 5 years on the top-end displays in LCD and OLED. So their ratios will change, but the market is growing.
Thank you, Raj. I think we're short on time. I don't know if there are a couple, if there's any burning questions from the audience. Maybe we'll take one.
I think we can take it offline, sir.
Okay, so maybe we'll take that offline. I just want to just ask a quick question to my panelists here. If you had to predict where India's display fab is going to be in 3 to 5 years, I'd like each of you to maybe, I know this is hard at this point, but if you can predict, you know, what do you think, where you think India will be in 5 years from now on the display fab side?
Yeah, Harith, we are quite positive. I think there's a tremendous push both on the infra, on the fiscal side, a lot of support on the capex from the state as well as from the center. So I think definitely we should see at least a 8.6 to 10 generation fab very soon. I'm very confident in the next 3 years' time we should have in India. I'm pretty sure.
Thank you.
Yeah, I agree. So I think in the next, I was mentioned the 3 to 5 years before, what's going to be in the next 5 years.
Yeah.
It is the same kind of flavor of technology in production. We want production technology, not more R&D project, which is also important because there was some point you want to discuss on R&D. Absolutely important that don't build production technology today and expect you'll be competitive unless you do some portion of that in research and development to improve the current technology that you have gotten into production. So I think there'll be fabs in India, and hope that I've seen this for 30 years, so don't worry about 3 to 5 years. Once it comes, it won't go. It'll stay and create jobs.
So with that, let's thank the panelists for a great discussion.
Yes, please give a round of applause. Yeah.
Thank you.
Thank you very much. As already indicated that any of the questions can be posed to the panelists after this session once they come down. But sincere request to all the esteemed audience not to crowd in front of the main stage so that it will be difficult for us to go through with the next session. So thank you very much. Let's give a round of applause for Mr. Harith Joshi, Mr. G. Rajeshwaran, and Mr. Abhijit Cortes. Well, ladies and gentlemen, we now move on to another exciting session wherein we move forward with regard to semiconductor product creation. Now, this session will delve deep into transforming cutting-edge semiconductor innovations to scalable, market-ready products, which at the end of the day, this is very important in terms of market-ready. It's a critical aspect of the semiconductor ecosystem that bridges innovation with real-world applications. So, as per what we have been doing, we start this all-important session with a keynote. So please put your hands together for Dr. Randhir Thakur, the CEO and Managing Director at the Tata Electronics. Hari, welcome to you, sir. Well, in the interest of time, straight away I hand over the session to you. Take us through. Let's take it away.
Good afternoon, everyone, and welcome to this session. I really want to thank the organizers and especially the ISM CEO, Mr. Amitesh Sinha. When ISM was first started a few years ago, he was there, started it, he went to do a few other things, and now this year he's back with a bang. So a lot of the enthusiasm and what we see happening in the show has been foundationally laid out when he was the ISM CEO. And I see many familiar faces, colleagues from the industry. Welcome to those came from abroad, welcome to India, and those who are in India, welcome to this session. I thought I will lay out what really is happening and why the product level, the manufacturing excellence, the manufacturing hub of semiconductor is crucial in India. There are 4 driving factors. We all know and living through the tension inflation. There are countries, wars going on, tariff surplus. This is happening everywhere. You know, we turn on the TV, there is tariff. Trust deficit. Nations have problem with each other. There is that lack of trust, what used to be, in order to really have a thriving supply chain. And lastly, technological warfare. We see that some countries are more privileged, have the capabilities, and others are denied. We are in the midst of all these challenges. In all of this, semiconductors are playing a key role for any nation, both for the national security as well as for the economic growth. because it fuels a lot of what goes on in the products, what goes into our consumers. So it becomes a critical part from many angles, especially the sensitivity became very high after the COVID situation globally. Semiconductor supply chain is dependent on, because that's how structurally it was laid out. When first the semiconductor started in early 60s, what founders in Intel, Bob Noyce and Gordon Moore had thought were the legends of this industry, that we want to design the chips in America, we want to make the factories. But as far as the packaging and other part, in those days was concerned for the CPUs, let's just move it overseas. So all of that came into Asia, but most of the design and the fab capability stayed in America. That's kind of how the industry started. But over time, it shifted to the right from me. The US part more focused on fabless. That's where most of the design became more pervasive. Some manufacturing still left. About what used to be 40% at the peak for United States is now in the 10 to 11% range. Most of it moved to Asia. Europe played a critical role because of mainly the materials innovation, some of the critical equipment. ASML, you may have heard about, a very crucial company for chip making, is in Europe. And then we come into Asia, we see that a lot of the packaging related activities, material related activities were developed, and they grew up in Japan, China to an extent, and Malaysia, Singapore. So that has been kind of the total lay of the land as far as the supply chain for electronics and semiconductors is concerned. India, I think, has been, and this is often overlooked, but in the whole supply chain, the talent from India has continued to play the role for decades, be it in the design or be many of the folks from India going overseas and contributing and being part of the semiconductor industry. So that kind of gives you the picture. If we look at the opportunity for India, you see, starting from one end to the other, whether it is the lot of the design or innovation, the products, they stayed in the United States. Then in Asia, a lot of the manufacturing in the area of red is manufacturing that is in Asia. And so the whole value chain is distributed. When we look at from India's standpoint, whether it is EMS space, it is packaging or manufacturing chips, because we are starting a little bit late, we have opportunity to go across the whole space. Nothing stops us from being in one segment or the other as the industry has been forced to distribute itself. So I see for India as a competitive advantage. We can be very open-minded and we can hit many points in the roadmap. The trends impacting the electronics market, AI has become very pervasive. There is more future there. There will be more demand. What is on the papers here, you know, who would have thought that a company like NVIDIA a few years ago was less than $10 billion for the year in revenue, is 40 plus billion in a quarter or something. So the way the growth happens, and this is really the magic of semiconductors, that things can change very quickly, mostly upwards. Sometimes it can also go down, but it is a sensitive space. However, the trends are so strong, whether it is in automotive or the pervasive connectivity. So the moat is there for us to, as country, to be able to participate in this space. Now, for semiconductor success, it is very crucial that you have an optimal combination of technology, capital, and talent. All three are needed, but any one of them is not enough. A country can have a lot of money, but if you don't have the talent or you don't have the technology, still cannot do it. So this is a complex industry. That's why I think the way we are looking at and what ISM has initiated to get the global players come in is very, very beneficial, because technology will play a key role. Capital alone won't be enough. and the policy of the country. I think that we all should be very, very pleased with the policy of Honorable Prime Minister of India, how he has visioned it and for the semiconductor, and the incentives have been provided in different stages, whether it is in the EMS space, where the country is now #2 in the phone manufacturing, or it is in the design space, or it is in the semiconductor space. In all of these areas, really what ISM and the country has done is tremendous for the new people to come in, break the barriers, and go participate in this space. But the optimized combination is very important. Government policy can accelerate this combination, and government has done its part, really starting with ISM 1.0, where many of us are beneficiaries of the policy, and as a result, there are things going on. Fabs are being built, packaging houses are being built, designs are being carried. So all of this is happening because the government has taken the initiative. And also ease of doing business. We know that there is a lot more to be done, but a lot has happened in the country. Some of the taxation policies are becoming very friendly. The states are participating in it. I think the Center of Excellences, whether it is through NILET, it's a lot of our IITs, all of those institutions are paying attention to semiconductor type skills. We ourselves as Tata Electronics are participating in many of the universities, working together with them. We are even defining the curriculum that is semiconductor dedicated. It is very specific in the manufacturing or technology area, and that is happening in the country today, which is crucial and something that would not have been possible without the government accelerating these policies. Just like cricket, I often give this analogy because this space is very complex. So there are 11 different critical areas. The good thing is the SEMICON brings many of these players today. You will come across, design folks are here, equipment people are here, material people are here, the folks from the infrastructure side. It's really the end-to-end design capability. So all of these areas are very detailed. They're very specific. I met some of the photomask companies here. So all of this will take for us, at least the first decade, we'll be getting all these elements, these different elements in a right configuration into the country. We won't be perfect. There will be some bumps here and there, but the key is the way the industry is committed and the way the government has shown leadership. That combination is going to continue over time to give us strength and be stronger in these areas. I think from the policy I see that we have to, as we carry from policy to production, the role of the industry and the government is kind of optimize its mix. There is capital and some other benefits you get from the government, but industry has to invest and do its part. Similarly, on the skill side, it is the institutions, the government, and the industry working together. On the trade, ease of doing business in the country, this is primarily to the government, but also we as industry will continue. And so these are all the combinations, different elements that will play a role. As far as the Tata Electronics, I'll just, for a couple of minutes, give you the overview. We started on the basis of partnership with our customers and partners. Doing the things that are in conjunction with collaboration with customers and partners. This really was Tata's and our chairman's vision that we want to make sure in order to make progress for us, we have to work collaboratively with partners. As a result, whether it is customer or it is of suppliers, we look to work with them very closely. Starting from the EMS space, going into OSAT, fab, and design services. These are the primary areas, broadly covering a lot of the pieces of the semiconductor. We are really privileged because as we look through the investment and identifying the critical opportunities, kind of gives you the integrated approach picture that Tata Electronics has. We start with the design. We have the fab capability being built. The packaging is already underway, and the EMS is in production. But idea is that over time, all of these capabilities are done in India. We can make sure that the right design optimization happens with the chip. The chip and the packaging interaction is there. The product, the final product that is built, and Ashwini Vaishnavji, Honorable Minister, has emphasized about product nation. It will take us these kind of integrated capabilities for us to get there. So this combination is in play as far as Tata Electronics is concerned. Footprint is large. We are privileged to have 70,000 people. 70% of them are women, and very, very excited about it. We are expanding, setting offices, but it is really about building the scale that is important for semiconductor manufacturing. We have to have scale. So it is difficult, but we have a great team. Many of the folks, the leadership team of Tata Electronics is around here. You can meet. But they are very busy, and the production efforts, the scale efforts are underway. Partnership, as I said in the vision, if we look at the last couple of years, we have customers committed for the fab, and they are, whether it is from US Analog Devices, Himax from Taiwan, to Bosch from Europe, and Bharat Electronics, our own India company. We look for the partnership with the customers where possible. Our other partners, PSMC, Martin Chu is here, the president of PSMC. We have a strong partnership because technology in this semiconductor business, it is challenging, and we want to make sure that we have reliable partner who we can work with. Similarly, the equipment and material players, we yesterday signed MOU with Merck, with C-DAC, and these are our critical partners, Synopsys, Tissot, Pegatron, SMPT. These are all companies, global companies, who are willing to work with us very closely, become our partners. And lastly, in the area of skilling and academic partnership, which a little bit also goes into innovation and R&D, we're working with the universities and national institutions to drive things forward together. I really conclude by saying that prime time for India Semiconductor, because when India can be and have the ability to have the building blocks and be a production powerhouse. I believe that the rising demand, just 100 billion, is going to be $500 million in 4 or 5 years for just the in the country demand. Innovation hub, we know that how the designs are done. Similarly, we will build our capabilities in innovation areas for semiconductors. The market access, I think the key is for us, the location is strategic, our policies are friendly, and ecosystem trust. We believe that if we look at the semiconductor electronic space, the customers have a lot of trust in India. Many of the nations have a lot of trust that in India, the ecosystem can build trust, that we will protect their IP, they will work with us together. So all of these elements are work in progress. The country has stronger policies. We need to, as the industry, carry them forward, implement, and as Prime Minister has said, speed will be the key. We have to move very fast in this space. And I leave you with that thought. Thank you very much.
Thank you, Dr. Adit Thakur, for that highly impactful address, and thanks for being here. Thank you, sir. Well, ladies and gentlemen, Dr. Thakur did mention during his presentation, during his keynote, about making India a product nation. In fact, the next segment of the session will be a panel discussion on making India a product nation. You would all agree with me that this will be a fascinating discussion, how India is transforming from a technology consumer to a technology producer, and how we can scale semiconductor innovations into world-class products. Well, we have one of the most respected personalities in our country to spearhead this particular session. He is, in fact, the co-founder of HCL, the chairman of the Mission Governing Board of the National Quantum Mission of India, distinguished fellow from Niti Aayog. So, ladies and gentlemen, please put your hands together and let's welcome on stage Padma Bhushan, Dr. Ajay Chaudhary on stage, please. He will initiate this particular panel discussion, and once he gives the initial opening remarks, I will call upon the other panelists later on. So, ladies and gentlemen, Dr. Ajay Chaudhary, a visionary pioneer, on stage.
Thank you. I think you heard a great speech and presentation from Ranjit. And what you would have understood from that is that Tata Electronics is really geared up to make products. But somebody also has to design products. And I think that is essential if we want to make India happen. So if I look at the history of the country, we've been terrific in making software services and engineering and design services. We've been a services country till now. I think the time has come for us to move to be a product nation. And the Honorable Minister talked about it, as well as the Prime Minister has been talking about making India a product nation. Now, to make India a product nation in semiconductors, there are few essential pieces that we must look at. What are our strengths in the country? Our strength is our brain. And so, what are our strengths? Our strengths are in design. While for the manufacturing and fabs, etc., we are creating capability. And there's a lot of work going on creating that capability. But when we look at India, what are our strengths? The strength is that 20% of the world's design capability sits in India. But all of this capability today is utilized to service the world. We really do not take this capability and design and make our own products. So I think the time has come for us to take a very strong view of what we should be doing to improve the value addition in the country. Our current GDP per person is $2,500, pathetic. While Korea and China are sitting in the 10,000 and 20,000. Why is that? Because our value addition in the country is quite low. So I think to improve on that, when ISM 1.0 was created, a DLI scheme was also created. And under this DLI scheme, funds were provided for design. And interestingly, initially people thought that not too many people will come forward, but definitely reasonable amount of people came forward for DLI 1.0. And when I started to look at some of those companies, I found that they were doing pretty good work. But I think where do we need to go now is quite different. Our direction has to be very strongly to start creating more systems to chip thinking. So if you don't make systems in the country, who will buy the chips? So you have to first make systems in the country. We have to make chips in the country. We have to then have a fab. Then we have to have packaging. But let's not forget the market. Unless we know what is the market, we cannot make products or chips. So I think this is the complete ecosystem that ISM 2.0, I'm sure Amitesh ji is here. We've had some discussions on this. This full ecosystem is what ISM 2.0 should attempt to do. Because if we create this full ecosystem, we will have some of the world's best products and chips being designed here. And I think once we make products and chips here, getting them to be made in the fabs and packaged here would be quite interesting to see. Now, when I started to look at what is happening in the design market and how many startups are doing various things, I got some very interesting results. Like, for example, Mindgrove Technology. Again, DLI-1 company. Okay, so they've developed a chip, very interesting product. They've also signed up with Bosch for their product. Incore Semiconductors. Incore Semiconductors, another damn good company out of IIT Madras. Sankhya Labs, everybody knows them. Morphing Machines is another interesting company that actually was funded by DLI 1.0. And they have an outstanding product that they have developed, which actually my fund, which is the IN fund, is actually funding. And I find that this is a great product that will get developed. Then, of course, there are many like this that I see. Netra Semi and a couple of other companies are there who are actually working on designing and making chips for CCTVs. So very critically, why is it that we need to have Indian chips in Indian products? Because if a Chinese chip sits inside an Indian product, all the data goes back to China. So I think it's very critical that we develop this industry and we develop products for India and we take them forward. There are many other great companies who are starting to make products for India. It's a start that I see. At this moment, there are 20, 30 companies only that are participating in making chips in India. We need to have hundreds of them. And if they have hundreds of them, then obviously the fab will get huge bunch of orders, which will be very valuable for the country. Recently, I read about a friend of mine, Shiva. He started a company called Hardwire, and he's now making a chip for boat. So we're seeing system companies and chip companies sort of coming together, and we will be having lots and lots of products like this happen. Interestingly, I also talked to my friend Amrit Manwani, who actually put up the first packaging unit in this country, which is a running unit. And he tells me that he has actually made a LED driver chip, which my foundation, Epic Foundation, and him worked together, and they've actually started shipping that product. So close to 1 million chips of driver LED chips have been shipped. So this is a great, great, great thing that's happening in the country, where products are being designed, products are being made, shipping is happening, and a lot of people don't know that this particular thing is happening, Sahasra is happening, because it was not part of ISM 1.0, it was part of pre-ISM scheme, which was again a very good scheme, MSIP scheme. I mean, you were there at that time. So I think things have happened and more things are happening, and today what we would like to do in our panel is to discuss how do we make India a product nation by designing and making products in India, and then making it for the country and taking them global. But one other piece that I want to definitely mention is that once products get designed in India, it's essential that the government business should go to those kind of startups who are making these products in India. This is how the US succeeded. The DARPA model was very clearly this. They gave a challenge to a startup, the startup made the product, and the business went to that company, and they grew. And initially, the growth took place with government business, and then they went all over the world. So this model will complete the virtuous cycle for us to be successful in making India a product nation. So may I now invite my panelists to come in? Sure.
Great start for this panel discussion without saying it goes. Now I'd like to call upon the panel members to kindly come over quickly. Mr. Kartikeya Joshi, the President and Head R&D at Minda Limited. Hearty welcome to you, sir. More than 2 decades of industry experience across various domains. Put your hands together for Mr. Kartikeya Joshi. Also, Mr. M.A. Johar, the President of CP Plus, an industry veteran, an electronics and telecommunications engineer, more than 30+ years of experience, and his legacy extends beyond business success. So, hearty welcome to you, Mr. Johar. I would also like to call upon Mr. Sandeep Gupta. Yes, Vice President, Central R&D and MD, India, Alpha Wave Semi-India Electronics and Semiconductor Association, IESA Executive Committee member, 27+ years experience in semiconductors and strong leadership background with perfect adaptability. Hearty welcome to you, Mr. Sandeep. And finally, Mr. Nikul Shah, the founder and CEO, Interstate Private Limited. He is a semiconductor entrepreneur with more than a decade of experience in RF. So hearty welcome to you, Mr. Nikul Shah. So in the interest of time, I would straight away hand it over to Dr. Ajay Chaudhary to take us through these sessions. Over to you, sir. Yeah.
Since you've already introduced the panel, I don't need to do that job. And I think we have a very, very terrific panel out here with different kinds of experiences. Some people who have design services experience, some people who make products, and some people who literally create products out of India for the world. So, to start with, may I request you to tell me, what do you think will make India happen as a product nation in semiconductors?
Thank you, sir. So I think from an Uno Minda R&D perspective, our approach is India first. And in India first approach, how we look at it is that we need to make technology affordable. And when we want to make technology affordable, there are two axes that we look at it. One axis is definitely import substitution, which to me is a great opportunity. The second is also to make products which are very specific to India. I personally believe that India as a market itself is a big business case for fabless semiconductor startups, and I'll give you numbers for it. So, and since I represent the automotive industry, if you look at the auto component industry itself, it is roughly around $74 billion to $80 billion industry. If we take out that revenue and boil it down to the electronic bomb percentage, we are still looking at an opportunity of around 10 billion. So I believe that for any number of startups to succeed in India, this is a big enough business case. I think what is important for them to realize to make it happen, which will be a mix of the incentives which has to be aligned. I think you talk about design-led incentives. In my opinion, the domestic value add equation in the PLI has to be further modeled to incentivize towards 100% localization, which is currently not the case. At the same point of time, the entire value chain, and again I come from an automotive industry where the lead time to launch a new chip is close to around 3 to 4 years. So the entire value chain has to be incentivized to make it happen. I think, in my opinion, if we do 3 or 4 of these 3 things, there is a great opportunity available for fabless semiconductor startups to make an impact in India. And in fact, as an R&D, we are already working with a couple of them. Thank you.
That's very interesting. So the automotive business is huge. And from what I understood, somebody told me that the total worldwide market for chips and software for the automotive industry could be anywhere around $1 trillion. So if that's the size of the market, it's a brilliant area for India to enter. But one thing that I've understood, and please clarify this to me. See, when I talk to people like Maruti, and I said, somebody wants to design a chip for you, they told me that I don't need chips, I need systems which are made, and then I buy those systems into the country. The chips are actually made for those systems outside the country. So how can startups get into that market piece? Because unless we get into that, see, you are already making those kind of products in India. But most of the other companies, the assemblies and sub-assemblies and products come from outside the country. So how can startups enter that market is the question I would like to ask you.
Thank you. I think it's a great question. And since you talked about Maruti, I think automotive is a very, very matured supply chain and value chain. And now I specifically talk about one of the startups that we are working with. So we do camera, and camera is basically a product system that we as tier 1, we manufacture and we supply it out to an OEM like say Maruti, Tata, Mahindra, and so on and so forth. The CMOS sensor, which is very integral to the camera performance, is something that is currently imported. We are working with one of the startups that is doing this CMOS sensor design in India. I think there are 2 aspects to it. One is the cost aspect and one is the performance aspect. So for example, if you look at from a Maruti perspective, or even for our perspective, important is that we hit the cost target. And at times it is difficult because this startup is competing with the global companies, and that's where I said that the government incentive has to kick in to provide that breathing space to the startup to grow its business. That's the point number 1. The second is the performance aspect. When you talk about an automotive industry, all the parts has to be AEC-Q 100 qualified. which is a very strict quality management system for part reliability. And it is a combination of the production system and the entire design, production, but more important, the reliability system that has to be built in, and it takes time. So there is around maybe anywhere around 2.5, 3 years for a startup to launch a product together with us to Maruti. The question is that how do you incentivize the OEM like Maruti, tier 1 like Uno Minda, at the same point of time, the startup together to make it happen, and so that we work together for this entire 3 years to deliver this system, which is, in my opinion, which will be a very good alternate to an imported product. So how do you make this entire value chain think long term over this 2.5, 3 years is where I think the incentive should be aligned economically by government, not only, and this is where I think this domestic value add has to be suitably modified to incentivize the entire value chain towards 100% import substitution.
Excellent point. Actually, Amitesh ji is here. He's probably listening again. But the point that I want to take a little further with you is that fundamentally what it needs is patient capital, correct, for startups. So that is something. Good news is that things like these have started to happen. Till now, it was the government doing DLI. I think the next DLI, which we have discussed with the ISM, is that they're going to take up a much bigger value per chip. Because today, the value that is provided is 30 crores per chip, and 50% the startup has to put. I think the way I look at it is if we really want to make a lot of medium-sized chips also, you need 100 to 200 crores per chip. And that provision, if it's made, on top of that VC funding comes in, then I think we can make it a viable proposition for a startup. Because otherwise, how will they work for 2 to 3 years creating a product without revenue? So that runway has to be provided to them. And I think that is a very important point that we need to look at to make sure that such things happen. And secondly, I think, pretty much what China has done recently, China has mandated that 50% of chips have to be Chinese in every product. Now that mandate is the kind of mandate we need in this country, because then Maruti has to start looking at Indian chips long term. And then they will talk to companies like you and other companies who are making sub-assemblies and products for them, and then the whole value chain will start to work. So I think that is essential. Would you agree?
Yes, absolutely. And I think the point that you made in your, I think, context-setting speech, that the initial demand of the government should be directed to these startups is, I think, is also a very, very good point, because for any product companies, what they need is an anchor customer. And some of these startups whom we are also evaluating, and for, say, for example, a camera technology, radar technology, an obvious customer is also government for defense. And if they get that as an opportunity with government, and then subsequently they target, say, for example, an automotive or an aerospace as an industry, I think that is also a good progressive way for a startup to be successful.
So I guess I was discussing this with the defense people also and with IDEX. And I had this discussion, and I mentioned something which I've been talking about for a long time. And I've said, the next wars will be fought with semiconductors. Right? And you can see that happened during this particular war. Because if we didn't have control over our own products and chips, we would have been in dire straits. Because we were competing with a phenomenal range of products from China, which were totally designed by them. But we managed our own. So I think that takes me to the next product, which is CCTV. CCTV is a huge, huge, huge market in this country. And I also heard about a very major contract that railways was wanting to buy, which is massively huge. What that means is that there is a great opportunity for vertical integration in the CCTV area as well. So I have actually been talking to a few startups who are wanting to make chips for CCTVs. And I'm sure that you must be talking to them also. So what do you feel we should do to make value addition happen in the country? And we should, which kind of, what should we do to make sure that the startups can actually start to make products and chips that are required for your industry?
Thank you, sir. I think I'll start with two things. First is that yes, CCTV industry as an industry evolving with a big pace. And the Indian companies, they have already started investing into the system, looking at the future of CCTV industry in India and across the world. We at CP Plus, if we give that, we started in about 2007. And first factory means we were the one who bring CCTV cameras to the consumers and to the domestic industries. And for premium products like project, as you said, railways, police, we've got about 140,000 cameras already installed in Delhi. 160,000 cameras already installed in Delhi schools. So those kind of big projects are coming, and now is railway coming into this for coaches and all. There is a need that the product should be completely indigenized, because if you see, the surveillance camera is the eye of any surveillance system. It has to be foolproof, no vulnerabilities, and for that you have to have the complete system in India. Looking at that, we have first controlled the software by ourselves through our R&D, then put in the factory at Tirupati, which was making about 1 million cameras. And after that, in last year, we invested big way, and we made the factory. We basically made the factory in Kadapa, which is with the capacity of about 2.5 million cameras in a month. And that is India's largest and world third largest factory for CCTV industry. Now, where we are lacking is, as you exactly said, that the company, the government has to say that the chips has to be Indian and all. That has already been implemented in CCTV industry. Through a gazette notification, PPO in 2023, MITI has given. And that's a very welcoming approach from the government of India and for the industry. Though we have a lull period for about 6 months, 8 months, and that business going down because of the policies and changing the design and all. But yes, now we are coming back again. And now that all the chips which we are using, in the process of redesigning of the complete thing, about 60–70% of non-electronic things we have already produced in India. The second thing which is left is that, and for which I am here with the industry, SEMICON industry sitting here, to put a request that yes, we can do that balance 30%, which is, as my friend said, that sensors and SOCs. If that could be available in India, we are ready to support, and we are there with all kind of factory facilities and all, to build up that and to manufacture that complete thing in India. So it would be an indigenized product. What action we have taken into this is that whatever components like housing, like your flash, your cables and everything, we have already indigenized. What left is sensors and SOC, which basically we are still importing from other companies like US, UK and Taiwan. We have already tied up with the L&T Technologies. They are designing a chip for us, which we'll get that. So probably, like it is almost 1 year now. And in about a year, we will have first CCTV chip, Indian design, first CCTV chip. And we would be the one who would be manufacturing the complete CCTV cameras with Indian chip. So that is what is our vision to basically make in line to the Honorable Prime Minister's Atmanirbhar Bharat, that complete indigenized product to give to India, which is secure, and with the core technology of CP+. We are specialized in that. Other than the STQC guidelines on which they are basically testing it on about 32 points, we have added 7 points, which is boot secure algorithm onto the system over and above that to make it more secure. So that is where we are heading to. But yes, urge the team sitting here that please help us in giving us the semiconductor so that we would be fully Indian.
That's a wonderful request, and I think people are listening here to make you 100% Indian. Tell me something, what's the total size of the market for CCTVs today in the country?
Sir, the market at this point of time is about 9,000 crores for India, and which is going to be in 2030, it would be about 32 crores. So growth of about 27 to 28% CAGR year on year on that.
So that's a terrific market. So I think one of the things that I mentioned earlier was that we need to go from system to chip to fab to packaging, and then of course the market. So if we identify 6 or 8 large areas like automotive, like CCTV, and focus on making everything indigenous, I think it will be a terrific strategy for the government to follow.
It would be
rather than, leaving it open for people to decide, go and make a chip. That doesn't work. You need to have a customer to make a chip, no? So if you are a customer, and similarly there are other CCTV customers, automatically there is a market for them domestically, and then of course everybody can go global. Because if we just look at Indian market, it's not good enough. We need to look global. And I'm sure you are also looking at going global.
Yeah, we are, because looking at the geopolitical situations worldwide, the whole world is looking at India as far as the CCTV industry is concerned, looking at the India to make the CCTV product. So CCTV, I think, would be the first product which would be give a feather onto the cap of that product nation of India. Yes. So CCTV product would be fully indigenized product as the product nation of India.
And a trusted country and a trusted product.
Correct,
which is very critical in your area.
Correct,
isn't
sir.
it?
Correct, sir.
Yeah. So I think the Honorable Minister also talked about trusted product and trusted country. Prime Minister also talks about trusted country. So this trusted piece is also quite important for us to market globally. And I think if you look at the South, we have a large market, right? Sir, we chatted a lot on what you are doing. So I think when I was talking about the software industry, the software industry is facing headwinds today due to AI and automation. But a piece of the software industry, which is engineering and R&D design, which is really where you are, is not facing that. Am I right?
Absolutely not.
AI cannot make chips, right?
We are far away from that.
Yes, so I think you are in a very, very good position to be able to help the country create products in India. So I think, what do you think as a service company you would need to make chips for India? And what incentives are needed, what support is needed from the government to make it happen? Because you have all the skills and the capabilities.
Absolutely.
You have designed 2-nanometer chips, right?
Yes.
So there's no issue in terms of skills. And that's what I say. Our skill is phenomenal in this area, but we don't do anything for the country. So that's what I would like to ask you. How do we do it? What should we do? How do we have hundreds of fabulous companies in this country?
I think going back to your original question that you asked to Mr. Karthikeyan here, designing systems which use Indian chips, I think one very important factor, of course, we need government support in every step of the way. But let's say if now I'm from the industry, I've been designing chips for 25 plus years, I don't know what kind of a chip I should be designing. Correct. So we need to bring together, first of all, a platform where we have RFQs from various system companies requesting, these are the kind of chips I want to design. This is the market cap, that is the TAM and the SAM for a startup that they can target with the chips that they're going to make, the specs that are required. I think if that is an open system, sort of an Amazon marketplace, if you like, I think that will encourage a lot of people to come forward and say, well, this is the area of expertise I have. Now, what is happening is as you said, right, we traditionally became the back offices for the MNCs as a cheap labor source. Back in 2004, when I came back to India, we were doing very low-level work, verification. But over the last 20 years, a lot of people have come back to India, and we've moved up the value chain. We are independently designing chips out of India. These are not derivative chips, mind you. These are product chips where the marketing team looks at the market, global market, and comes back with a spec, and the Indian team is completely executing it out of India. Now, if we want to take these people and be able to design chips, they need to know that they have a solid play. And I think that is where that will help build the courage in the folks in the country to take that leap forward. And I think there's one subtle problem, which probably we do not realize. Software industry, as you can see, anyone can think of an idea. If they have the coding skills, they can put up a product. In semiconductors, to be able to put up a product, you need to minimum have 15 years of experience. And when I say 15 years of experience, you're at the age of 40, which means that you have a family to take care of. Your risk appetite is much lower as compared to a 25-year-old building a software product. So I need to have certain guarantees in life that I can put food on the table for my family, I can maintain my living standard. And for that, we need to have a certain guarantee in a way that yes, if I am able to build a quality product, it will be bought. I'm not saying build a substandard product. If I build a quality product, I need to be able to have a customer for it. As you said, as you rightly addressed, market is what we need to think about. That is what is going to drive innovation. There's no point making a product which no one's going to buy, right? So I think that whole mindset change that needs to be brought about in the industry, that yes, we can design products. We are capable. We are doing it for MNCs. We can now do it for India. And we can do it for the world. So this is more of a philosophical point that I'm trying to make, because there's no lack of talent. We are making, as I said, we are making 2-nanometer chips here in India, in Bangalore and Pune. We are making 2.5D 3D packaging chips. We just taped out with TSMC 3D chip, which is die-on-die stacked, the latest technology, 6 terabits of throughput between 2 dies. This is all done out of India. We have that talent. It's just giving them the right impetus, right focus. That is what is going to make it happen, sir.
So actually, the government has been pretty progressive in coming up with a semiconductor policy. And rightly so, to attract fabs to India was not easy. I mean, why would people come to India? And the only reason why people came to India was the kind of incentives that were offered. 50% of capex was phenomenal. I think the best in the world. That has got us fabs going. Now we need to get the rest of the ecosystem going.
Absolutely.
And I think if we really want value addition, we want our GSDP to improve, the only choice is design.
Absolutely.
We need to design products in India, we need to design chips in India, and then we take it to a fab. But the market part, as you rightly said, is extremely essential. And if we can guarantee market to start with for startups, hundreds of fabulous companies will
I have no doubt.
Because the biggest challenge is that it may take 2 years for somebody to make a chip. They need to last out. They need to have the money. And they need to have, we have to run a family. As you rightly said, some of them will be 35, 40 years old. So they're not going to be 20-year-old youngsters making a chip. So I think very critically, the market is a very important factor. And I think a virtuous cycle of, first of all, government giving incentives, and then government giving business, which is how the United States was created. The complete military industrial complex of United States has been created by DARPA by saying, here is a challenge, make this product, I'll give you the business. That is essential, and not giving 2 crores of business. 500 crore.
And guaranteed business over multiple years. Abhi, what I've heard is that the Indian defense does not give you a contract for more than a year.
Yeah.
So it's not guaranteed that you build the product and then the following year you're going to get that order.
No. There are so many other issues. If you get an order for 8 crores, you have to give a bank guarantee for 6 crores. So, those are all issues to be sorted out in the country. Those are things that needs to be done. But I think the country is changing and a lot of issues are there. But the issue of market and product is absolutely essential for the semiconductor industry to be successful.
Yeah.
We must make products and we must make chips, and that's how we'll add value.
Absolutely. And just, I want to address one more point that when you were talking to Mr. Johar about CCTV chips that are being made, and I think the concern that India has with respect to importing chips from a certain country, and now we are looking to source those exact chips from other places while we are designing our own chips, the same concern is with all the other countries in the world as well. So the market is tremendous wherever there is security involved, especially for not just CCTV, but drones and anything that is used in defense. So it is a tremendous market, and it's not just for India, it is for the world that we can design, and we can design cutting edge stuff. So I think having a clear understanding of what the specs are, because I can come and say, oh, I'll make a CCTV chip, but I need to know what are the features you need, what is the cost point, what is the timeline, what is the volume. And
that's it. You're the last, and you have the last word.
Yes, sir, yes. So I think I have gone through this journey, 12 years as an experience and then 2 years in this startup culture. So what I understand, what I learned is we need to create a cluster. What I say is cheap to product concept that you already mentioned about that. So we have to take a cluster, like one company is making chips, some already doing production, which company come forward, okay, this chip we will utilize, because we need to match the China cost. This is the main issue. If we are going to a customer for pitching, okay, please use this chip in your product or you can do trials. So they are asking us, how much is the cost of that chip that you are selling to us? We are saying X rupees. They are saying we are buying in X minus 10 or X minus 20. So why should we buy? We have to reduce our product cost. So this cluster if we create, then we have a volume. With the volume, any of the startup in this particular industry can take chip at least at that level of cost where people can afford that cost. Either it's 30% more or 40% more, but at least product company can afford that. So I think this is the first point that I can say. Second point is I am saying that fast to market we have to create. China is changing technology every year, every month, right? We are just still starting. So we have to move fast, we have to take fast. So might be in the DLI 2.0, if government will approve multiple projects for the single company, that single company can apply multiple projects. And if the investors comes upfront and say, okay, we are supporting you, and just build the chips, build the ecosystems, and the product companies come forward, we will replace these chips with the particular things, then I think this will be a revolutionary after 5 or 10 years. So this is my input overall.
So I guess the question I want to ask next is that, how do we make a Qualcomm out of India? That should be our dream. So what do you think we should be doing to have a Qualcomm in 5 to 10 years?
I think, as I said, that, I mean, if you look at Qualcomm also, they started, and I think many of the colleagues know it better than me, they started by looking at one specific industry of IoT. And then they grew from there, right? They started by looking at a product approach, and as the market boomed in, say, for example, in industrial or automotive, they started following a platform approach. And that is something that made Qualcomm what Qualcomm it is today. Furthermore, I think what is powering Qualcomm is the ecosystem approach that they have taken. But it is also at the end of the day, I think most of the leadership talent of the Qualcomm, if you look at, I think many of them are also Indians. So I think for me, the first step is that can we attract these world-class talent to make a Qualcomm out of India? I think that is the first question that we need to answer. And for that, I think we need to give them a roadmap that a similar ecosystem will be available them to develop out of India, right? I think, there are many stories that are already happening now that the expats technologies are returning back to India. I know it from L&T Semiconductor. I think that's one of the great examples. For me, I think that is one fundamental. The second is, and I can again tell it from an automotive perspective, that most of the global markets are slowing down, and India is the market with the biggest headroom. So if we somehow make sure that our local semicon companies, which will be supported with some bias by the government and industry, to make it competitive over, say, 5, 6, 10 years, I think, in my opinion, this is something that could happen.
So I think it's possible.
It's possible.
What do you say?
Absolutely. I think it is absolutely possible. Companies like Qualcomm, NVIDIA are disruptors in their own fields. When they grew, and basically they created a huge amount of disruption by thinking about the technologies of the future. And so we need visionaries, and as he rightly said, we have a lot of Indian leadership in the US. We need those visionaries to think up of products that we can build for the world. Because if I want to build an AI chip, which is going to be used everywhere, I need to be able to have the best goddamn GPU designers or neuromorphic processors. I need to have them in India. And so I think attracting talent back, putting a plan in place for that, I think if we just attract the talent with the right schemes, we'll have the next company, next Qualcomm.
I guess the point you made was absolutely valid. Ecosystem. If we create the ecosystem, people will come. Don't create the ecosystem, people won't come. And I think one other last question that I want quickly answered by any of you is that I've been observing that the whole world is around ARM today, right? There's been an attempt in India to do RISC. Should we pursue that or not?
I think absolutely yes. Look at China. So until RISC-V came out, so I was part of Sci-5, who were incidentally the creators of the RISC-V processor architecture. And the difference, if not everyone understands this, but ARM ISA, which is the instruction set architecture, is a licensed architecture. It's not open source. So if I have to build a processor which is based on ARM architecture, I have to pay ARM a royalty. And ARM, being a UK company, now SoftBank has invested, and now it's a public company in the US, but which means that if the US government or the UK government at any point of time decides that they do not want to offer this technology to any country, that country is host. And when RISC-V came up, China took it up as a mission, that RISC-V is the way to go. Today, there are probably 50 to 100 RISC-V companies in China, and they're building their entire software ecosystem around it. And that absolutely needs to be done to protect our sovereignty. Because it is an open source, nobody can stop that to us.
Yeah, just one small thing I want to say here is that we should have the consolidated approach. We should not have that packet approach that, okay, fab companies, these are the policies, these are the incentives, these are the design companies, these are the policies, these are the things, other manufacturing. So we have to have a consolidated ecosystem and vertical ecosystem, and
our thinking has to go vertical.
Yeah, and the government has to give whatever PLIs or incentive schemes they are announcing, it should be onto the complete chain of this. Yeah, that is how we can build up the ecosystem correctly.
I agree with you. So I think our time is up, but this was a wonderful discussion, and I think we've got some very interesting points that have all come up. We need to think big. We need to make a Qualcomm and NVIDIA out of India. And that's the thought we should take back and say, what is required to make it happen? And I think definitely we should do a lot more work on RISC-V. You know, That is where our answer lies, because we just cannot be dependent on other countries for technology. And for technology sovereignty in this country, we need RISC-V. Would you agree?
Absolutely.
Yeah, thank you.
Yeah, thank you.
Thank you, sir, for moderating this session. And let's give a round of applause, ladies and gentlemen. And thank you, Dr. Ajay Chaudhary, and all the panelists. We've got two more quick keynotes to conclude for the day, so request all of you to kindly stay back. In the next 20 minutes or so, both the keynotes will be over, and thereafter we can get back to our destination safely and securely. So request all of you to kindly stay back, because the next keynote will also be a very interesting one with two keynote speakers raring to go. Thank you, sir. Ajay Chaudhary and others to kindly move to the wing inside the room. No, so there's a room on the left-hand side. So the first keynote of the two keynotes is, the first one will be presented by Dr. Sandeep Kumar, the Chief Executive of L&T Semiconductor Technologies, India's largest semiconductor product company. Let's give a round of applause and welcome Dr. Sandeep Kumar. Well, yeah, in the interest of time, I'm straight away handing over to you, sir. Please.
Send it to Aditya.
Hello? So I think it was a perfect setup. Dr. Randhir talked about how he is creating a full ecosystem for manufacturing semiconductors. And then Ajay ji and the panel discussed an element of systems and how system capabilities needed and design and product capabilities needed. I think the journey is just beginning, and we are still a small drop in the ocean. Why I say that? Just to make sure we don't get too euphoric and realize that there is a long road ahead of us, is the fab that is being set up will cover, in the beginning, 2 or 3 out of 30 process nodes. So there's a lot of work to do to cover the entire spectrum. But you have to start somewhere, so it started, which is a great thing. Then we talk about 100 billion in semiconductor consumption in 2030. That is true. But 90 billion of that is going into products that were designed outside of India, whether it is the Apple iPhone or the server made by NVIDIA. So they are deciding what semiconductor will go into that system. That's one challenge. The second part is the 100 billion in revenue is coming from 10,000 products. So when we talk about even a camera, we talk,
Interestingly, we're working with CP+, we're working with Uno Minda, we're working with the other two. So, but when we talk about a camera, it has 15 chips in it. We only talk about the SoC. And it's an important element. And then we talk, but there's another array of chips. There's a power chip, there's a sensor chip, there is a image processor chip. So building that many chips requires a lot of companies. Because no, even L&T, we are planning to do many, but we are not going to do 10,000. And that requires a different approach on how you build that infrastructure. Earlier this week on Monday, we kicked off or launched a program that is supported, backed by the government, METI and others, and the state governments and national governments. How do we create 100 startups every year so that over a 10-year period, you are creating 1,000? And each of those startups will create 10 products. Now you are getting in that ballpark. Not everyone will succeed. Some will fail. That is the nature of that business. But that is the scale that is required if you want to actually become a product nation, right? That's what we want to do. As far as the system side is concerned, when we talk about a camera, we can still put our head around it, in the sense that the camera may have, you know, a $40 BOM, maybe even less, maybe more like a $20 BOM. Bill of materials on the semiconductor, that can be divided into 5 or 6 high value, and the rest you don't need to worry about. There are resistors, capacitors, diodes. So you can say, okay, we will design these 4 and create a complete bill of material in India. You talk about a car, automotive, it is 2,000 components, each of high value. It's $2,000 worth of semiconductor content in an advanced vehicle. And again, some of them are $10, but then some of them are 50 cents. So you have to take that and look at a subsystem and say, I want to start with this subsystem and see how we can analyze that subsystem and build that components for that subsystem in an ecosystem. And there are 3 startups, 4 startups, or big companies who are creating that. So that is the thinking. Another good good thing about this semiconductor, which sometimes we get scared because of lack of knowledge or experience. But if I build a chip for the camera, or I build a chip for the car, it has to be, you know, KJ at Uno Minda said performance and cost. CP Plus didn't say it, but we are working with them. We know it's performance and cost. So if I'm designing a chip that is best in performance and best in cost, then I should be able to sell it globally. There is no reason that it is only for the India market. In fact, when I go globally outside of China, I may actually be able to get a little better margin because the Indian market on cost is as, if not more aggressive than the China market on the price side. The only difference in China and India is China operates at 10% gross margin, so they can figure out how to drop the cost even though it's not a profitable product. So what I would say is, you know, as we try to build a product nation, one, I mean, we need to tap into the system, but take it a deeper level, right? And how do we build that complete system, the components for that, and create, enable, create, maybe the wrong word, enable startups or companies who will create that solution, semiconductor part. And then you partition the automotive and create that part. Now those are subsystems, unless you get to compute, that take $10, $20 million per chip to take from start concept to production. But out of the $100 billion Indian market, 50 or 70, 60 billion is sitting in high performance compute. That is a NVIDIA or a Intel or a AMD, and building a solution that replaces those is a $200 to $400 million commitment. But that is, again, so fine. So we are, as a nation, we are willing to commit $10, $20 billion towards establishing manufacturing. We should not shy away from committing $500 million to $1 billion and enabling multiple companies to build a CPU, a GPU, a NPU, a AIU. And each one will be 500 million, but that is still, so what? That is what it takes to capture actually 70, 80% of this $100 billion content that we are thinking India will consume, right? In general, in semiconductor, you know, the math is quite straightforward. A $100 billion market, whether it's served by us or by somebody, on an average will run 50% gross margin. Some GPUs will run 70 and some analog and, you know, RF smaller will run 30. 50% gross margin is $50 billion. That means that $50 billion a year has to pour back into designing the next generation. Only 10% is net profit. So, okay, 40 billion has to go back. To jumpstart that kind of system, you have to invest 30, 40 billion a year for the next 2-3 years until the products start rolling out. Okay, so you don't try to do it all in one shot. Let's not say, okay, I'm going to do everything, but then you take some bets. And my suggestion is to take the bets. Sorry, am I out of time?
Yeah, that's over.
So I would say we take the bets, we do a proper analysis, take the bets where the systems are being made in India, where we will be able to get through it. Within that, build the highest value areas first and as investment, because even though they are larger, because they will spread and sell globally, go to market globally. Those are the 3 points. Sorry.
No issue, sir. Thank you. We were, in fact, all of us were engrossed in that wonderful keynote by Mr. Sandeep Kumar. Sorry for the intervention in the interest of time, so don't think otherwise. So, ladies and gentlemen, let's give a round of applause to Dr. Sandeep Kumar, CEO and L&T Semiconductor Technologies. We now move on to the final keynote at the end of the day. It gives me great pleasure to welcome Mr. Aditya Ramakrishna, the VP of Siemens India and Head of Sales Digital Industries, and he has held various positions at Siemens and a great achiever. Put your hands together for Mr. Aditya.
Thanks a lot.
Allow yourselves.
Yeah, thanks a lot. I think in the previous panel, right, we heard a bit about talent and folks coming back to India, and I think I'm one of those examples. I've just moved back last year after 23 years around the globe, and 7 of those in Taiwan. And it gives me a lot of pleasure also then to see all this momentum happening here in India, right, with everything around semiconductors. Having stayed in Taiwan for 7 years, worked with all these big guys, and with Siemens, and to see everything which is happening in India is really amazing. So over the next 10 minutes, I'm going to tell you a bit. I mean, the title says Bridging Together the Real and the Digital World. And this is what I'm going to be sort of talking about today, right? I mean, how we as Siemens are helping all these initiatives, right, which is running out there to sort of take shape. How are we helping the fabs, the OSATs, to really produce with our technology, right from the first step of designing to the production, the simulation, and the automation. So this is something I'll try to sort of get across in the next few minutes. Siemens, first of all, right, it's big. I mean, there's a lot of stuff around Siemens, which Siemens does. Basically 3 big parts. First, around the trains, then a business around the infrastructure, and finally, everything around digitalization and automation. And it is especially this business which is enabling all these different initiatives around fabs, around OSATs, around the country to sort of start up, get successful, produce chips also, right? As you see, we as Siemens worldwide, we are working with about 95% of all fab and semiconductor companies, basically all of them, right? So from the top 30, 95% we are working with them. All the machines, so most of the machines which get also delivered into some of these fabs are with Siemens. So in fact, every 3rd machine is with a Siemens controller or is controlled by it, basically. And as you see, #1 in the industrial automation space and, of course, also in the software space. So we are well experienced also with semiconductor companies, with fabs, with electronics, and in this whole space to make companies not only all around the world successful. You've heard a lot about what are the challenges, right? And this is where we at Siemens also, we try with our global team to understand these challenges and try to help, of course, all the companies around here. I think in one of the previous panels, you also heard about this, right? The sort of different sort of architectures which are sort of coming up daily. In the meantime, also these 3D integrations and with the different layers. So this is a new way of manufacturing. And this is where also with some of our new design technologies, Mentor Graphics, for example, right, is a Siemens company where we are supporting some of these fabulous initiatives which also was spoken about previously. Of course, most of the companies also talk about this digital transformation, right? I mean, we are trying to drive this digital transformation, but where do you start? And this is where also we try to sort of handhold some of the companies to drive this digital transformation across. And finally, the major topic is, of course, energy, right? I mean, sustainability, massive topic, and semiconductor fabs are one of the most energy-consuming things at all, right? And this is where also, how can we as Siemens help some of these companies to reduce energy consumption, to become more efficient, and maybe to identify some of the topics which could become problematic later, maybe already at an early stage. So these are some of the topics we are looking at. And of course, also semiconductors as such, right? The manufacturing is also changing. It is no longer that you're sort of just as designing a semiconductor and the semiconductor is getting produced. It also varies by vertical or by branch where it is going into, right? So for example, a semiconductor going into automotive is also then designed, at least designed in a much different way. And here is where also with some of our domain experience, we are able to bring that in. Just another interesting fact, right? So we as Siemens, we are also a massive customer to some of these semiconductor companies, right? So we as Siemens, we purchase 6 billion electronic components every year. Out of that, 2 billion of them are chips, right? So we are also a massive consumer of all these. And this is where also we are bringing that experience. And of course, we are sort of looking at it is in 3 levels. And this is where, how do we make it happen? How do we support some of these customers to be successful in this step? And I'm basically looking at it around 3 aspects. So right from the design phase, and this is where with Siemens EDA, we have the complete solutions for that, to the production, so here also with the automation and some of the digitalization topics, and up to the supply chain. Why is supply chain so important, right, you may ask? And here, there's also several mechanisms, not only for the scope 1, but also around scope 2 and scope 3, where we are enabling with our technologies, some of the companies, to track what sort of scope 2, scope 3 emissions are maybe also being generated in order to have the better tracking of it, in order to also then in a systematic way make it better and reduce also these scope 2 and scope 3 emissions, right? So these are sort of the 3 steps we are looking at around this, across this value chain. Of course, in the chip design side, EDA, I will not go too much into that. I think there is a dedicated session around EDA tomorrow, so I would really recommend that session to you. However, around AI, I think also in one of the panels, there was the talk of AI, and here at Siemens, we are having multiple AI use cases, right? I think generative AI is a big topic. Here we are cooperating or collaborating with Microsoft, building industrial co-pilots, because what we also notice is folks who are programming a PLC, it's going to get much lesser also going forward, right? But at the end of the day, in every semiconductor fab, you do need PLCs. But the number of people programming are getting lesser. People just want to program it like you go to ChatGPT and program it, right? And then sort of write the code. So that is why we are developing industrial-based co-pilots so that also for any safety applications, all this comes out in a perfect way. So this is just one example around where we are using generative AI for programming, for coding, but also for troubleshooting, but also for service. We've got topics where from a remote location, we are able to sort of not only service a machine, but detect faults, but also have predictive maintenance topics to reduce the faults of some of these machines. So these are some of the topics where we are getting in, for example, with AI. I would like to also give a nice story around the production, right? And here is where also we do have experience with our own factories, where when we are, as Siemens, designing or even maybe replacing some stuff in our existing factories, we are having everything first in the virtual world. And this is the trend which we are recommending to customers actually across branches, be it a food and beverage company or also importantly, a semiconductor company, that you're building the factory, first of all, in the virtual world, and not only the factory, right? Not only all the processes, but also the machines, that when you're receiving as a semiconductor fab, the machines, you're already maybe in the first step receiving these machines in the virtual world first. So that means you're perfectly integrating everything virtually. You're making sure that all the processes are perfectly fitting before you even receive the machines, maybe even 12 to 18 months before, so that a lot of optimizations can be made before that. We are working at Siemens with multiple fab companies worldwide. Of course, I can't take the names here due to NDAs, but we are working with multiple companies to also implement such technologies. And of course, later, when the fab is running, what is also happening is you have the performance data. So with the performance data, you're also able to then optimize some of these plan, not only the machines, but also the fab around energy efficiency, just as an example, right? In order to then reduce costs and optimize energies out of that. So that is why this topic around digital twins is a massive lever which we as Siemens see to increase efficiency of these fabs and come faster to market. Just one example, of course, that is for our own factory. It is not a semiconductor factory, it is an electronics factory, which we are currently setting up in Singapore. And for this factory, the factory is going to start building in 6 to 8 months from now, but already everything is ready virtually. And although we did have some delays or some optimizations needed, everything is going to work out seamlessly nonetheless. And finally, this is how we see the future, right? I mean, from a pre-digital plant, which was maybe present some years ago and it's maybe not even there anymore, to the future, to the adaptive and autonomous plant, where we think till 2030, most of the fabs which are going to sort of come across or come around are going to be exactly that, right? Adaptive and autonomous. So already you see that, right? I mean, the other major challenge which you normally have in factories is these data silos, right? Where normally you have data in different silos, and when you talk about sort of taking data from these silos and sort of putting it on a layer where you're then really able to use it and do something with that data meaningfully, this is where then we also come into play with some of our MES topics and some of our other integration topics, right? So this is the future, and this is a journey which we at Siemens see. The future is this adaptive factory, and our factory, it's electronics factory in Singapore, will be basically this, right? An adaptive and an autonomous plant. And just to sort of close it off, I just touched upon it briefly, right, about the topic of sustainability. Semiconductors are really, really energy consuming. And this is where we are as Siemens actively working also in different semi-consortiums to make sure that we are actively sort of also putting our needs, our requirements, our points of view to ensure that global standards are getting created. In addition, of course, to some of the topics where we do like sort of analyzing these plants or having some of our energy efficiency equipment in the plants to reduce energy consumption with the help of the digital twin technologies. So that is why all in all, we at Siemens, we believe that digital technology, this digital twin, is the major lever for increasing the productivity of fabs and getting them faster on the grid and producing faster. Thanks a lot.
Thank you, Mr. Aditya Ramakrishna, for that wonderful presentation. So with this, we come to the end of the deliberations on day 2. Well, ladies and gentlemen, tomorrow the final day. Let's carry on the momentum forward, and do join us for the exciting and engaging sessions on design, product creation, startup ecosystem, international cooperation, ecosystem readiness, talent capital, as well as regulatory requirements. So with this, we come to the end of today's program. See you all tomorrow morning. The sessions will start at 9 a.m. Until then, all of you, please take care of yourself. Namaskar, and take care. And have a great evening.